Hello. Still eating dinner. Still eating dinner. Okay. Wait. I am still eating dinner, so it's gonna take a little while. Also, I need to update this, the ordering of this clock. Wait. Dun. Music? What's the music? The music is my music. The background song, yeah, they are my music. You can search for it in my channel, in my music channel. Right now it's called Zai World. I am gonna change the name of the channel in a short while because, yeah. I'm gonna, just a little bit of complications. What am I eating? Fish? Not really. I'm just eating rice and some, like, chicken breast. I'm thinking of just Zai the fish. Because Zai World is not really my name. You know, I titled it like thinking this is my world, so I'm titling my channel Zai World. But if I turn it into a YouTube artist page, then the name of the channel has to match the name of the artist. And my name is not Zai World. Like, World is not my last name, so yeah. I think Zai the Fish is kind of just a catchy name for an artist, because I don't think I've heard of a famous artist that like goes by something the fish or something, right? I need to change up the ordering of the clocks in this live split because I need to okay, I need to do ModularDiscriminant's clock first. Okay. So where am I? 222. Oh. Okay, so how many clocks do we have left? There are... Right. I guess it goes there. This goes like there. 2, 4, 4 goes there. 2, 4, 5 goes there. 2, 4, 6 goes there. 2, 4, 7 goes there. 2, 4, 8 goes there. 2, 4, 9. 250. 251. 252. Okay. That should be correct. So we started from 190 and we are just up to 220. So we did 60. We did 30 for 10 hours. We need 30 more. And we're going to look at modular discriminants. Bam. How do you control the limbs of the fishbowl? What type of fish are you? I am a robot fish. Do you live in a lukewarm ocean? I can, I think. Why is I so small in this thumbnail? Right. Wait. Is the thumbnail... Wait, what's the thumbnail right now? Okay. That's the thumbnail right now. Yep. Huh. 눕방하는 건가요? Will I do a second math clock contest? Not of this caliber. I'll probably have the rules be more strict so that people would have to submit less. I'll probably do it in my Discord if I make one, because the YouTube community system is kind of bugging out all the time, so it's not reliable. So I would hopefully do it in our Discord server. 달력 어떤가요? 그것도 좋습니다. I'm in Korea. I am at 8:53 p.m. right now. I'm almost done eating dinner. Wait, you cannot hear me? I think you can. You should be able to hear me, right? Okay. What type of fish are you? I'm a robot fish. I hear you, Cloud and Lear.
디스코드 서버에서 아직 계획이 없습니다.
Does fish food taste good? No, I'm on a diet right now, so it doesn't taste good. But I have gotten so used to it that I think my taste buds have left me, so I don't have any taste buds left.
마크 서버 열 수도 있고요. 다 먹었습니다. 나도 치우고 올게요.
I ate it. I'm gonna tidy things up and come back after brushing my teeth. Okay. Wait for a while. Okay. So let's look at the questions. Let's look at the question. Zai is not my name, actual name. Not my middle name either. Do you think water damages him? No, I can swim. I can swim. How did I come up with my profile pic? The logo it's a Android pattern lock-ified version of my older logo, which kind of looked like I don't know how I would describe it. It kind of looked like a kind of like a clover, but with only two leaves. That's how my logo looked like at the first. So I turned that into a Android pattern lock, and it became the logo I have right now. So like I can draw it here right now. My original logo that I used just when I was a kid looks something like this. Something like this, I think. Something like an infinity and then L, maybe? Infinity plus L? Yeah, because at that time my nickname started with an L, I think. I don't even remember. But then I made a pattern lock with that logo, and then it became this. Bam. Wait. Let's look at... There's a... Wait. I'm getting a message. Wait a minute. Okay. Before we start, this is the second half of the stream, right? I'm gonna be much more tired than the first half of the stream because it's 12 hours in. And I need some morale to continue, right? I need some good morale. Okay. Before I start, here is another intermission. It's an intermission inside an intermission. Okay. Intermission inside an intermission. And that is... I'm gonna play the piano. I'm gonna play the piano for a while. One song maybe. I don't know. What should I play? Let's see. I think... What should I play? Move that. Move that. Move that. Move that. Where's my pedal? Where did my pedal go? It's here. Okay. Okay, I got my pedal. And let's make it sound better. Which is by doing... What, Rushy? No. I don't even actually remember what the melody was. I've never practiced it. Okay. Where... What... 파이송은 뭐지? 파이송은 뭔지 모르겠네요. Let's just do some... I don't know. I'll just do some... Just some calming music to prepare. To prepare for another 12-hour stream. Thank you. Thank you, thank you. Okay, that was the intermission. Thank you, thank you. I'm a bit shaky from being tired, but yeah. I'm a bit shaky, but I think my morale has returned. Drink some more water. Thank you, thank you, thank you. Let's drink some more water. Why do I wear gloves? Because I am a robot fish. Does that make sense? So, we are going to return to the clocks. Bam, bam, bam! Time to suffer! Let's start up the music. Something... I don't know, maybe this? Yeah. Okay. How do I have hands if you're a robot fish? Yeah, I don't have hands, maybe. Yeah, that's why I wear gloves, to hide my non-existent hands. Okay. And now, we have a special guest, which is ModularDiscriminant, who is gonna be who made 6 clocks, and we are gonna be interviewing them and just going through the clocks with them together. Let's see. Okay. Bam, bam, bam. Let's start a call. And hello, hello.
Hello.
Hello. Okay, so this is ModularDiscriminant. They are also from Korea. And could you introduce yourself, maybe?
Okay. Hello, viewers. I'm ModularDiscriminant. I'm a undergraduate student in Korea, and my major is mathematics. So, thank you, Dr. Zai, for inviting me to your amazing stream. And okay.
Right. Thank you.
Really
Thank you.
appreciate you.
Yeah. Today, I mean, we have to look at your clocks. There are 6 clocks. I mean, you told me for a screen share. I mean, can I share your screen, and can I like have my clocks? I mean, can I have your clocks on my screen and share it to you? Maybe is that how we're gonna do this? Because I can share it like this. You can also share, and I can look at that too. If you can.
Can you share my screen?
Okay, so if you can see the stream, the screen I am sharing to you right now. Please tell me. If you cannot, please tell me. So
I can see your.
Right, you can see me going through your YouTube post right now. Can you?
Yeah, I can see.
Right. I think in that case, this is like supposed to be easy, right? These are just constants, so they aren't that hard. So I don't think I'll be needing your help for like the first few ones. So today we have the mathematical constants clock. That's the first one. Okay. By the way, I should start the timer again.
Can I share my screen?
Oh, can you share your screen too?
I just don't know how to share.
You have to click on the share screen thing on your Discord. So this is your first time with Discord, right? I think you just click on the streaming thing. Maybe. Yep. Yep. Then yeah, that's. I can see your screen. Yeah.
Okay. So this is my first clock. Can you see it?
Wait. Yep. This is your first clock.
Okay.
Right. I can see it. Yeah, I can see it very well.
But this is going fractal. Like okay.
Right.
I don't know. Yeah. Okay. So I kinda wanna explain
Alright,
the hardest constant. So yeah, for the easy ones, you can just explain yourself, I think.
Yep, I will try to explain this myself. Featuring modular discriminant. Bam.
Oh,
Okay,
thank you.
let's look at the integer part of. Actually, I can. This one, I think I'll just write down on my screen and just sharing with my viewers because
Yeah,
we have.
yeah, that's better.
Yep. So I studied all of this yesterday. Yesterday? Where is it? Where is all the constants? It's here. There are all the constants. Okay. So, first of all, the golden ratio, the integer part of the golden ratio is around 1.61 something. The integer part is 1. Bam. The golden ratio is important in like many mathematics, but I believe the viewers will be kind of familiar with it. So the integer part of E also the viewers will be kind of familiar with E. So I won't talk too much about it. The integer part is 2. The integer part, it's also called Euler's number here. Also called just the natural constant, and stuff. Yeah. The integer part of, we have pi. Wait, I forgot to bring the uncropped version. The integer. What am I seeing? The integer part of pi. Bam. The integer part of pi is of course 3. It's 3.14. Now we have some harder constants. So first off, we have the Feigenbaum constant, which is, and I learned this yesterday, it is around 4.6692 something, and it is equal to the limit of an plus 1 minus an divided by an plus 2 minus an plus 1, where these are the distances between bifurcations, that's a long word, of the logistic map. That's another long word. The distance between bifurcations of the logistic map. So, basically, there's this thing called the logistic map that is very important in chaos theory. It's something that should behave like something that looks really intuitive but behaves really chaotic. So, what is a logistic map? And if you like watched any of the popular math channels, you might have seen this diagram somewhere. It's like a very popular image. So this is a graph of some kind of function. I mean, it's not a function, but it's like some kind of like it's a function of something. Yeah, something like Veritasium. So what happens is that this comes from a very simple function, which is this. Xn plus 1 equals r xn times n1 xn, yeah. So this function behaves very weirdly when it gets taller and taller. So what this is you're essentially shooting a laser here that goes on, yeah, like that. Wow, that's dizzy. So anyway, the graph looks like it starts off as one line, then it splits off into 2, then it splits off into 4, then it's like really tiny, but then it splits off into 8, then 16, then 32, then something, something, and so on. It goes really tiny, tiny like that. So this is like, how fast is it? How fast does it bifurcate, like split? And how does this distance get shrink over time? That is what the Feigenbaum constant is about. This is the distance between the nth bifurcation and the n plus 1th bifurcation. This is the next bifurcation. So for example, it's this divided by this. It's also this divided by this. And this constant is what that gets closer and closer to. So that was Feigenbaum's constant. By the way, modular discriminant, you can like interrupt me at any time if you have something to say. Have something to share.
Thank you. Can I add one more remark then?
Oh, yeah.
For the Feigenbaum constant, you can also refer to the Mandelbrot set. So you can see my screen maybe?
Oh, yep. Mandelbrot set.
Yeah, in my screen, I'm playing GIF on Wikipedia. So the Mandelbrot set is a very complicated self-similar fractal. And yeah, its self-similarity is non-trivial, but it comes from the properties of chaos theory. And what you're looking at is the first tip of the left side of the main component. So it just goes on forever, and this accumulation point corresponds to the accumulation point of the logistic map. And so the ratio of the radius of each bulb is equal to 4.669. That is
these bulb, so this is 4 times as bigger as this, the length, right? Around 4.66 times or something. Yep, that's amazing. Thank you.
Yeah.
Okay. So the next one, we have the integer part of, and then this looks like a 2 and a W, but I heard that it's a form of pi. It's like a pi, but it's some kind of cursive or something. 2 pi. So what is this? This is called the lemniscate constant. Lemniscate constant. And the lemniscate is a particular curve that looks like this. It has 2 focal points, and the thing that defines the curve is that from any point on the curve to the 2 focal points, the product of the 2 lengths are the same. So if this is P, then the distance from P to F1 times the distance to from P to F2 is always constant. If you graph this, you get something that looks like this. And then this pi thing is the perimeter of this divided by the diameter. The diameter is just how long is it like horizontally. The perimeter is the length. So that's going to be this, and this is around 2.622 something. So the integer part of 2 of this is going to be 5.22 something, so it's going to be 5. Right?
Okay, can I make a remark?
Yeah.
In my screen, I'm currently showing you the database called LMFDB, which is a shorthand for the L functions and modular forms database. And you can search so many elliptic curves. You can find any elliptic curve here.
Right.
Like conductor, we can go to 32.
Wow, 32. A3, yeah.
Yeah, that just means that the conductor of this elliptic curve is 32, and the 3 is just an index. Yeah. And the elliptic curve looks like this kind of graph, and it is not on the ellipse, but it is just a cubic curve.
Right.
So in this curve, we have the real period, which is equal to exactly the twice of the Leibniz constant.
Right.
This happens because the elliptic curve has the complex multiplication phenomena,
Complex multiplication.
which is hard. Yeah, a bit hard to explain, but I think I should write it this way. Elliptic curve
Elliptic
is
curve. Yep, that's an elliptic curve.
Indeed a torus.
Indeed a torus.
Yeah,
It has a hole?
It is a torus. Yeah. It is a torus in some sense.
Right.
So when you look at this equation, you just need to come up with this graph, but it is a real model of the elliptic curve.
Real
and
modulo.
if you look
Okay.
at the comfort, I don't know the exact terminology, but elliptic curve over R, I say. Okay, over R, and if you see the elliptic curve over C,
Right.
then this looks like
Uh-huh.
a torus.
So that's like a
And-
4D
yeah.
like or 3D
Yeah.
graph version of the elliptic curve, something like that.
Yeah, I mean it should be 2D since each variable should be in C, so it would be the subset of C2.
Right,
but
right. Kind of 4D, but not really. Yeah.
yeah, it is a 2D surface embedded in 4D
Right.
space. Since if you choose one x, then y would be determined
Right.
up to signs. So you only have two real degree of freedom, so it would be a 2D surface
Okay.
rather than three manifold.
Okay.
So topologically, it would be a torus by some calculations.
Right.
I should really need some time to explain this calculation, but anyways. Okay, so torus is indeed a quotient of a complex plane by
Torus
a lattice.
is a Torus is
So the elliptic curve is indeed a quotient by some lattice. This is C, and we quotient it by lattice lambda, where the quotient just means that it is taken as an quotient of abelian groups. So the fundamental polygon looks like this, and maybe you will remind the topological diagram that gives the torus. Do you remember this diagram?
No, I do not. I have never learned topology, so I would not know what that is.
Yeah. Okay.
I'm planning to learn it in this year.
This year. Okay.
When will part 3 release?
I mean,
it takes at least a month. Okay.
I think it is not that hard to visualize here since it is
right. I know what that means. Yeah, you attach the two sides and then you attach these two sides and the result becomes a torus. Right.
Right. That is just the explanation. No more things are needed.
Right, and that's called a T squared. Yeah.
T2. Yes.
Yep. T2.
So just an abelian group quotient would be torus topologically, and we wanna find out what this lattice is, or each elliptic curve E.
Right.
So it turns out that the lattice for the elliptic curve y squared equals x cubed minus x is equal to the lattice of Gaussian integers times a constant.
Okay.
It is
times
just a fancy notation for the sphere lattice. but it is stretched by some constant. This is not 1, but
Right.
I guess 2. Yeah, maybe this constant.
Uh-huh.
I don't exactly remember. Maybe it would be its half, but
Okay.
anyways. So the Lemniscate constant naturally arises when you consider an elliptic curve which has a symmetric
Right.
lattice.
So that 2.622 you wrote there, that is the Lemniscate constant, right?
Yeah.
That appears there.
Yeah.
And
Yeah,
so
I think
that is the importance of this number in this in the topology, field of topology.
Yeah. So Zi, the lattice of the shape Zi is more important than other lattices since it has a 90 degrees rotational symmetry, while others do not possess that symmetry. In general,
right.
lattice, it would look like a parallelogram, which just has a 180 degrees rotational symmetry, but this has more symmetries, so it is indeed a unique kind of constant over all its curves.
Okay, that was
That's
very insightful.
Yeah.
Yep. Thank you for that explanation. Okay.
Thank you.
Let's move on to tau, which is just 2 pi, which is 6.28. I believe we can skip over this, and this is the integer part is 6. The rounding of this is also like we just put it in the calculator. So square root 2026. Bam. Is gonna be 6.7. So this is 7 rounded to 7. Now we have Gauss's constant, and this just this is already something we've looked at, and it just happens to be the omega pi, as someone suggested in chat, divided by pi, which is 0.834 something something. The first decimal place is 8. Gauss's constant is also equal to 1 over the arithmetic geometric mean of 1 and square root of 2. And that's when you put 1 and square root of 2. You take the arithmetic mean, you take the geometric mean, you do that again. You start from these two numbers, you take the arithmetic mean, you take the geometric mean, and do that again. If you keep doing that, you result in this, and that the reciprocal of that is going to be G here, 0.834 something. Right. And then we have Catalan's constant, which is, I believe in Wikipedia, it's also denoted G, but that's the same as this. But anyway, beta 2, this is also called a Dirichlet beta. And what is it? It is 0.915 something. So the first decimal place of that is 9. So this one is equal to sigma, and from 0 to infinity, -1 n divided by 2n plus 1 squared. So that's gonna be like 1 minus 3 squared plus 5 squared over 1 minus 7. I mean, under 1. Anyway, that kind of stuff. That's gonna be this number, and that is 0.9 something. Next up, we have Gies-King's something something. The first two digits of this is going to be 1.01494 something something. So the first two digits are 1 and 0, which is why it's at 10 o'clock. And this one is equal to, this one is also represented as a series, which is like kind of complex in this form, but like it's the only way I can understand what it is. So this is how it looks like. Bam, bam, bam. And then plus, there's one more. one more term, which is another n from 1 to infinity, 1 over 3n plus 1 squared. And that whole thing is equal to this, supposedly. And then at 11 o'clock, we have Levy's constant. Levy's constant?
Can I make a remark on Gisekin constant?
Yep.
Thank you. So, Gisekin constant is kind of hard-looking constant. So its meaning is maybe it's not for this streaming, but yeah, you need to know about the hyperbolic 3 manifold.
Wait, are you sharing another screen right now? Because it is showing my screen on your screen.
I'm sharing my screen.
Right.
Okay. So hyperbolic 3 manifold is...
Wait, why am I looking at my screen? Wait. Why did it switch like that? Okay, now it's on your screen. Did I switch? I don't know. Hyperbolic 3 manifold.
Okay.
So
it is this kind of hard subject, but I think you can just think of tiles in hyperbolic space.
Tiles in hyperbolic space, right?
So hyperbolic space is a concept that requires 1 hour to explain. So
right.
Let's just focus on tiles.
Okay.
So
Tiles.
In Euclidean space, tiles can have different kind of shapes, like square or triangles or hexagons and other shapes. And what is our question? Our question is that what can be the volume of the tiles? What can be the smallest volume of the tiles?
Okay.
That is our question. But in Euclidean space, this question is kind of, obvious, since any tile can be shrinkened as much as you want, since it preserves the tile structures, right?
Where we were finding the largest volume of like each tile, or like the entire.
Okay. So you're given the set of possible tiles that can cover the Euclidean space,
right?
And there can be so many different tiles of different sizes.
Yep.
So your question is to find the smallest volume of each tile.
Okay, the smallest volume of each tile. Right. So when you're filling things up with that little square, but the thing is, you can shrink it however you want, so it's technically get like 0?
Yeah. In Euclidean space, this question is meaningful. I mean meaningless.
Right.
Yeah. So what changes the question is that the curvature of the space. When the curvature comes in, the shapes no longer maintain its original shape when you shrink or stretch the shapes. So, for example, consider Earth, or in math terms, sphere.
Right.
On an Earth, you can draw a triangle, and you can make large this triangle.
Right.
I drew it in reverse way. Okay, so the angles of the triangle
change,
gets larger and larger. Yeah.
And if we're tiling it, like in this example, like does the tiling happen when the triangle is like covers 1/8 of the sphere. It's like when everything is 90 degrees.
Yeah. Yes, you're absolutely right. If you have a triangle of right angles,
Yeah.
the right equilateral triangle, yeah, very
3
very
right angles.
strange.
And maybe this is like the only way this is tileable, maybe?
I mean, if you have equilateral triangles, then this is the only possible way. But sphere tilings can be more bizarre if you consider other shapes.
Right. 토스티님 지금 댓글에서 하는 말 맞는 것 같습니다. Chat. Right. Yep. Chat can help too.
Yes.
Thank you. This one is.
I cannot see the chat, so yeah.
Yeah. Pentagons covering spheres.
Yeah.
Sphere.
Yeah. If you have pentagonal tile, then to cover the sphere, you need to make the angle 120 degrees. So this just resembles the shape of a dodecahedron. Like this way, you can adjust the size of the tiles to make possible to tile the whole space. So the area of the tile is meaningful since it cannot be an arbitrary size as in Euclidean space.
Right. And this connects back to tiles in hyperbolic space?
Yes.
Yep.
In hyperbolic space, the things are more unintuitive, but actually that's not that crazy space. You just have constant negative curvature.
Like a saddle?
Curvature.
Saddle stuff?
Yeah. Saddle indeed has a negative curvature, but it does not have a constant negative curvature. So.
Oh, right.
I mean, at one point it looks like a saddle, but
right.
globally it is. Yeah. It is not a saddle. You just need to consider shapes like this. In spherical geometry, you can have a fat triangles. In Euclidean geometry, you have normal triangles.
Right.
And in hyperbolic geometry, you have thin triangles.
Yep.
With their angles is deficit from the 180 degrees.
Yeah, less than 180. I believe, I've seen examples like the Escher painting, triangle, painting, bats and bats and angels and stuff, the angels and demons. Something like this.
Yeah.
This is like a hyperbolic space stuff. Yeah.
Yes, that was the exact example of the hyperbolic tiling. Fun fact is that Escher never knowed about the underlying hyperbolic geometry of this stuff, but he just captured the patterns in the tilings and drew his artworks.
Right.
So, in this case, we also can consider the area of each triangle tiles and wanna find the minimum area. So that would be the meaningful question in this case. And that's the meaning of the Gessenking's constant. In hyperbolic 3 space, the 3-dimensional tiles can have different shapes.
Yeah.
And Gessenking's tile looks like a tetrahedron, but it is thin since its angles are I guess 60 degrees, but not sure.
So that is
that's the second thing.
You are tiling the hyperbolic 3 space with tetrahedrons that look like that, maybe regular tetrahedrons. And then in that case, the size of that tetrahedron volume or whatever has to be Gessenking's constant.
That's absolutely right.
Okay.
The volume of the smallest possible volume of these tiles is the Giesecke's constant,
Right.
1.01 or etc. That's the remark for 10 o'clock.
Right. That's great. Thank you. Thank you.
Thank you.
So that was Giesecke's constant. I see now why it is called V. That's V for volume.
Yeah. Yeah, right.
Now we have Levy's constant, which is I've written it here, and it is around 1.186 something. And this is equal to just simply pi squared divided by 12 ln 2. So that is Levy's constant. And then finally we have A, which is Glacier-Klein-Kellen constant. Glacier-Klein-Kellen constant. And the first two digits of that is 1.28. It's 1.28. That's something. So the first two digits is 1, 2. So that's 12 o'clock. And this is equal to, in the Wikipedia, it said e to the 12th minus zeta prime minus 1. And that's what Wikipedia said. Or the integer part of this gamma is a what this is also called a Euler constant, right? Euler and some other name. There was some other name there. Euler something constant. And this is around 0.577 something. And the integer part of that is 0. So this becomes 12 or 0. So 12 o'clock or 0 o'clock. Right.
Yeah, so the Glacier-Kincaid constant and Euler's constant are kinda similar, I guess. How should I explain? In the Wikipedia page of Glacier-Kincaid constant,
right,
you can see many asymptotic expressions.
Okay.
Are you seeing my screen?
Yep. Oh, by the way, someone asked, where is 2026 in this clock?
I guess on the 7 o'clock?
Yep, it's here. The rules are you just have to put 2026 somewhere in the clock. So it doesn't have to be everywhere around the clock. It's just in one puzzle, and that's okay.
That's right. I am not prepared to explain these equations, but I just make brief remarks. So
okay.
Wikipedia says that this is the definition of the hyperfactorial.
Hyperfactorial, okay.
And it just gives the asymptotic expression for the hyperfactorial and then quadratic.
N quadratic.
So,
right?
Okay, so the Euler constant analogy is just a mistake of mine.
Okay.
It appears as a constant on the Stirling-like approximation.
Stirling-like approximation
of the generalized factorial.
Right.
So you can remember the Stirling approximation of the factorial.
Stirling's formula is this one.
Yeah.
Yep.
This one is kind of looks like this strange looking expressions. So if I bring this correctly, this looks a lot more like the Stirling approximation. Since this part are very similar, and the resulting constant is the Glacier-Kincaid constant for the hyperfactorial.
HN. Right.
Yeah, I think in this way you can you can find the meaning of this constant. That's remark.
Right. Thank you. So that's
Thank you.
yep. Just like square root of 2 pi n in Stirling's formula, that's about a factorial. The Glacier-Kincaid constant is about hyperfactorials, connects to hyperfactorials. Okay, that
Indeed,
is
the Korean Wikipedia pages exist, so I learned the pronunciation there. 글레이셔 킨켈린 상수라고 부른다고
Glacier-Kincaid.
하네요.
Aha. Right, Glacier-Kincaid. Okay, Glacier-Kincaid. Right.
Okay.
And that's one clock complete. Yay! That's the first clock by ModularDiscriminant. And now we
Thank you.
reset everything and go for part 2. Part 2. Wait.
Okay.
Part 2 is it's this one, right? Only 1 2026, only for 2026. This clock is filled with expressions that contain only 1 2026, which is only 4 2026. Here's the list of rules that the clock obeys. I'm sure that the rules are pretty non-trivial. Rules for the clock, only 1 2026. Yep, only 4 2026. You need to make a real number that rounds to the desired integer, 1 to 12, by successively applying functions of one variable to only 1 2026. So let's look at the clock and go see it together. So this is how it looks. You put 2026 into various functions, and it doesn't give exactly 1, but it gives an, like you see here, there's an error term here. The error here is like, maybe I should bring it up like this. Okay. You can see that it has less than 0.1 error for green, less than 0.01 for blue. And this was version 1 of the clock, and they have actually made the version 2 of the clock, which is even more precise. So you can see compared to version 1, which had some black ones, now we have a lot more blue ones and all the rest are green. So the error got really small. So that's, I guess, what I'll be looking here, and I'll just be putting everything into Wolfram Alpha. But anyway, let's let's read the rest of the rules. So V2, V1 tries to represent simplest or most elegant expressions that rounds to 1 to 12, visually short or clean. Unexpectedness of the expressions was considered. For example, 11 o'clock, sin h cosecant 2026 is not fun enough. Right. In contrast, tan square root 2026, it relies on a pure coincidence. Right, tan is like goes crazy all over the y-axis. So if you put like a seemingly random number into a tan and then that into a tan again, that's so random, and it's very interesting that I guess it's very lucky that it lands on something close to 11. So that's version 1, unexpectedness, and version 2, there's more accuracy. And here, the important part is it only works for 2026, not 2025 or 2027. I mean, it could work for other numbers, right? But at least around 2026, it doesn't work for 2025 and 2027. So I guess I'm just going to believe that it doesn't work for 2025 and 2027. I'm just going to put in 2026 and see if they work. Okay.
Wow.
ln gamma sine 2026. Maybe just for 1 o'clock. Maybe just for 1 o'clock I'll put in 2025 and 2027. So wait, ln with the large L, is that different from just log?
That just means that we use the principal branch for the natural logarithms, since in the complex domain, logarithm does not have a unique value.
Oh, okay.
So the capital ln is more rigorous notation for the expressions.
Principal. I'm writing this down. Principal. Yeah, principal like branch of log. Okay. In complex plane. In complex plane. So this happens to be 1.02 something something. Now, if I change it to 2025, does it break? Yes, it does. If I change it to 2027, does it break? Wait. Decimal why is the wait, this one has I guess. Oh, I guess because sign somehow went below 0 and that's why it's getting I in the thing.
Yeah.
Okay, so it breaks for 2025 and 2026. I mean 2025 and 2027, but it works for 2026.
That's right.
Okay. And the next one we have secant of 2026. By the way, while I put these in, what was your method of finding these stuff? Did you like do a program?
Absolutely manually.
Ha!
All these things on my own with just the help of Wolfram Alpha, and I mean, I could just make a large list of numbers that are interesting. So after you calculate 100 expressions, the list is very dense. So you have 3.1, 3.2, 3.3, and so on. So that you can literally make any number after that point, I guess.
Oh, because there are so many functions and you can do them in whatever order you want, maybe? So you just tried out all the all the possible combinations?
Yeah, I actually didn't make all the possible combinations, since most of them would result in non-elegant expressions, since functions are usually very slowly varying. So I looked up some inputs that are close to the pole of the function. So for example, if you
Right.
if you have a gamma function, then and you have a near integer expression, then you can collapse them to blow up the values.
To a negative integer? For a gamma function. Right.
And
by the way, why
and
is this not computing for me? What? I 5 o'clock, the factorial, the Wolfram Alpha just does not give me a number. It just gives me an expression.
It's a puzzle.
Bam. Let's look at 6 o'clock. That is around 6. Let's look at 7 o'clock. Also, that's supposed to be the digamma function, I believe. Is it?
Yeah, that's right.
Minus ln. I guess this has to work. ln 10 cos 2026. And put it. Please work. Please work. Please work. It works. 7 point something. Okay, and then we have.
Can you read 5 o'clock? So cosine h 2026 is a really large number.
Yeah.
And you plug in cosine, then it oscillates really quickly. So
yeah,
Wolfram Alpha doesn't calculate after that point. So if you calculate cosine h 2026 alone, it evaluates the value.
Oh, really? Okay, wow, it does. Okay, so I'll copy that.
That's
put
right.
a factorial and then square root that thing. And that is around 5, right? Amazing.
That's how I calculate it. Yeah.
Right. So I was at 8 o'clock. Wow. How would this calculate? This does digamma cosecant 26 radians. And that is 8. Okay, and then 9 o'clock. Let's go to minus gamma cotangent 2026 radians factorial. And that is around 8.9. And then we have digamma. Bam, 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 bam. Oh, that's also going to be degrees. Also, what is the digamma function? 9.93. 9.93.
Digamma function is a function that is defined for the derivative of the gamma function. So the definition is that gamma prime divided by gamma function.
Gamma prime divided. Okay.
So,
It's yeah.
yeah, it
ln
is called the logarithmic derivative of the gamma function.
Mhm.
So
Because-
if you differentiate ln gamma, it gives the digamma function.
Right. So this is the log of gamma to the derivative, and that gives us gamma like in the bottom and gamma prime at the top. That's what it does for every f if you differentiate log.
Yeah.
Okay, so we got 11, and now we only have 12 left. Zeta of sine arc cos. Sine of arc cos should be like, I don't know, there. I think there was a formula that I forgot. Rad. Okay. Arc cosine sine zeta function. Maybe I should do this first. Wait.
Yeah.
Arc cosine, it's not rad. I'm stupid. Okay, this is just 2026. And that is
A complex number.
right. And then we put that in zeta. Bam. And then put an absolute value around that. And that is 11.97. And that completes
Yes.
the only 2026, only 2026 version 2 clock. Bam.
Yeah, so the zeta function oscillates very, very irregularly around the imaginary parts gets larger. So I did some gotcha for this one too.
Right, right. Okay.
Thank you.
Okay. The next one. But we are back for third time. Number theoretic expressions that contain only one 2026, which is only for 2026. So unlike the last one, this is more number theory. You need to make exactly the desired integer, and it should only work for 2026, not 2025 or 2027. It could work for other numbers other than these two, though, right? So it could work for other numbers, like it could work for 2024. It could work for 2028, but it doesn't work for 2025 or 2027. Only commonly used single value functions, arithmetic functions, no two analytic functions, no number stuff. Right. Okay, let's look at this clock. Now, here you can see this time it looks very similar, but this time it's all blue. Error is less than 0.01, and I believe it's just because there's no error, right? It's just the error is just 0.
Correct. Yeah.
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 Because these are number theory stuff, and all the values are integers and stuff. So, let's look at these. So, for example, we let's see. Wait. Can I confirm? Wait. Have you considered reconsidering your life choices? I mean, when are you ending the stream and going to sleep? I mean, numberbasher, I give you 2 choices because I right now I have your thing on the end. Number 1, we can do your clock right after this right after my segment with modular discriminant ends. That's option 1. Option 2 is you go to sleep and return tomorrow morning. What do you think, Number Basher? Yours is in the end. You are in no rush, so you will have to go to sleep and return tomorrow morning. Okay. Wait, you're not sleeping? Yes. I'm not. No, I mean, no. I'm not sleeping.
Wait.
I
You don't sleep, really?
I mean, I said it like I'm not ending the stream until
Oh.
I am done with all the
Oh.
clocks. And you can, I mean, if this segment is over, then ModularDiscriminant, you're free to go. Like, I'm not stopping anyone. Number Basher, you either do it right after this, because your clock is going to take me 3 hours, right? And I think you know that too. You know that I will take 3 hours solving your clock. So you either do it right after this, which is going to start at around 11 p.m. Or even if I do everything else fast enough, it will still be around 6 a.m. or something when I go to your math clock. So I will take more than 3 hours solving your math clock, so you can sleep and then return, and then I will be solving your clock when you wake up. And I think that's how it's gonna go. Okay. But anyway, let's look at these clocks. We have only mu, which is it is the Mobius thing, and the thing is, okay, I can calculate this by hand because 2026 is 2 times 1013. Now, it's a product of 2 distinct primes, and in that case, this becomes -1 to the power of 2, so it is 1. This is 1. This is the number of prime factors of n, which is, this is at 2 times 1013, so number of prime factors, 2. M, what's M? M is, wait, okay, I actually don't.
Mertens function.
Wait. Mersen?
So basically, Mertens 함수라고 하는데요.
Uh-huh.
Basically, you define the Mertens function by the sum of the Mobius mu functions.
Right.
Yeah, that's right.
Okay. So Mertens function is a partial sum of the Mobius function. Okay. Okay.
Yeah.
Okay, from 1 to n mu k. Partial sum of Mobius. I'm writing it down in my notebook. Mertens function. Okay. So I believe then if I just do Mertens or something 2026, it's gonna give me, no, it's giving me the age of Franz Karl Joseph Mertens in 2026. So M, maybe? M is a math function. No. Let's just do maybe sum everything, do it ourselves. Maybe put that mu in there. Okay, do that. It is 3. Right. So it is 3.
Right.
And then D is the number of, yeah, you told me last time, this is the number of divisors. It's same as writing sigma 0 of 2026. So since it has 1,
That's
2,
right.
10, 13, 2026, it's 4. Yeah, I learn. And then we have
Thank you.
this one is the number of coprimes, Toshian function. The number of coprimes, I mean, it's, I believe it's 10, 12 or something. I believe I calculated that before. Toshian.
Right.
2026 is 1012. We put that in the totient function again, which gives us 440, and then we put 440 in the count factorize 440,
Yeah.
and it's 2, 5, 11. 5 prime factors, I mean. 3 distinct, but 5 prime factors.
Yeah.
So-
Can I make a remark?
Yep.
So basically, you can make a shortcut in the calculation using O from alpha.
Oh,
In my screen, I'm
right.
typing the code.
Uh-huh.
So this is a shortcut. So firstly, you can type factor,
Okay.
which just gives the factorization of the letter, and in the letter you can write the exact name of the Wolfram language function,
Right.
which is Euler phi. This is the
Right.
correct name.
Okay.
So in the Wolfram language documentation, you can find various functions. Documentation. Wolfram language,
Wolfram language document.
which is the language that coded the Wolfram alpha. So this is the pool of all built-in functions, and you can find the exact name of the functions here.
Right.
So the Möbius mu was the really Möbius mu, and for the prime counting function, you have prime pi, and
Uh-huh.
for the partition function, you have partitions p.
Partitions.
Like,
P.
yeah, here's S, by the way. So in this
Right.
way, you can use Wolfram alpha very quickly, I guess. So,
Okay.
yeah, this
Thank
is
you.
small
Okay,
tip
I
for
am
you.
writing that down.
Mhm.
Right. So this P. Wait, what is this P thing?
That's the partition function.
This one is the partition function.
P.
Oh, it's in. Yeah, this one is in lowercase this time. Okay, so, and omega is number of distinct prime divisors of n. So we're gonna do factor, and then partitions P, and then 2026.
Yeah, that is really huge number.
Wow.
So it is
But it has
gotcha.
6 prime factors, 6 distinct prime factors.
yeah.
And then we have partitions P 2026, and then wait. So D that's just counting the number of all the divisors. So in this case, because this had 6 distinct prime factors, D of that will be 2 to the 6.
Right.
So we need factor 64. And that's going to give us, of course, it's going to give us 7 divisors.
Yeah.
And then here we have, I know that's 10, 12. And then we have lambda. Okay, now what is lambda?
Lambda. May I explain?
Yep.
Okay. The Carmichael lambda function is basically a function that gives the best optimal number for the Euler's theorem. So Euler's theorem in the number theory was that for any modulus m for any integer such that they are co-prime, then the a to the phi mth power would be always 1 modulo m. That is the Euler theorem in number theories. So yeah, it basically just a generalization of the Fermat's-Little theorem. Like, for example, if you calculate modulo 7 1 to the 6th power to the 6th power, it always gives 1. And Euler's theorem can be used to non-prime moduluses. For example, modulo 8, you can calculate everything becomes 1 in modulo 8. But this exponent 4 is not that optimal, because when we square the numbers, it indeed gives the numbers that are congruent to 1. Yes, so the optimal number for the exponent is 2. That is the Carmichael lambda function.
Okay.
So you basically, consider every possible coprime integers and power it to some number to make it all 1. And the smallest possible integer becomes the definition of lambda m.
Right.
That's the definition. And for the practical purpose, here is the built-in symbol Carmichael lambda.
Carmichael lambda, right? Carmichael lambda. Okay.
Yeah, that's the remark. Thank you.
Thank you. Okay, let's return to this. And let's do a. So factor Carmichael lambda of Euler phi 2026. And that's gonna be 110. That's 3 distinct prime factors. So 2 to the 3 is an 8. Now let's look at that's gonna be partition P 2026, but then put that in a Euler phi, and then factorize that. And omega is just the number of distinct prime divisors. Why is it lagging? There are 1, 2, 3, 4, 5, 6, 7, 8, 9 distinct prime divisors. So that's 9. Next up we have I keep having to flip through my pages. Okay. We need a. I don't know how to write that yet, so I'm just gonna do. Mertens is gonna be. Actually, I need to put in this number there. That's very amazing.
Maybe you can use sigma 1 just sigma 1 for the sigma function, I guess.
Sigma 1.
Sigma underbar 1.
Sigma 1. Oh. Underbar. Maybe I need natural language? Maybe? Oh.
Yeah.
And then the M is just I don't know, some I don't know, maybe that does it?
Yeah. I don't know how to calculate Mertens function in Wolfram language. Yeah, the sum is the best possible.
And then Möbius is like, I don't know, this?
Yeah, I cannot see your screen, so
right.
Moebius, yeah.
Mobius and then just K maybe? Right.
Yeah.
And then we put 2026 there. And that's minus 10.
Maybe it's mu.
And that's minus 10, so this is 10. So I got that. Okay. The next one is gonna be pi is prime pi, and then d. Wait, I should have. And then I just should do factor. I mean Euler phi 2026 maybe. So that's sigma 1. So that's sum of factors. Sum of factors of maybe that's gonna do it. Wait, sum of divisors. Divisors. It's 2016. 2016 factor number of divisors of 2016. That's 36. And then prime pi 36 is 11. So that's 11. And finally, we have factor Euler phi 2026. And that's going to give 12 divisors. Bam. And that's a clock complete. Right.
Yeah.
That is clock number
Maybe
3.
you can use the sigma 0 for the divisor function and d function and sigma 1 for the sigma function.
Right. Okay. I will write that down here. Sigma 1. Sigma 0. Okay. But that clears the 3rd clock, and now we go to the 4th clock, and it is the quaternary clock. This is my quaternary submission for the math clock contest. Here's the puzzle. The expressions aren't directly evaluated to the integers 1 to 12. Instead, they have the crucial common property. When you figure out what it is, you'll get the meaning of the clock. And these might serve as hints. And let's see what it is. It's very, very simple.
Yeah.
It looks very, very simple. Let's first calculate all of that. And I guess we will just keep using Wolfram Alpha. I'll just put it, I'll just use it myself here. Just calculate all of that. So, I don't know if I would need the decimal representation. I'll first just write it like this. This is just 3 over 11. 3 to the power of, what is this? -3. That's going to be 1 over 27. This is going to be another 3 over 101. And this one is 2026 divided by 18 plus 720, which is going to be... how large is that? I mean, we can just divide it by 2 and we get 369 in the denominator. Also, the decimal approximation seems... I don't know. Would it be important? I don't know. 2 divided by 26 is this. 2 divided by -3 plus 720 is just 2 divided by 717. 62 divided by 2263. That's gonna be 2 over 73. Okay. Okay, I don't know if the decimal will matter, but it's 2739726, and that repeats. Okay. This is 3 to the power of -4, which is going to be 1 over 81. This is 122, 1. That's 24 plus 720 minus 6. So this will evaluate to 738. Bam. 190 divided by 4059. And 0.0468095590. So now I think I get it. It's the number of repeating digits below the decimal point. I think because yeah, this has 10 digits repeating, this has 8 digits repeating, 4 digits. I believe all the others will. I'll return to it. And
yeah.
let's look at. 김민조님 유리화하면 자모에 합성수가 하나도 없네요. 그게 합성수 근데 81분의 1 같은 거 빼고요. 이거 빼고 다 소수인가 보네요. 그래서 이게 반복이 잘 원래
합수는 아닐 거예요 아마.
요 81분의 1 이런 거 빼면 오케이. 2 divided by what is this? -4. So it's just 2i plus 1 and then minus 1. So that's gonna be 132i. Wait. So it's gonna be 2 divided by what squared? I mean, it should be Okay. 66 times 2i plus 1 and then minus 1. Just do that. 2 over 21649. And then finally 1 over 202 plus 6 over 26 times 2, and that's gonna give us 158 divided by 1313. Now let's check our hypothesis and see if this has 12 repeating digits. So it starts from 0.12. Also note it starts with 12. 120335110434, and then it repeats. So this has 12 digits repeating, and it starts with 12.
Right.
Maybe 12 is a coincidence. Is that? Maybe 12 is a coincidence. Let's look at 101 divided by 3. That's of course gonna be 0.666666 something. Yeah. But yeah, we should check it. Yeah, it's 1 digit repeating. And 3 over 11.
Yeah, also note the repeating point just starts right after the decimal point. So I didn't make any redundant non-repeating digits.
Yep.
By removing all the factors 2 and 5 from the denominator.
No factors 2 and 5 from denominator. Right.
Yeah, that's the pattern.
Okay. 2, 1. What's 1 over 27 look like? What's 1 over 27 look like? 037. Bam. What's 3 over 101 look like? 3 over 101 looks like 0297. Okay. By the way, is there a reason it was specifically called the quaternary clock with this Q as the rational number?
Yeah, just for that math BBQs. So I just wanna emphasize that I use the repeating property of the rational numbers. So I use the Blackboard board Q at that point, and this is my 4th submission, so I found the word that has meaning of 4th and is starting with Q, so that is the word quaternary.
Yeah, quaternary. And
yeah, it just means 4th.
Yeah. It has something to do does it have something to do with quaternions? Quaternion something? Something there?
Yeah, that is not related to quaternions, unfortunately.
When I first saw the clock, I thought it was gonna be like maybe 4 of them are related to each other and something. Maybe 3 of them are related to each other, and there are 4 like such pairs. I was like, but then I was stumped, and then it didn't work out that way. That has 7 repeating digits. 8. Let's just look at 11 and end the clock. 2 divided by 2, 1, 6, 4, 9. That's gonna be, wow, 0, 0, 0, 0, 9, 2, 3, 8, 3, 0, 2. That's 11 digits, and then it repeats. Yep. So that's how you get this. By the way,
for the behind.
Behind. Can we hear about that?
Behind story is that we just need to factor the repeating 9s n times and find its prime factors to make the denominator. So, for example, 11 o'clock is made by the prime factor of 999, 999, 999, and 99. So you can factor that and find out what are the prime factors, and the smallest one is that 5-digit number, so I really struggled to make the number.
Aha. With only 2026. Right.
I used mostly 2026 since 3 of them would be too easy. That it's the behind story.
Right. Amazing. Okay. We have 2 more clocks. Actually, like, basically 1 more clock to go, but that one is a big one. It's
So the
called...
coronary one is my only puzzle, and the 5th one is, the thing.
Okay. The exceptional structures. This clock shows the unique properties of numbers 1 to 12, 20, and 26 in mathematics. You can see that the statements given here are non-artificial. These are fundamental properties of numbers 1 to 12, 20, and 26. In other words, you cannot generalize or modify the resulting number by slightly twisting the statements. Each of them are only for that specific number. Most of them are even related to strange, exotic objects in mathematics. Are chat allowed to make guesses together? Yeah, of course. That's actually helping me. That helps me massively and increases my lifespan. Because otherwise I could die. Let's copy that image and put it here. And I don't know how you would want to go about this, because ModularDiscriminant has a whole essay made about this clock, right? You have an entire set of essays made about this clock. So I could look at it and maybe I could I could explain some of them, but I cannot. So it's probably best to leave this to you, or maybe you could see me read through your essay and then tell me when something goes wrong, maybe. So what do you think? Do you want to do it yourself, or do you want to see me do it?
Okay. Can I see you reading my essay? But wouldn't it take so long? Are you okay?
Oh, right. Maybe. Well, then, maybe you could only point out the important parts, or just the gist of it. Maybe that's gonna be faster.
Important part.
Because okay. I want everyone to see the size of this scroll bar that my mouse is on. Can you see this scroll bar, everyone? Can you? It's a small part of the stream. You might need a big red circle to focus on it. Okay? Can you see this? Can you see this essay? Bam.
Yeah, 24 pages long.
Took more than 10 hours for you to finish.
Yeah, indeed.
Okay. So I don't know. Can you if you go through it, can you explain everything in like 10 minutes or something, maybe?
Yes, I mean, yeah. I hope you read this essay someday, but if
Yeah, I will. Of course,
force
I
you
will.
to
Yeah.
read right now, then I will kill you. So, uh, definitely.
Okay. I'll first just read
So-
the entire clock, and then you can go through it, right? I'll just read through the entire clock. So for 1 o'clock, we have number of regular homotopy classes of the immersion S2 to R3. Okay. For 2 o'clock, we have P that is larger than 1, such that LP of the real number is a Hilbert space. For 3 o'clock, we have the largest order of an automorphism of Dynkin diagrams. Zai, what are you going to do after this? Either the numberbasher clock or this Marmalicious clock. That depends on what numberbasher tells me to do. So, 4 o'clock, we have n such that they are exotic r to the n's. 5 o'clock, we have smallest n such that degree n polynomial equation is not algebraically solvable. And this is the only one up till now that I know. The impossibility of the quintic. Now, we have n such that the outer morphism, I forgot how to pronounce this, but I believe sometime I learned this in linear algebra and stuff. Out of Sn is non-trivial. In 7 o'clock, we have smallest n, that is not 4, such that there are exotic n spheres. And I guess it has to not equal 4, because 4 we already have, there are exotic r to the n's. Maybe there are exotic n spheres in R4. Smallest n such that there's a singular minimal hypersurface in Rn. The largest number of roots of exceptional affine Kac-Moody algebras. Right. Amazing. For 10 o'clock, we have conjectural degree of the solution of Lamar's Mahler measure problem. Conjectural. For 11, we have smallest n such that modular curve x0 of n is not a sphere. And then for 12 o'clock, we have smallest weight of cusp forms of level 1. And then for 2026, we have 20, the largest number of faces of regular polyhedra. I know this one. That's a regular icosahedron. Has 20 sides.
That's right.
Looks like this.
Yeah.
Kind of looks like this. Amazing drawing. The number of sporadic groups, I also know the answer to this. I, of course, don't know anything about sporadic groups, but there are 26 sporadic groups. There's the monster group something, moonshine something.
Right.
And that concludes this clock. Okay, so now let's listen to the explanation.
I can see now what should I do. So basically, I wanna emphasize some points in this essay. So I can give you a short lecture for this essay. I mean, yeah, this essay is a lecture note. So that you can refer to.
Right.
Though this is not very rigorous essays. So anyways,
I'm gonna put it up in my second monitor. Right.
Yeah, for 1 o'clock. Yeah, let's begin. There's a puzzle that you can solve for this third one. So the first one, I wanna show you the interesting shapes in sphere eversion video. So the most famous one is the outside in video of the geometry center.
Yep, that's a classic. Everyone knows this. Everyone in the chat knows this.
Okay. So basically, this video really explains the phenomenon well. So you cannot make this crease or pinch, and you need to flip its inside and outside.
You're pinching it infinitely tight.
Right. Yep.
So, can I turn the sound on?
I
don't
can
know.
already hear the sound.
Okay, thank you. So this is the
Yes.
aversion process.
You bet. That
It
wasn't
is
easy to follow,
really
was it?
really
But watch
complicated process, but actually it is a bunch of ideas that is very geometrical.
Inside out?
So
Uh-huh.
the whole
Put a target
video
point
explains
in
what
the
the
funnel.
idea is.
Mm-hmm.
It first starts with the two-dimensional case, which is analogy for the
On a more
three-dimensional
complicated
case,
track, the car might sometimes be
and
turning
it
left.
explains that
Two.
two-dimensional case is essentially different from the three-dimensional case. So let me add one page here. What is the aversion of the two-dimensional actually one-dimensional sphere in two-dimensional space? Can we make this eversion is the first part of the video. So
Mm-hmm.
basically the answer is no,
No.
and the explanation goes like this. For the curves
Yeah.
in two-dimensional space, we can make an invariant of a curve.
Yep, and that is
called
how many
winding
times
number.
you like go counterclockwise or clockwise, the winding number. Yep. Yep. So
That's correct.
yeah,
Right.
winding numbers should change from 1 to -1 if you can reverse the circle. So it's impossible.
Yeah, right. So the winding number concept is actually to rigorously define, you would need to some kind of
Okay.
integration, but you can think it of this way. So any polygon has some
Uh-huh.
the sum of the outer angles would be the full turn, right?
Yep.
That is the phenomenon because of the winding number is 1.
Okay.
So in this way, you can add all the turning angles with some integration symbol, and that is the definition of the winding number, which is invariant under good transformations.
Right.
Yeah, the good transform is actually the rigorously. It is called the regular homotopy.
Mm-hmm. Wait. By the way, if 1 o'clock takes 10 minutes, then 12 explanations will take 2 hours. So you need to choose wisely what
Okay.
you are going to explain.
Okay. Okay, I maybe skip some very hard or tedious hours, and okay,
Right.
I'll make it in 1 hour maybe. I
Right.
must make it in 1 hour to not
Right.
for you.
I'll try to understand everything. If I think it's
thank
too
you,
above
really,
my
yeah.
level, then I will tell you. If it's too
Yeah.
above my level, yeah.
Okay, really, thank you. Okay, regular homotopy is just a fancy term for the good transformations for this one. So
Okay.
basically, you can move the curve however you want. You can indeed self-intersect the curve, but
Mhm.
you're not allowed to pinch the curve like this way. And
Uh-huh.
this pinching especially happens when you need to make a tight pulling of two strands like this.
Okay.
So in this case, you'll make this shape, which is not allowed.
Okay.
So that's why you cannot turn the circle inside out. In this case, to make the inside to the outside, you need to pull these two strands. It would not be allowed. So the trivial mechanism would not work.
Mm-hmm.
The invariant winding number is invariant under this kind of transformations, without any pinching.
Okay.
That's the important part. So the fact that this is invariant is called the Whitney-Grosstein theorem, I guess. Whitney. By the way, this is mentioned in the original video. And yeah, as you mentioned, this has winding number 1. This is winding number -1. So it does not preserve the winding number. Okay, so in the case of sphere, the situation is different since you can how should I say? In the three-dimensional case, that the invariant is more complicated since there are indeed 3 possible shapes. Like the geometry center says it is a frown. This is a smile, and there is a saddle. So the video explains that, yeah, the alternating sum of the number of smiles and saddles and frowns would be invariant. So for the positive sphere, we have smile and a frown. I'm actually confused about the invariant calculation here, so I'll be a bit a bit not rigorous here. But anyways, the result is not different here.
Right.
So it may be possible.
Right.
It may be possible. Yeah, and the real magic is that indeed it is possible by the corrugation method of the Thurston. So where should I show you?
Original curve in blue.
The
develops
corrugated
but the way
string can be turned into any shape without any
We have to
pinching,
keep
since
adjacent
corrugations
guides roughly
are
parallel as we
the
rotate them to align with the circle.
cushions to
This
this
is
pinching.
possible as long as the turning number of the original
And
curve
with this method,
can't
you
we
can
align the guides if
transform
the turning
literally
number
any
isn't
shape
That's
that
what happens when we try
that
to turn a figure
makes the
8 into a
invariant
circle.
not changed. So the explicit mechanism just relies on these corrugations. That's all I can say for a brief explanation.
Right.
And indeed, you can see other methods of sphere eversion.
Boy's surface.
So, yeah. So
Was
the
it
first
found
one
by
was- the
Boy?
first one-
What
it is not. I mean, the name Boy is the surname. It is the name of Bernard Boy,
Oh.
who found the Boy's surface in 1901, and he was the graduate student of Hubert.
Wow.
David
Graduate
Hubert.
student.
And
Wow.
Yeah. And the
Boy.
Hubert made a question for Boy. Yeah, his name is Boy, literally. And Hilbert thought that RP2, the real positive plane, cannot be immersed into the R3, since Hilbert himself proved that the embedding of RP2 is not possible in R3. By the way, do you know the difference of embedding and immersion?
No.
Okay, it is not that different actually. I mean, not that difficult actually. You have some shape, and you need to put it inside a large space like R2.
Yep.
We have a famous shape.
Yep.
And you wanna put it into a plane, but you can put it into the plane using some curved lines.
Yep.
That is the rule for embedding. just make sure that your lines must not intersect each other. Then it is called embedding. But
Right.
in immersion, you are allowed to cross its lines. So basically, this kind of this is too complicated.
Can I
how should
show
I go?
like an image? Wait, I have a great image.
Yeah.
That was drawn by none other than numberbasher. In the wait, where was the
Okay.
image? Wait, numberbasher, send me a DM right now of that image.
All right.
Okay, I'm not sure where to find it. Okay, let's just continue. Let's just continue. The Xi
Okay,
made of
but-
Xi made of Xi.
Yeah,
I don't know. Okay.
I know.
Okay,
It
let's
just, you
play.
can make the lines cross.
Yep.
Yeah. In the immersion, lines can cross in the immersion, like this and this,
Right.
maybe. So, Hilbert's question is that can you put RP2, which is a very non-intuitive space, into 3D space
Right.
with some self-intersections without any I'll say creases again.
Mm-hmm.
So I could not explain with this diagram. If you have a circle
Okay.
immersed into R2, then you can make it self-intersect, but you cannot make it very angular. This is not allowed.
Yeah. Wait.
So
immersion.
basically,
Yeah.
no
Yeah.
crease condition. Yeah.
Right.
In embedding, with the no sharp edges or no creases condition, you also have the no self-intersection.
Aha. No.
Yeah, that's the difference. No self-intersection.
And then they should have
Okay, so
both no sharp edges.
yes. So my writing is a bit messy, so I'll need to
Right.
explain it later.
I understood
more
that, but
clearly.
Unfortunately, that means this
Yeah.
example that the amazing example I just brought in from Discord is not an immersion, unfortunately. So what is this? This is, if you look really close, that's too, can you even see? Wait, it's too small. So this is there's supposed to be like a there's supposed to be like a tiny face here, and this is supposed to go like this is supposed to be a really long fish that goes like this, and then goes like this, and then like this, and then like this, and like this, and like this, and then back to here, and that's the tail. So yeah.
Oh,
Okay, unfortunately, that is not an immersion of the Xi fish because there are creases, but if you imagine these are like rounded, then this would be a great immersion of the Xi fish in 2D space.
yeah, you totally understood. If you round it, it would be an immersion.
Right.
Yeah. So the problem is that can you make it by using the self-intersections very cleverly? So Boy was that clever to make the intersections in such a fascinating way.
Right.
This video shows the voice surface for 49 seconds. I mean, I don't think you can understand it fully using this video, but anyways, it shows the voice surface.
Okay.
In 2 different angles.
Right.
Yeah, so basically it is a disc and it wraps of itself like this.
Aha. Okay.
and you make a section of it, it is always a Mobius strip.
Mm-hmm. Right.
Yeah, that's because RP2 is a non-orientable surface, so it contains so many Mobius strips.
Mm-hmm.
Where were we? So the boy's idea was that we can make an immersion, and the sphere eversion of the boy's surface version is not due to boys, but due to the later mathematicians.
Mm-hmm.
And they found that if you overlap two boys' surface,
Mm-hmm.
then it is regularly homotopic. So it is possible to make a good transformation from the two boy surface to a sphere. So the strategy is like this. You go to the double boy surface, which have different size and different
Mm-hmm.
orientation, and you can swap these two things to sheets. And how can I draw this? You swap these two sheets and go back to the sphere. Then its inside would be the outside, since this process swaps these two faces. How can I draw?
Right.
Yeah, so this relies on the fact that RP2 space is RP2 space has a double covering of sphere, but for the moment, just think it of as sphere is 2 times the real positive plane. That would suffice.
Okay.
Yes, so I cannot explain all the methods, but you can see so many possible sphere eversion methods in this channel.
Okay. J12 Studio.
Yeah, I really love. Yeah, I love these animations, so I just wanted to show you these animations.
Right.
That's the story of the sphere eversion.
Right.
Yeah, so
that was 1 o'clock.
That was 1 o'clock. Okay.
Okay.
For the 2 o'clock, I guess.
By the way, 12 hours! 12 hours, everyone! Yeah. 12 hours!
What?
Okay. Let's continue.
Yeah. Your streaming is really, really long. I appreciate it. Really. I respect you. LPR is a Hilbert space. I really don't know much about the functional analysis, so I'll just briefly explain it.
Right.
LPR, what is this? So basically, LP distance is a generalization of the Euclidean distance. So basically, you would calculate the difference of 2 points like this, using the Pythagorean theorem.
Yeah. That's
the mathematicians,
L2
always generalize.
Yeah.
Yeah. So the LP distance indeed satisfies the definition of the distance.
Yeah.
And this is a weird distance.
So the LPR is a space whose distance is defined like this, right?
Actually, LPR space is more complicated space. I'll just explain what LP metric is and why L2 is special using this Euclidean case. I cannot explain what LPR is here. So when you draw the circle here, then we have a normal circle. When you draw circle means that the set of points with the fixed distance. So in this case, the circle would be a bit different shape, like this one or something.
Wait, I cannot see the maybe your oh yeah, I now I can see, right.
Yeah. I cannot explain why the normal circle is truly important, but
Right.
think of it like this: the rotational symmetry of the original circle is preserved only for p equals 2 case, and for the other cases the shape is so irregular that the space does not work in great sense.
Yep. I kind of get it. Maybe I get it.
Yeah.
For now, I think maybe I get it is kind of a line we have to settle on today.
Yeah. The problem is that I'm not very familiar with these spaces, so I cannot explain greatly either.
Mm-hmm.
So we will just give it.
So yeah, that has to be true. P 1 over p plus 1 over q has to equal 1 for that to be dual. And then
Yeah.
if p is 2, then q is also 2, then it's self-dual. So it's dual to itself. Okay.
Yeah.
And like
so
right
that's
now,
why LP2 is important. Yeah.
Right. That's why it's important. Right?
Yeah. We can just skip it. And actually I am not very interested in the Hilbert spaces, so this is my biased preference. I really love this one, so I will use more time to explain this one.
Right.
Yeah.
3 o'clock.
Okay.
Again, the largest order of an automorphism of Dynkin diagrams is supposed to be 3. Okay?
Yeah. So basically, you have puzzle for this one. You need to see the Dynkin diagram and find the graph that is mostly symmetry. The graph with the most symmetry.
Graph with the most symmetry. Dynkin diagrams. Okay.
Yeah, I'm showing you the full list of Dynkin diagrams. Here, the the subscript means the number of vertices of each diagram. And the value n is just a natural number. You can put any number there.
Right.
Yeah, so you can see many symmetric diagrams. For example, AN is always twofold symmetry, since it can it can be reversed.
Twofold symmetry.
And, it is symmetric with respect to the vertical line. So AN is twofold symmetric, and most of them are twofold symmetric, but there is one diagram that is more symmetric than others. Can you find it?
In here, that is more symmetric than others. I guess. I mean, I think if dn, if n was, how would it be? If n is 4, then there would be 3 circles around 1.
Yeah, that's the answer. So you got the answer very quickly. So congratulations. This is the mostly symmetric Dynkin diagram.
Is it called D4 or D3 in this case?
You're correct. D4 is its name.
Uh-huh.
It has 4 nodes.
Right.
So the Dynkin diagram just encodes the data of the hard algebraic structures, so-called Lie algebras.
Yeah, okay.
I have a lot of story to tell you all the algebras and Lie groups, but it would kill you now. So I need to just mention that this diagram has threefold symmetry.
Right. I will learn algebra this year. So yeah, hopefully.
Oh.
That's I have
really
the you know the who is it from? 이인혜 잠깐만 이거 뭐지? 이인석 교수님. Do you know that one? 선영대수학군 and like just 대수학 that stuff. Yeah. Those two books. I'm gonna study them.
Great.
The textbooks. Yeah.
Okay. Really great. Okay. So this thinking diagram corresponds to just some arbitrary Lie algebra.
Right.
Or Lie group. Actually, you can understand the definition of SO8 since are you familiar with SO stuff?
Not really. I only know like kind of it's something related to I don't know orthogonal.
That's fine. Yeah.
Yeah.
Okay. SO2, SO3 are the most familiar ones for the rotational symmetries.
SO2 rotational symmetry. Okay.
Yeah, so it basically is the group of rotational transforms on R2. So it is the set of orthogonal matrices, so it is called the orthogonal group, and it is indeed a orthogonal matrices with determinant 1.
Yeah.
We call that special orthogonal group.
Yeah.
That is just the definition. And we can visualize it using the
Wait, the silent reverend asked,
state.
Dai, did you like math from a young age? No. Also, what's your favorite types of problems? None. Okay, let's continue.
Okay. So the most rotationally symmetric shape is circles. So we can consider SO2 as a rotational symmetric group of the circle.
Right. So that circle kind of symbolizes the SO2 group?
Yeah.
Okay.
Yeah.
Everything that lies on that circle is a part of SO2. Yep. I mean like the transformation that does that, the rotation for every theta. Yeah.
Yeah. That's right. I'm kinda confusing that SO2 is really looks like the circle, but I won't mention it here. It is not relevant. SO3, you can think about the rotational symmetry group of the two sphere. Yeah. I cannot explain it more, just think about the rotational transformations. So somehow in 8 dimensions, something strange happens that this rotational symmetry group is more is something different.
Okay. I will believe you.
Other group.
So this SO8 is the Lie group that corresponds to the D4 Dinkin diagram. Okay.
Yeah, that's absolutely correct.
Yep.
So there is a whole article about this phenomenon. The triolity phenomenon refers to this exceptional symmetry of the Dinkin diagram D4.
Right.
So I just want to mention that the word triolity here. So
triolity.
Yeah, there are so complicated explanations, but it somehow is related to the modified version of the SO8 group called Spin 8.
Wait, there was a donation by Wonder Ruiner 2 times. Thank you, Wonder Ruiner, for the donation. Yeah, I will work harder on the clocks. I will learn more in this stream. I will be a good math YouTuber. Thank you. Triality.
Thank you for the information.
Triality
Yeah.
in NLab. Okay.
Yeah, actually, NLab has sometimes more information than Wikipedia for advanced stuff. So
Right.
I like to, search in NLab.
Okay.
So this is really complicated mathematics. Spin 8 group contains spin 7 subgroups, which have 3 conjugacy classes, and they are permuted.
Mhm.
But this is all too hard, so I'll draw a picture that just symbolizes this phenomenon.
Okay. That's kind of okay.
Yeah. In this kind of way, you can feel the exceptional trial symmetry of these Lie groups.
Okay.
That's why I put in the 3 o'clock of exceptional structures.
Uh-huh. Right.
Yeah.
Okay.
I really love this one, and the next one is really, really complicated stuff for the
Right.
topological one.
Good.
Exotic R4.
Uh-huh. Could we?
Yeah.
Exotic
Yeah,
R4.
Actually, there is a Wikipedia article on exotic R4 solely.
Right.
This is really, really exceptional structure of mathematics.
Right.
So to understand the word exotic, you need to know about smooth manifold and topological manifold.
3 blue, 1 brown, more like 4 cyan, 1 black. That's amazing.
Yeah.
That's amazing. Thank you for that, chat. Okay.
Okay, so do you know what manifold is?
No, I think that is why
Oh.
this might be too hard for me. This one might be too hard for me.
Okay. I either don't know about the visualization of exotic R4. This is really, really hard stuff.
Mm-hmm.
Actually, I heard about it really formally, but not visually, so I cannot explain it either.
Okay.
But at least I can explain what this is related for.
Uh-huh.
So, a manifold is a space that is locally looks like a Euclidean space.
Right.
Maybe you have heard about this metaphor?
No. Not yet.
Okay. It's not a metaphor, actually a definition.
Locally looks like
Euclidean.
Euclidean space. Okay.
Yeah. Locally means that if you have a triangle, I can always use the Jai fish for example.
Yeah.
If you locally look at this part of Jai, then you can enlarge it to the line segment.
Mm-hmm.
This looks like a line. This is locally Euclidean
Right.
at this point. Yeah. But it is not locally Euclidean at, I'll say this point, since it locally looks like an X shape.
Yep.
This is just a union of two lines. This is not, homeomorphic
Right.
to any of RNs. But the homeomorphic is too hard words, so it does not resemble
A line. Does not resemble a line.
Yeah, it does not resemble a line or plane or space, any of them.
Mhm.
So it is not a manifold. So basically, you get a manifold if you can very smoothly attach these lines. So you
Mhm.
cannot have many choices in one dimension. So you can just try not to make a sharp edge like this. try not to make a intersection like this, then you get a one manifold. That's the basic definition and explanation of manifold.
Right.
But for the exotic phenomena, we need to clarify it that this is a topological manifold. Since we does not endow any more structures on this set, so it is only a topologically meaningful manifold.
Okay.
Then what is smooth? So have you heard about the smooth functions?
Smooth functions? I don't think what I know is that. I only know I don't know what that means actually.
Okay. That just means that a function is infinitely differentiable.
Oh, right. Okay.
So this is just a terminology that can be understood using calculus. Let f be a real function. It is smooth if and only if it is infinitely differentiable.
Okay, I got that.
Call it
C infinity.
Infinitely differentiable space.
Okay.
Yeah. So basically, for smooth manifolds, you want to consider differentiations on the manifold.
Okay.
That is the motivation for the smooth manifold. So basically, differentiation is defined on Euclidean space to Euclidean space, as learned in Calculus 2.
Zai read this. Catchy teeny ping. Zai? Okay. Anyway.
Catch teeny ping. Okay, so the differentiable functions are really easy to grasp. Like you can write down any expression that has no singular points. This kind of thing is example of smooth function.
Right. I think
really
x squared plus
I shouldn't really write down the denominator.
Yeah, okay. That works.
Okay, that's a smooth function. And for the smooth manifolds, you can generalize this kind of things to this kind of terminologies. In the general for the general smooth manifolds, we can define the term smooth function, which locally looks like a smooth function between Euclidean spaces.
Oh, okay. Now I kind of get what it means. Yeah.
Yeah, that's just the meaning of smooth function between manifolds. So you basically always wanna look at locally and wanna force them to make a great theory. So there are several conditions defining smooth manifolds, but I won't say it here.
Okay.
Topological manifold. So basically, that is the difference of two manifold. Topological manifold is just a shape, whereas smooth manifold is a space that can be used to do calculus.
So yeah, topological manifold was just imagine that's just a shape, and smooth manifold is something that we can use to do calculus. It's shape, but we can use it to do calculus.
Yeah.
Okay.
Yeah. Very right. So just a shape is meaning ordinary objects like planes, spheres, torus, or anything, and this is not a manifold. And smooth manifold is a thing that has more structure. This more structure is rigorously called an atlas. But anyways,
okay.
The point is that you can endo a structure more than one way. One way.
Okay.
That is a tricky part, but think it like this way. You have any set and you endo an operation, a binary operation, to make a group.
Okay.
I think you know the group.
Yeah.
Yeah. So the group is a special set that has a binary operation with some great properties. And you can give the binary operation however you want. So there is no unique choice. There are several different choices. Can you star? Can you asterisk?
Okay.
And like this, when you endo additional structures, there need not be one way. This is the similar situation that you can, except that you need to imagining the endoing the structure of calculus itself. So it is really not likely to be visualizable, even.
So how would this connect back to, I don't know, endowing something in R4?
Yeah. The definition of exotic objects in topology is just that. We usually endo a standard version of calculus on the manifold to promote it to smooth manifold.
Yeah.
So for example, for the R4 space, R3 space, we have standard calculus to make it smooth manifold. But if you endo another very strange structure, very strange calculus to that manifold, we call it exotic exotic manifold.
Right.
Manifold. So the term exotic R4 means that it is endowed with a very strangely deformed calculus.
Right. So, yep. And I think that's the only way I'm going to understand right now. It's just that it's a weird thing, a weird calculus on a manifold.
Yeah. Very weird calculus. I cannot explain it either since I can't understand it.
Okay.
Weird calculus. I just can read Wikipedia and how exotic they are. I can just say that these are really counterintuitive since some of the exotic R4s can be thought of as a subspace of the standard R4.
Okay. Small.
Yeah. So
large. Okay.
There is some way to visualize it. I guess we can take a very appropriate subset of this R4 space to visualize it, but I don't know how to do it.
Okay.
Yeah. I wanna tell this story. So the point is that exotic R4 is the only one that is exotic among ORN. That is the point.
Right.
The number of smooth structures possible, number of calculus on this topological manifolds possible are exactly one, very, very many, and exactly one, and so on. This is the only exceptionally strange case. R4 is the one that is strange.
Right. That is very interesting.
Really, indeed interesting. There are uncountably many exotic structures on R4.
Right. Okay.
I don't know why it is, but somehow 4-dimensional is really strange for topologists. So topologists wanna research topology using this as a standard point. So we cut the fields of mathematics, like this is the higher dimensional
Right.
topology, and this is the 4-manifold theory. This
Right.
is a whole very, very hard theory, and this is a low-dimensional topology.
Right. Right.
Yeah, that's why 4 is the standard.
Thank you. Okay. And
yeah,
I think we can skip 5 because I'm going to learn that anyway, and I
Yeah.
already know the gist of it. So, yeah.
Okay.
And I believe, like, if there's exotic R4, then, like, exotic N spheres could exist in other dimensions too. But, yeah, there are...
Yeah.
Even more than 4 and 7, I believe. Yeah, there would be more, but the smallest n that is not 4 is 7, so that's why it's 7 o'clock, right?
Yeah, right.
Okay, if that's...
So...
Yeah, if then I guess we could also skip the 7 o'clock, and if maybe we could, talk about 6 o'clock?
Yeah. Can I mention some fancy fact about 7 o'clock?
Yeah.
I just found this image of the visualization of the exotic S7. So
Exotic. S7 is a golf club. That is very exotic. Exotic 7 sphere.
Okay. I saw this, I mean, not very deeply, but I just skimmed this article. I didn't understand it either, but this looks very fancy.
Okay.
Actually.
I'll check it out later. NileJohnson.net. Right.
Yeah, thanks. So S7 is also a very fascinating object, as it is the first known example of an exotic spheres. So Milner found it, and the sequence of exotic 7 spheres is even more chaotic than the Euclidean one.
Okay.
So you have, okay, maybe this way is more engaging. I'll write down the sequence quickly. So for lower dimensions, you have 1, 1, 1. We don't know about S4 either. We know nothing about it.
Okay.
And 1, 1. And there are 28 exotic structures. And this sequence continues very irregularly. 11 goes 992. 12 is 1, 13 is 2, 14 is 2, and 15 we have 16,256, and 2, 16, and for 19 we have 523,264.
Wow.
And yeah.
Okay.
The sequence gets really chaotic. That was what I wanna mention.
Right.
Yeah. For 4K plus 3 dimensions, we have something goes wrong.
Right, right.
Yeah. Quickly go to 6 o'clock. For this one, I just wrote how can we roughly construct this auto-automorphism of the symmetric group of degree 6. And actually it is not very rigorous since I didn't fully understand it, but yeah, I just wrote down what I know.
Right.
I'll just explain what out means, and I won't delve into the construction.
Okay.
So, do you know about the group homomorphisms?
Yes. But
yes.
yeah. Kinda.
Yeah. That is the function from one group to the another that preserves the operation structure, which is a quick recall. And the group automorphism is the thing we want to focus on.
G to G, right? It
Automorphism
works on itself.
Yeah.
Yep.
Yeah, that's right. G to G. And it must be an isomorphism also. If only the function goes G to G, it is called an endomorphism.
Oh, right.
자기 소설. And if you have a perfectly same structure, then it's called isomorphism. 동형사상.
Right.
And if you have an endo and isomorphism, then it is called automorphism. 자기 동형사상.
Yep.
Yes. So that's what automorphism is. It is intuitively a symmetry of the object. So, for example, the jellyfish have the symmetry of the horizontal line, mirror reflection.
Yeah.
So basically, any transformation that remains itself, any transformation that remains itself is considered an automorphism in intuitive way.
Okay.
And since automorphism is a symmetry, all of the collection of automorphisms, this is just the identity function that remains jellyfish as itself. All of the collection of automorphisms forms a group. Yeah, so you need to find all possible transformations to calculate the automorphism group. This swaps this lower part and upper part of jellyfish. This remains unchanged. So this is called the automorphism group of the object.
Okay.
And is denoted aut. Yeah. That is isomorphic with the cyclic group of two elements. And yeah, in this way you can consider any object's automorphism group.
Right.
Like anything would possible. So very symmetric shapes have very fancy automorphism groups and so on. Maybe dihedral. Yeah, I'll consider rotational ones. Anyways, so if we consider a automorphism of group itself, then it is again a group. Yeah, it is again a group.
Okay.
So this is kind of symmetries of the symmetries, right?
Right. Symmetry of symmetries.
Yeah, it is just an intuitive phrase, but not very mathematical. Just symmetry of the group would be more accurate.
Right.
Okay. Group themselves. So what we want to consider is that the symmetry of the symmetric group. That is a catchphrase. Symmetry of symmetric groups.
Yeah.
When we consider symmetric n, then we
So
we think we know. Yeah.
Symmetry of symmetry groups. If that lies outside of the original symmetry group thing, then that's the outer automorphism.
Yeah. So you're basically right. You're right. But automorphism is a function from group to group. It is not contained in the group actually.
Oh, yeah.
Yeah. So basically you're right, but it is not directly interpreted as an inner object of the group. So define inner automorphisms, we need to think a bit more. I'll just write down the definition. I think it wouldn't take so long to understand, I believe. G is an element of the group G, and we define the function phi G as follows.
Okay, I wrote that
down.
down.
The theorem is that phi G is an automorphism of G.
Okay.
So basically, this happens since if you can consider two elements, then G inverse G inverse can be factorized into two conjugated elements, right? Yeah, that's why it is a group homomorphism, and you need to show that it is injective and surjective, but that's a
Right, I
tedious
get it.
boring part. Yeah. So this kind of automorphism is kinda very easy ones that originate from the group itself, which came from the group element G.
Yeah.
So your phrase is actually correct. Inner automorphism came from the original elements of the group. This phi G is called the inner automorphism. So if you have another automorphism of the group that don't resembles this shape, then it is called an auto-automorphism.
Okay.
Yes, so auto-automorphism really measures the non-trivial, non-obvious symmetries of the group itself.
Right.
Yes, so I will give you a quick example of auto-automorphism. Consider the good old friend Z, which is an abelian group. And the inner automorphism phi n stands Z to Z like this way. N plus X plus N inverse. Can you see that?
Yep.
Yeah, this is always an identity function. So inner automorphisms are always trivial here. But I guess you can come up with another automorphism of Z that is non-trivial. What would it be? Can you guess?
Automorphism that is non-trivial. We're talking about the abelian group of just the integers, right? I don't know, maybe just adding one?
Yeah.
What?
Okay. Adding one is a great choice for the bijective function, but unfortunately, it does not preserve the
negative
addition structure.
Yeah, right. So it's negative, maybe.
Yeah, that's correct. The negation operation gives the non-trivial automorphism. That corresponds to visually the vertical symmetry of this picture, and that gives the outer automorphism of Z. So the outer automorphisms form a group of two elements, which is isomorphic with the demo 2Z.
Right.
Yeah, actually, outer automorphism has somewhat more complicated definition since if we define automorphisms as a non-inner automorphisms, then they would not form a group. So to think out as a group, we need to consider more thoroughly. And ouch is in fact defined by the quotient group of the automorphism group, by the inner automorphism group. Yeah, that is a real definition.
Right.
But for the moment, you can just think of it as a set of automorphisms. I mean, non-inner automorphisms.
Okay.
Okay. So that is the technical part, but the whole point is that we want to measure non-trivial automorphisms of the groups.
Right.
Non-trivial symmetries of groups. That is the interesting part. There is a Wikipedia article of the automorphism of symmetric groups.
Wikipedia.
Symmetric group. There is a whole article on this subject.
Okay.
Okay. So you can see very strange phenomenon that outer automorphism of Sn is always trivial unless n is equal to 6.
Right.
Yeah.
For all n is not 2 and 6, it's just that. If n is 2, it's just that. If n is 6, is something weird. Okay.
Yeah, something is wrong with this case, and I actually cannot explain why n equals 6 is different.
Right.
My knowledge is also contained in this Wikipedia article. So there is a construction in this article.
Someday I will read it, right? Someday I will read it.
Someday. I don't know why, but symmetric group on 6 points is weirder since it has some non-trivial automorphism to itself.
Mm-hmm. Right.
Yeah, that's the point for the 6th class.
Okay.
Yeah, it is really only for n equals 6.
Right. So that was 1 to 7. We're going at 12 hours 45 minutes. Okay, let's see. Right. So which do you think you can explain quickly of the remaining ones, or more maybe like the important ones, maybe that you want to talk about?
Okay, so this is not my interest. This is the one that I don't understand either.
Okay.
And cosmology algebra is a complicated subject that is also closely related to Lie algebras.
Mm-hmm.
And Lemmer's problem is such an interesting conjecture, but how should I classify this? This is kind of properties of algebraic numbers.
Okay.
That is the subject.
Okay.
Yeah, that is the question that is about the smallest room for algebraic numbers. But I think it is, it can be skipped. And these two consist of the number theory, which is my favorite subject. Mm-hmm. This is related to elliptic curves. This is related to modular forms.
Okay.
And what can I mean, I cannot explain them in short times, but since I like this subject, I'll quickly introduce them.
Okay.
I'll try to quickly introduce them. Okay. So 11 o'clock is stated as a language of modular curves. So in number theory, here are 3 interrelated subjects.
Modular form,
and
elliptic
modular
curves,
and modular curves.
modular curves, and your nickname is ModularDiscriminant.
Yeah,
Okay.
it is an example of modular form.
Uh-huh.
So I'll explain it on 12 o'clock. Let me quickly remark that modular forms and elliptic curves are very famous due to the celebrated Fermat's last theorem's proof.
Oh, right.
Yeah,
That's
Wiles
what it
proof,
connects it.
yeah,
Okay.
Wiles proof connects the whole world of modular forms and whole world of elliptic curves.
Mm-hmm.
That maybe laymen would probably hear about these subjects. Modular curves are related to these two subjects, but it is not that this is mother, and this is son. This is not that kind of relation.
Mm-hmm.
I don't know much about modular curve theory, but this is I can explain what it is.
Uh-huh.
So we again consider the hyperbolic plane,
Right.
and we consider the tiling again.
Uh-huh.
We need to draw a tiling very carefully.
Tiling, that looks like that.
Yeah, I cannot actually justify this shape, but this triangle, I mean, yeah, it is triangle in hyperbolic space.
Okay.
This triangle has 60 degrees, and 0 degrees angle.
Okay.
Okay, and if we move this triangle, we get this large triangle, which is also have a 60 degrees and 60 degrees and 0 degrees angle.
Mm-hmm.
Okay, so the explanation is a bit not rigorous, but you can just intuitively think it as 60-60-0 triangle.
Okay.
Here's another 60-60-0 triangle, and this tiling gives the
Okay.
beautiful tiling on H2, and X0n. That is the guy in the statement. What
Right.
is X0n? Yeah. So
Modular
I cannot
curve.
tell you more. Yeah, more
Uh-huh.
than saying that X0n is a several pieces together of these triangles.
Mm-hmm.
I drew. So you basically concatenate 60-60-0 triangles, and you need to actually quotient these triangles using some appropriate law. Therefore, you get a surface that is compact, so it always lies into one family of this standard classification.
Okay.
So yeah, modular curve is a quotient of hyperbolic space by the congruent subgroup gamma 0 n, but explaining this is a technical term.
Okay.
So by pasting these triangular pieces, you can get some surface.
Okay.
And it has a number of holes. Yeah, that's the point. Genus. The number of holes, number of visual holes, not homological holes. Number of visual holes is called genus.
Right.
Yeah. So for every modular curve X0n, you can calculate its genus.
Mm-hmm.
Okay, so what would they be? Basically, n gets larger, the genus gets larger and larger, but this is the point. We get always a sphere until 10, genus 0 surface, and we get a first non-zero term in 11.
Right.
Yeah. Maybe this sequence goes like this, but yeah, actually you can click this link in the PDF file and go to the OEIS sequence.
Yep. That's 11th
Okay.
term is 1. Yeah, I see that. Right.
Yeah. So in the modular curve word, this x0n has the meaning of 11, and in the elliptic curve word, 11 serves as a smallest conductor due to this fact.
Right.
But yeah, 11 goes here to here using the relation. That's the remark.
Okay.
And the modular forms word. So 12 o'clock is the whole modular form theory.
Whole of modular form theory. Smallest weight of cusp forms of level 1. Okay.
Yeah. Weight and level and cusp forms. So how can I introduce the subject? I would need 1 hour to explain it, so I'll just give you visuals.
Right.
Eisenstein series. I really love these visual pictures that are pretty.
Me too.
Eisenstein series.
Eisenstein
you.
series. Okay. Eisenstein series.
Is the Gotthold-Eisenstein, which is also known as Eisenstein criterion or Eisenstein integers. You can go to Korean page to see
Eisenstein.
another information. Yeah, Eisenstein.
Right. And that's a pretty picture. That's a pretty picture.
Yeah.
And it's pretty.
Pretty.
And it's pretty.
Nice.
And that's a great introduction to modular curves and modular forms.
I maybe can explain one thing.
Right.
Modular forms actually satisfy very interesting functional equations.
F of z plus 1.
That's the whole point of modular forms. These two identities are the 4 properties of modular forms. And you can see that this means that F is...
that means F is like the first one, it's periodic.
Yeah, F is a periodic function. Thank you.
Yeah.
That is the property of the modular forms.
Right.
So basically you can see the periodicity period 1 in this picture.
Yep, the colors repeat.
In this picture.
Yep. Colors are repeating.
Yeah. So FC has a Fourier series expansion.
Fourier series expansion. Okay. Fourier series. Right.
Yeah, I guess you know the Fourier series.
Yep.
But we need to represent it in complex segments.
That's why it's all colored weirdly.
Okay.
The graph is all colored weirdly.
Yeah. Right. We have a Fourier series of... by the way, we usually define this function. The modular form theorists define this function.
Right.
Since this is the most basic function of period 1.
Okay.
Yeah. So we use that function to make our Fourier series. A -1, -1z, a0, a1, a2, and so on. And the technical condition of technical definition of the modular forms condition says that these terms are 0. That is the condition of the definition of modular forms. So we basically wanna consider something like a Taylor series. A0, A1,
Starting from
EZ.
0. Okay.
Yeah.
Okay.
This is exactly the Taylor series, since if we define the variable q, then we can see that this is a Taylor series for q.
Okay.
Okay. So I guess you got it. ENZ equals EZN, so QN.
Yeah.
Yeah. So modular form has all modular forms has their own Fourier expansions, and specifically, we can plug in q equals 0. Then we have the constant term, right?
Yep.
Yeah. So q is equal to 0. exp2 pi I z is equal to 0. So we need to actually limiting z to some infinity, but what direction can you say? What direction of infinity?
Wait, we're limiting z. Okay, we're. What we're. I mean, we. What?
Yeah.
We're sending z to what? Just negative infinity, right? Just. That's the only way it's gonna go to 0? What is.
Here's indeed I.
So. Yeah, okay, so z to, like, upward? I? To the I direction? Maybe?
Yeah. Yeah, that's absolutely correct. You need to go upwards. You need to go upwards to make it 0. So when we plug in, we just say we plug in I infinity, then we get q equals 0, and the modular form goes to the constant term.
Right.
That's why you see the constant color above this plot. Yeah. No matter what real part you have, you will get a constant if your imaginary part is
term if
sufficiently
it's
large.
sufficiently large. Right. Okay.
Yeah. That's
right.
That's the meaning of the constant term. And
13 hours, everyone. 13 hours. Thank you. 13 hours.
Yay. Okay. A0. So the definition of a cusp form is just that. The modular form with A0 equals 0.
Right.
So basically, Fi infinity is equal to 0.
Right.
So why we call it cusp form? That's because in this hyperbolic tiling, the triangles have this kind of shapes.
Wait. My donation worked. Wait. My donation worked for the first time. Donation alert worked for the first time. Oh my gosh. John Sai, thank you for the $2. Wait.
$2.
How does it work only that at that time? Wait. Okay, thank you.
Maybe $2?
Yeah.
If that's the difference. I don't know the difference.
Right.
Congratulations.
Yeah. Thank you.
Oh, thank you. Thank you for the donation.
Johnny says the 12 o'clock should technically say non-zero cusp forms to be really pedantic. Smallest weight of non-zero cusp forms of level 1. Is that would that be better?
Wow, you really got the rigorous point. Thank you for your critics. I really thank you for your
right.
Yeah, advice. Non-zero. I didn't thought about that.
Okay.
Non-zero cusp forms. Okay, I'll say non-trivial cusp forms.
아, 인천님 감사합니다.
Thank
아,
you.
돈에 필요 없습니다. 예, 마음만으로도
네.
감사합니다.
감사합니다. 여기서
Yeah.
okay. So the triangles here are a bit weird triangle, but we'll call these vertices as cusps,
Uh-huh.
since it generally means that some pinch points of a curve.
Right?
Okay. So the cusp form got its name since it vanishes at the cusp infinity.
Mm-hmm.
Yeah, that's just the etymology of the name. So we wanna consider the first non-zero cusp form of level 1.
Okay.
I won't explain the derivation, but the answer is the function called delta z.
Delta Z.
Yeah, which indeed starts with the 0 and 24 and then 255 and so on,
Okay.
which can be explicitly described as an infinite product.
Infinite product.
Yeah, that's really, really beautiful
That's
product.
Q times pi of that. Okay.
Yeah.
Okay.
So the interesting fact here is that 24 serves as a really important role here. It cannot be changed into any other integer.
Right. That's why it's
Yeah.
special. Yep.
Yeah, that's why it is exceptional again. And we just define the eta function as
Eta
its
function.
24th root. Yeah.
Mm-hmm. Okay.
And q to the 24th, 1/24th power is rigorously defined as an exponential function to avoid the branch cut issues.
Okay.
And yeah, so we have two interrelated functions that are really, really relying on the property of 24.
Right.
If we change this number, these functions would no longer be a modular form.
Mm-hmm. Okay.
The 24 magic, yeah, this magic gives some interesting mathematical facts around 24. That's why I love this function so much and made my nickname the ModularDiscriminant.
Okay.
This delta z is called the ModularDiscriminant.
Right. Modular discriminant.
Yeah.
And that, I guess, wraps up 12 o'clock, at least just a slight part of it. So, amazing callback to your name. Amazing facts about math. Yep.
Thank you for your... Yeah.
And we've solved the clock, right? We've solved the clock. And ignore that there's a conjecture, unsolved conjecture there. We solved the clock. And
can I explain about the center terms?
Oh, the center terms? I mean, I know about this one and I heard about this one, so yeah. I guess I don't think even you would know everything about sporadic groups, right? I don't think you would be able to explain all 26 sporadic groups, right?
Oh, that's right. Yeah, I will someday learn everything about sporadic groups.
Yeah.
Okay. Someday.
Right.
Okay.
And these are 26 sporadic groups.
Then.
Right. Amazing.
So my article, here has some information about sporadic groups, and I want to mention that the happy family here is defined as a set of subquotients of the monster group, the largest sporadic group.
There's the monster in the sporadic group, there's a happy family, and there's this remaining 6. Yep. Okay.
Yeah. Happy family consists of 20 sporadic groups. Happy family. And the whole number of sporadic groups is 26.
20 of 26. Amazing.
Year.
That is the year.
Yeah.
2026. 성인이신가요? 맞습니다. 근데 사람들한테 물어보는 거구나. Okay, whatever.
Okay. So
wow.
mathematics is very beautiful.
Yep.
Yeah.
That solves the clock.
That's the clock.
By the way, yeah, you have a sixth clock, but the sixth clock is the clock of clocks, and you just have all 6 of your clocks like a fractal inside of your clock. And I guess I wouldn't have to explain anything more about this. It's just your first clock, second clock, third clock, fourth clock, fifth clock, and then this sixth clock, which is this itself, right?
Can I remark something?
Oh, of course. If there's something special about it.
You're totally right. This is just a clock that is a collection of the previous submissions. But I just made some story about this clock on the comments.
Oh, okay.
So,
right. You first dreamt of 12 clocks, but you made you have to resort to 6 clocks, so these 6 are same as these 6. Right.
Yeah.
Couldn't do through the real life. Wait, I cannot see the right part of that comment. Okay. Here's one possible excuse. In topology, the surface that is gained by gluing the antipodal points in the boundary of the closed disk is called the real projective plane, RP2. I learned that today! If you regard the small clocks as instructions of how to glue the boundary of the whole clock face, you can notice that the whole clock becomes the surface RP2. I guess that's because these are all lines that go through the origin, and that kind of makes it like a projection, real projection thing. That's kind of how it's related. Okay. Now, this clock is a non-orientable surface like the famous Möbius strip. In the clock that is homeomorphic to RP squared, it is natural to use RP2. It's natural to use only 6 different small clocks rather than using 12 of them. If you don't get it, search hemidodecahedron in Wikipedia. It has 6 regular pentagon faces rather than standard 12, since it is an abstract regular polyhedron that is homeomorphic to RP2. A collection of half of 12 clocks makes so much sense in this way, as RP2 is one of the basic and important manifolds in mathematics. Speaking of topology, here's one more interesting fact. We can see that the clock contains itself. It's a fractal. Yes, this clock is the 6th clock, and it is in the 6th hour. Assume that the black boundary circles of small copies of itself are tangent to the original black boundary circle. I guess this is tangent to this, so it's just straight up tangent to that perimeter. Then since this clock repeats itself infinitely, there would be an infinite number of smaller and smaller tangent black circles in this clock. What? Let X be the union of all black circles. Regard X as the subspace of R square, or R2. We don't think about the RP2 thing. Okay. Just the union of one big circle, 2 small circles, 4 smaller circles. Is X a closed subspace of R2? So, closed subspace. Is it open or closed? I believe if, like, can you make a small set around here that's kind of open? Wait, if it's tangent, then it all resolves to this one point, and it's included in the boundary, right? But wait, if this is fractal, there's also a small circle to the top of the circle, right? And wait.
Yeah.
In that case, maybe if we alternate, like if we go down, then in the small circle we go up, and then in that smaller circle we go down and stuff.
Yeah.
Then maybe we get to a point that is not contained in the set. Maybe.
Yeah, I thought like that too. Yeah, maybe. I really didn't solve my exercises rigorously. So,
oh, right. Okay. That's for the viewers. That's for the commenters. Everyone in the comments. Is X path connected? Is it locally path connected? I mean, it's connected. Like, I don't know. How does the fundamental group
I don't know what that is. Universal covering effects. Cause her search about the Hawaiian earring. And that,
Yeah. So, can you see my screen?
of course. Right. This is what
Yeah.
the set looks like. The circle
Yeah.
inside circle.
Yeah. The intended. Yeah. Right. So I actually dreamed to make a 12 clock of clocks.
Yeah.
So in that case, it would resulting in more simpler space.
Just up, 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 up. In that case, it's this is definitely closed in this case, right?
Yeah, you're right. It's closed. I originally thought of these problems considering this space.
Right.
So, well, the problem would be more harder for this.
Yeah,
space,
I think if you go like down, up, down, up, down, up, then it results in like you can't make like it's how like you cannot make 1/3 by doing 1/2 minus 1/4 plus 1/8 and stuff.
Yeah.
Yeah, so I think it's gonna be an open set.
You're right about the non-closed argument. This is not closed.
Oh, yeah, not closed, not closed. I don't mean like I mean I don't mean open. Yeah. Not closed.
Yeah. That is correct. So I think we need to consider like a contour set like structure.
Yeah.
Here for these points. And I didn't really thought about it very deeply. So maybe you're right.
Zai, can we get these solution PDFs and your piano sheets? Yeah, you can get these solution PDFs. Maybe ModularDiscriminant will like I can post like a link here and like, even in the Yeah. I can do it. I'll do everything once I have time. Yeah.
Yeah, it is possible to publish since you know what, I actually wrote this whole article in the comment section of the 5th submission.
Oh, really?
So
wow.
It is really long comment.
Wow.
So it is indeed public.
Okay.
At this time.
Okay.
You can publish it at any time. Okay. So I just wanted to mention that Hawaiian earring space.
Hawaiian
since
earring?
I learned it on my last semester. Hawaiian earring. Which is one of the counterexamples in topology. Its fundamental group is really chaotically shaped.
Okay.
It is the space that does not have universal covering, but I think we'll need more explanations on this one. I'll just mention that there can be really exceptionally complicated path here. I'll just convey the point. So normally you will, when you consider the closed curves here, you will normally traverse these circles and come back to this point. And you will traverse the finite number of circles, right?
Right.
Yeah, that's the continuity is about. You must traverse finite number of circles when your space is like this.
Right.
You can only traverse a finite number of circles in finite number of time. But in this Hawaiian earring, you have infinitely many smaller and smaller circles.
Yep.
So in finite time, you can traverse infinite number of circles.
Oh, right.
Yeah. That's the whole point of this exotic space. You can go through like this and it is really possible to do, curve every circle in finite time.
Okay. Right.
Yeah. That's why its fundamental group is really complicated. And That's why it is on counterexample. So in this clock of clocks, I wanted to make a fractal structure that shows this example.
Okay.
That's the end of my class.
Right. That took 3 hours flat from 10. Okay. If I need, that's including the time I spent eating dinner, but yeah. Anyway, thank you for this monstrosity of a clock. That's a solve.
Yeah.
And thank you for being here today. I only asked modular discriminants like today about being in the video, being in the stream, but yeah, thank you for coming to the stream. I learned a lot today, and yep.
Yeah, really fun today.
Thank you for the submission.
Thank you for reading all my long articles.
Yep. Right. So I will be continuing. Thank you. We like any final words to the viewers before we end the call.
Final words. For
Maybe
the fifth plug, I really enjoyed making the fifth plug since it really consists of the subjects that I'm interested in. So if you are engaged by this clock, then maybe you will someday, viewers will someday feel the beauty of mathematics more. I hope that everyone can feel the beauty. Thank you.
Right. Yep. I hope this we can explain this in a more easier. Maybe I'll learn this, and maybe I'll find a way to like maybe not as rigorously, but just get. Maybe I'll try to find a way to explain things more beautifully. Yep. I hope people learn about the beauty of these stuff. Thank you so much for being here today. 감사합니다.
Thank you.
Right.
저 근데 혹시 이게
yeah.
다른 이제 아글링님이랑 다른 분들도 뭔가 같이 푸시는 거를 이제 하시는 걸 봐서 약간 저도 뭔가 같이 계속 푸는 걸 하는 건가도 궁금했었는데 혹시.
뭐 계속 같이 푸시고 싶으신가요? 어떻게?
뭐 새벽 몇 시쯤에 자러 가긴 할 것 같긴 한데.
그렇군요. 근데 지금 당장 이제 또 다시 그러니까 제일 어려운 시기에는 이 맨 마지막에 있어서 내일 아침에 오시면 될 것 같습니다. 그러면 만약에 정말 참여를 하고 싶으시다면 그리고 안 와도 당연히 괜찮고요. 네.
예.
네. 감사합니다.
뭔가 그러면 내일 아침에 한번 자고 와보도록 하겠습니다.
네네. 감사합니다. 네. Thank you.
Wow.
Okay, that was an insane Discord call. Wow, we are at 227, and we have up to 253. It's going to be a long night today. I'm going to go to the toilet real quick. Toilet. Wow. Thank you for a toilet. Big toilet here. Let's go to the toilet. Okay. Ah. Hello. Okay. Okay. It's time. Wait. Toilet. Let's change that to math clocks. Put it there. Okay. Korea is going to bed now, and America is slowly waking. Let's see if our friends have woken up. Let's see. Bam, bam, bam. Okay, good morning from USA. So now... Bye-bye. Good morning. Yama, bye-bye Yama. Hey, GD. Good evening from the Middle East. Nice to be in the Baltics. Poland is doing neither. Hello. Okay. What? Let's set things up again. Let's see. Refresh PNG tuber. What did I miss? Not much. Because I just went to the toilet. Anyway. Good night from Jeonju. Good night. Oh, you missed the 3-hour lecture. Right. So we are right here now. Notice the increase of time. So notice the time. Yeah, this is how it went. Now we are back to Marmalicious. And I'm gonna eat a sandwich while doing this because I need the energy. This is 12:27 a.m. That's a good sandwich. Good sandwich. Okay. Give you the sandwich. Okay. Wait, you're in the call right now. Wait, numberbasher, you have to. It's time to choose. Actually, I just said I'm gonna do Marmalicious, so I'll probably have to do Marmalicious to for the promise. But it's possible you are in the call. Right. Okay. Bam.
Hi.
Hello.
Yeah.
This is ModularDiscriminant. I mean, after ModularDiscriminant, we have Marmalicious, and in the voice call we have Sunny, also known as numberbasher. Hello.
Hi. Hello, I'm back, I guess.
But you haven't slept right now, right? You are in this like a similar time zone as me?
Yes, I'm in a similar time zone, but my sleep cycle has already been completely fucked.
Wait.
I have no idea when I'm going to sleep.
In that case, okay, you have to determine whether you are going to. We want to do your clock and early or late.
that becomes a problem because I don't know when I'm gonna sleep. Because my sleep cycle. Okay. Since you promised to do Marmalicious first, you may as well continue. But maybe you can look at mine after that, or I mean, if it makes sense.
Right. That's possible. The next one is Moldovalan. So bad news to Moldovalan, because Moldovalan's clock will be delayed by a lot after that. Moldovalan is not in Discord right now, maybe. Okay, but anyway, this is Marmalicious's clock. And let's look at this for a bit. I've studied for this yesterday as well. I mean, I could not study for ModularDiscriminant's clock because there's no way I can study 4 years worth of math in one day, but I've studied for this one. Okay, so the kissing number in 3D means how many circles can you put around how many spheres can you put around one sphere that touches the sphere. Like you can put a lot of spheres around the sphere. And of course, these spheres all have to be the same size as the original sphere. So like you can put a lot of spheres, and then the kissing number is like the most number of spheres you can put around the sphere in 3Ds, and that is 12. We can check that in Wikipedia. Kissing number. It's in one dimension. It's like in a line you can only put 2, so that makes sense. In 2 dimensions, like you can put 6 at most. In 3 dimensions, it's 12. But it was very difficult to establish why 12 is the case, so of course we're not going to prove that 12 is the kissing number. Now, let's look at this one.
But yeah, just to add on, it looks like an icosahedron's vertices.
Oh, right. So, icosahedron, or like I don't know, sphere packing. Icosahedron. And you get something. Yeah, that's a nice visualization. Yeah, this is how it looks. Yeah, it kind of looks like that. Yeah. Now we have 2026 equals k minus k divided by k minus k divided by k minus k over 2026. And like here we can just calculate this one. We divide this by k, and wait, that's actually really neat. Divide this by k and we get 111. Also, if anyone wants to join the Xcali draw, maybe I'll post the link here in the
You should not be showing that in stream. Oh wait, does it? Okay, it's not the full thing. Thank God.
No, it's not on stream. I of course changed it on the stream. You are watching my Discord stream, which is different from my actual stream.
Okay, yeah.
Yeah.
That is true.
So
that is true.
So this is.
Anyway, hi.
Hello. Okay. This is asphalt. Okay.
The stream started when I went to school, and now it is almost midnight, and there's fireworks going on because Chinese New Year.
Yep.
Yeah.
I'm actually so happy I managed to just completely fill my Chinese New Year with having a fever and solving clocks that I didn't go to any parties. That is actually a humongous save of time.
Amazing. I hope you get better.
It has fully recovered, but at the expense of my sleep cycle.
Right. If we plug in 1, we just know that it works because this is -1 over 2025. So this is 1 plus 2025, which is 2026. And I'm just going to leave it at that. Maybe there's another solution because it's a quadratic, but I think, yeah. Yeah. This one is bam. And we put that in Desmos. We put that in Desmos and it becomes...
Oh boy.
Good Desmos.
Whoa. Integral 0 to infinity.
By the way, asshole, you know you can change your name on the top right corner with share. So you can be no longer incomparable ferret.
ln x 2. Surely they know how to solve this. Wolfram Alpha. And it's almost 2, and that's just, yeah. It is 2. This is 3. Pi. Floor.
Topic of math, I literally had an additional mathematics exam today.
Wait, you had an exam yesterday?
No, today.
Today, right.
It wasn't actually that hard considering I'm in this stream.
Right.
Okay, back to the stream. Going off topic.
Okay. Wait, so you are done with the exam, right? You don't have an exam.
I am done.
Yep.
I am done with the exam. I still remember the questions from the exam.
Right. And I learned how to solve this by the help of numberbasher, and actually, maybe not. Maybe I haven't learned how to solve it, but
here you apply what we call Simon's favorite factoring trick, which I have no idea why it's Simon's favorite factoring trick, but it is. But you rewrite this as x minus 4, y minus 4 equals 16. And since you want integer solutions, that's just free.
Right. Wait, that always works. Yeah, why am I not thinking of that? Okay, that always works. Right. So it's called Simon's favorite factoring trick?
Yeah, when you just make up a factor to make a factor. Make up a term to make a...
So, like, it's 5 because... Yeah. Okay.
Yep.
1, 2, 4, 5, 4, 8, 16. 1 divided by probability that all 3 men survive in. And I've searched for this, and this is... Where is it? Okay, So, this is an Indian film, I think. And I don't know if this is like, if this has any copyright, but this is from a movie and I don't know of this movie. I don't know if anyone in the chat will know of this movie. There's some kind of, I guess, villain. They grab a pistol. There are 3 men standing here who are like, I don't know, captives. And the villain is trying does a Russian roulette to like kill these 3 people, and I think you heard that he just shot 3 times. So this is a fully loaded gun with 6 bullets. There are 6 rooms that bullets can go in. You know, the Russian roulette. He just shot 3 consecutive shots, right? And then he spins the thing, and then he spins the... What do you call this? The thing. And then what he does is this is like now random, right? Now, originally, the gun has 6 bullets, but now he has shot like 3 of them, so like consecutively, so 3 of them are empty. And now he's spun it in a random way. And now he's gonna shoot 3 people in order. So like bam, bam, bam. And what is the probability that all 3 men survive in this Russian roulette? So like, if we should shoot people 3 consecutive times, then if for all of them to survive, then it should, when you randomly spin it, it should exactly land on this first blank spot, right? So it has to be blank, blank, blank. So this actually happens in the movie. So this, I don't know, I believe this is the villain, and the villain just does all sorts of like, like, I don't know, villain stuff. And then the gun just misses 3 times and all 3 people survive. And he's just like confused. Why does it not work? Just the villain's just confused and all 3 of them survive. So this is, the probability is 1/6. So this would be 1 over that. So this is 6. So I believe we just did this number of ways to make 3 in a row. I mean, not just, but like when before you went to bed, I think. So we did 3. There are 7 ways to make like the 3 by 3 by 3 tic-tac-toe. Starting from 1 corner, I believe. And number of ways to make 3 in a row. So it's gonna be like, is this a factorial? I don't know. So if it's going like vertically, there can be 9 possibilities. If it's going in the X directions, if it's going in the Y direction, there's also 9 possibilities. And then there can be like these rotations, right? And these rotations, and these rotations, which means there's 6, 1, 2, 3, 4, 5, 6, and for each case, you can have like one that goes like this, one that goes 1 further down, and one that goes 1 further down, right? So that's 3 times 6, and then you have these corner ones. And there are just 4 ways to make 3 of them, so that's plus 4. So it's 27 plus 18 plus 4, which is 49. And I believe this is not a factorial, because if we just ignore that, then root 49 is 7, and that's the answer. Wow. Number basher is bashing numbers here. Number of solutions.
Living up to their name, huh?
This is way above 9 solutions. This is
really
way above 8. This is not working. So there's something that is not.
We have a donation.
Wait. Thank you! Lime trees are cool! For the donation. Wait. I also... Yeah. Thank you. Thank you. Love your dedication. Thank you so much. I will work hard on the math clock. So bashing numbers is working. There has to be 8 solutions here, by the way. Yep. Every number can be represented.
Like 8, so that's not working. There's like already 8 ways in a subcase, and then there are just more subcases. There are 8 subcases, and the first subcase is 8 solutions.
Right.
So that's not working.
Right. Okay.
I'm not seeing an easy way to fix it as well.
Every number can be represented by a max of 9 cubes, and this is just a solved problem called Waring's problem. And every rational integer of something, 9 of third power, so cubes of positive integers. Every sum is 9, sum of 9 cubes. And I think it's been proven that 23 and 239 are only numbers that require 9 cubes, and everything else can be represented by 8 or less cubes. For example, 23, we can do, so 3 cubed is 27, so we can't use that, right? 2 cubed is 8. We can do 8 plus 8, then 7 ones. So because this is 16 plus 7, and that requires 9 cubes. And this does like something similar, but other than this, everything can be represented by less than 9 cubes. Number of ways, wait, so this one, age at which Russell started Euclid? Age at which Russell started Euclid. I guess Russell started Euclid at 10. So this is just 15, I believe if it's all like that, maybe you're supposed to be doing like, what would this be? 10. It's actually not to scale, it's much bigger. If it looks like this, then this is like, what? Actually, I don't know if this was in the middle, then I can solve it quickly, but if it's not, I don't know. So maybe I just do, maybe I just do a little bit of algebra. Y equals 1/3 of x, and then here we have y equals negative x plus 15, and then it has to meet at 15 equals this, so 45 divided by 4, and that means this is 15 divided by 4. So 15 divided by 4. This is 5. We don't have to find the area of the quadrilateral. Really? But I've already done it. What? I'm area of the triangle shaped one. We don't have to find the area of the triangle shaped one. Equal to the area of 2 times 15 times 5 minus 4 times area of the small triangles Okay. 225, that's a big thing. Minus 2 times 15 times 5. Uh-huh. Wait. Uh-huh. Right? Minus 4 of the small triangles, right? So that's why I was wrong. Bam. But what if I already solved it? What if I solve it? And what if it's 90? Why is it?
I also do get.
You also got 90?
Yep.
Okay. This is 90. For some reason, this is 90. Number of ways to tile 3x4 rectangle by 2x1 dominoes.
Oh my god, my drawing below is just completely lagged out. Damn. Just here.
Oh wait. Oh, I don't see that. My screen is completely desynced with yours, I think.
What?
I think everyone's screen is.
I don't see the red boxes anymore.
Okay, we are already desynced. Okay.
I'm just gonna finish this and hope.
Yeah, we're just gonna
Wait,
do it.
I'm just gonna screenshot this after I'm done.
Right.
Oh my god, that's not supposed to happen.
Okay, so these are when you divide it up to 2 big parts and do, yeah, and each part can be represented 3 ways. This is what you have. Yep, that makes sense. The 2 exotic cases. Exotic cases, just like how R to the 4 is the only exotic, what was it?
Manifold?
R to the 4 is the only exotic manifold. It has an uncountable number of calculus structures. And top topological manifold is the shape, and smooth manifold is the shape with calculus, and you can endow structure more than one way, right? And then that's why it's 11, and that solves the clock. Zai, are you an exotic fish? Maybe. I'm a robot fish. Okay, thank you, Marmalicious, for submitting that clock. This is a really cool drawing. Thank you for this. Amazing artwork. Let's...
Also, since Moldavala is here, I suggest we look at Moldavalas first.
Okay, let's look at Moldavalans.
Isn't that the... Oh my...
Instead of postponing it by 3 hours.
Yeah. So, this is Moldavalans. Abhorrent clock. Cosine clock.
I love how this is just... Yeah, this is just Wolfram Alpha entering exercise. Good luck, Zai. We won't help you here.
So, okay, if you're not gonna help me, I'm gonna stop the live collaboration because it's lagging.
There's not much point in collaborating with this. I was gonna say flag clock.
Bam. Okay. How big am I gonna need to zoom in? Okay.
White.
Can I open this in a new tab? I don't think that's a better resolution than this. Maybe it is. It's kinda. But okay. Maybe I'll copy that. Paste it on top of this. Like that. And a bit bigger. What if I just start from 12 o'clock? I just start from 12 o'clock. By the way, it's not cropped off, right? Okay. What if I just start from 12 o'clock? Okay. Okay. Okay.
This is just diabolical.
Okay. 4.
By the way, according to edit notes, there's a cut off plus sign in this third row of the 12 entry.
Okay. I'm gonna have to cosine.
Hey, you know what? I'm gonna deafen on Discord, and I'm gonna listen to the YouTube stream music.
Okay. Okay, I'm gonna write some important numbers down. So, cosine squared of pi over 12 is this. Okay. And Okay. How much? I mean, do you think Desmos is better than Wolfram Alpha for this? I think so. I think so too. Yes, I think so.
I love how Zai is just saying, I think so. I think so too. I love how Zai is just saying.
Okay. Everything is fine with Desmos. Hello, Desmos. Would you be interested in solving 2 cosine pi squared to the power of 8 times cosine squared of pi divided by 12 minus cosine pi divided by 4 times cosine pi divided by 12 plus cosine to the squared pi divided by 12 minus 2 cosine pi divided by 4 cosine pi divided by 6 cosine pi divided by 12 plus cosine squared pi divided by 6 cosine squared pi divided by 4 divided by 2 to the 4 cosine squared pi over 12 minus 2 to the 5 cosine pi over 4 cosine pi over 6 cosine pi over 12 plus 2 to the 4 cosine squared pi over 6 cosine squared pi over 4 is 3. The next one is 2 to the 2. 2 to the 2. Can you see it in 2 to the 2? I mean, let's just write 4 at that point.
Imagine if everything just was 0.
4 times 16. Yeah. If it's like a bunch of cosines and there's a cosine pi over 2 hidden in the equation, I'm gonna break the monitor. Cosine squared pi over 12 minus 32 cosine pi divided by 4 cosine pi divided by 6 cosine pi divided by 12 times that's 16 cosine squared pi over 6 cosine squared pi over 4. Okay, it's wrong. Is there a chance? I think there's a chance. I think that's a chance. I think there's a chance there's a plus here. Maybe this is what they meant by the third row. It's not this. Maybe it's this. I don't know.
No, it was the place below.
Wait, really? Wait, but this is wrong. I think I found that's a typo too. I think it better be, because this better equal 1. I mean, no, this better equal 2 or something. We have 4 times 16 cosine squared of pi divided by 12 minus 2 to the, what in the world would that be? Is that 1 minus 2 plus 6? Maybe. Cosine pi over 4, cosine pi over 6, cosine pi over 12 plus 16 cosine squared pi over 6 cosine squared pi over 4 bam 2 cosine pi. Actually, wait, do you know? Okay, here's what a programmer does. This is what a programmer does. Auto hotkey. Edit script. Okay. So what I'm gonna do is hot if win active Desmos, and then I do I don't know, I do a, what should I do? Let's try F6. Send.
Just remap.
Yeah, remap what? Remap.
Remap it into cosine of pi over.
Yeah. That's what I'm thinking.
Like, for pi over 4, pi over 6, pi over 8, and pi over 12.
Yeah. I'm gonna have... Let's try... Let's see if this works. Reload script. And let's see... F6. Yep, that does it. That almost does it. Oh, I shouldn't have pressed this. Okay, let's do... send cosine pi over 6, and then F8 is gonna be, oops. F8 is gonna be send cosine pi over 12. Wait, I need to press the right key between the denominator and the parenthesis, right? I forgot how to... Wait. Wait, how do I send the right key? How do I send the right key? Enter F. Launch left? Maybe just right? Maybe just right. Maybe this works. Let's see. So, let's see if I want to F6. Oh, I didn't reload the script. Okay, I reload the script and I press F6 and that does it. Okay. Bam. We've got cosine pi over 4, pi over 6, and pi over 12, ladies and gentlemen. Let's continue. So where were we? We're in the third one. 2 cosine times 8 times... Actually, we should do cosine squared and cosine separately, but wait, actually, here's what we do. F... F... We have, how many F's do I have? Let's not do that. Let's do a, F... Yeah, let's just... Maybe this is the better play. Maybe this is the better play. Maybe this is the better play. And reload the thing. We have F6 and F7. Okay, F6 and F7. What are we gonna do? We press F7. Wait. Okay, F7 does that. I shouldn't use F7 actually. Actually, wait. Is this not supposed to be... Right. Shift 6. How do I do Shift 6 in... How do I do Shift 6 in this stuff? Shift, okay. Okay. +6 maybe? I do a +6 there. And this is gonna be... I reload the script. Bam. Press F7. Yep. And it works. Minus... and... minus 2 cosine pi over 4... Cosine pi over... Oops, pi over 6. Cosine pi over... Oop, I need to remember to press right after that. Cosine pi over 12. And then plus cosine squared pi over 6. And then cosine squared pi over 4. Right. Right. Okay. This better be 1/3. Minus this better be 3. Okay. Okay. I don't need you anymore. Don't need you anymore. I'm certain that I'm correct, so... 2 cosine pi over 4 times... Hey, I should do this times 8. Right. And then... Cosine squared... minus cosine pi cosine 12 plus squared 12 minus 2 4 6 12 plus square of 6 square of 4. I then do 16 square of 12 and then minus 2 to the 5, 4, 6, 12, plus 16 times square of 6, I think? Is that a 6 or... 6, maybe? And then another 4. And that is a 3, minus 1/3, this is 12. Okay, let's go. 1 o'clock is 1. That is root 2 squared is 2. It's gonna be... that's 3. That's 2. 2 cosine 6 pi. That's gonna be... 2 root 3. So, bam bam. That's root 3 squared. That's 3. Here we have... Cosine. Oh, I need to solve for x and the question mark. I need to solve for the question mark.
Did we ever read out Rebar Consumers donation?
Oh. Hello. Oh, Rebar Consumer donated. Wow, thank you. Math is cool, I guess. Thank you so much. Thank you so much for the donation. I will use it wisely and creatively. Thank you. Math is cool. Math is cool.
Math is cool when you're not on a clock with hundreds of cosines.
Is suffering. Math is suffering. Math is suffering.
Math is suffering and math is both a subset of suffering and cool.
1 minus.
In fact, I claim that math is precisely the intersection of these sets.
X over 15 is insane. Wait, actually, it's just sine. Why am I just... I don't know. My brain is so fried. I'm not able to discern what sine is anymore.
I can tell. I can tell.
Cosine, so that's tangent. That's going to be tangent pi over 5. Okay, let's rewrite this too, because that's simpler. Like that. And this is going to be tangent x pi over 5. Alright. And 1 minus that. So this is going to be tangent something. So it's going to be tangent x plus 1 pi. X plus 1 pi over 5. That's what it's going to be. And that has to equal tangent of 7 pi over 15, right? So that means x has to be like this plus pi something. I don't need you anymore. Wait. So what am I even solving for? There are multiple solutions, right? So maybe I just go for this and it solves to this, maybe? But then that doesn't make sense because it's 4 over 3. So maybe I'm wrong. Oh, I'm wrong because this is x. Okay, I am very wrong. X, yeah. It has to be this. Okay, now I understand it's x equals 4 and other stuff. X equals 4 plus 15n or something. 4 plus 15n. Okay, 4 plus 15n. I think. And now we have... Oh my... I have to rotate the clock. Maybe I don't. Because I can just rotate my neck instead. And receive neck pain. 16 cosine squared 12 and then minus... What's that? That's another 32 cosine. Why did I type it? I am never typing it again. 6 and 12 plus 16.
I just had an idea for a clock. We should make 1 out of 2026, and then make 2 out of 1, make 3 out of 2, etc. And then make 12 out of 11, and then expand out the entire fucking thing.
Expand out. Right. Do not make that. Do not make that. And Boom, boom. Bam, bam. That's 2. 2 plus 2 plus 1 equals 5. Did I just actually type out the same thing? I wasn't sure if it was the same until I typed everything out. Because, like, I was unsure if there was any number there different. So after I typed it out, I realized it's the same. Okay. Let's see. If they are reusing this, if they keep reusing this, then maybe we can prematurely change all of this in other places. Yep, that's a 2. This is a 2. So yeah, we solved that. And here, yeah, that's a 2. And what do we have here? That's the same thing as what was there. Yeah. This is 3. This is 3. So this is 3 squared, so we get 9. Actually, amazing discovery. Absolutely amazing discovery. This is a 2. This is a 2.
We're actually making quick progress here.
This is 2. This is a 1. This is a 2. This is a times. 2 plus 3 times 2. What?
Well,
Okay. Bam. Where does this connect to? This connects to here. This connects to here. This connects to here. So it's 2 plus 2 plus 1 times 2. So it's 10. Okay. Okay. We have... It's the same thing. It's actually the same thing. I'm looking at it. Yep. Yep, it's the same thing. It's 3. Plus, what is this? This is 4 times. Yep, this is 2. 3 plus 4 times 2, that's an 11. And here, all we have left is... That's a... That's the... No, that's only the numerator of this. But this is a 2, so this has to be a 6. Okay. Okay. This is a 6. This is a 6. And then this is a 2. So 6 plus 2 over 2, that's the 7. And then here we have... That's the 6. That's the 6 part. Wow. Okay. That's
Yippee.
Done. Done. This is not the way it was intended. If it was not the way it was intended, you shouldn't have copy pasted. Right? You shouldn't have copy pasted. You also, what is this? If you zoom in and out really quickly, you can kind of read it. No, I cannot read it. That's a solved clock. That's a solved clock.
I'll see if I can pull the image up. But meanwhile, you can descend into the 9th circle of hell.
Right. Actually, is Mr. Funny Sheep in the chat? Because if they are in the chat, this will be a big disservice to them because we're changing the order because if I do the hardest clock at 9 a.m. in the morning tomorrow without sleeping, then I wouldn't be able to do it. So I need to do it right now, I think. I have to do it right now. So I have to open the very hard clock. Very, very, very hard clock. So... I mean...
Okay, if you zoom in on the Moldovala thing, it says, Moldovala, please watch Bluey.
It's Moldovala, please watch Bluey? Please watch Bluey, okay? Okay.
Okay, my clock has 1 or 2 erratas, which... Major
Really?
erratum.
Okay.
Clean that up.
230. The unfortunate thing is, I cannot like do this automatically. So we have to go through 20 like this is just bubble sort. We are bubble sorting you up. We are bubbling you up the the timer.
That is very. We shall also temporarily change run category to very, very hard. or not circle of hell, whichever is more convenient.
Bam, 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 bam.
Oh god, this is gonna be fun. This is great streaming. I stayed up till, well, I mean, it's 12 a.m. for me right now. Stayed up to
253 number basher. Bam. We have 253 in front of 230 right here. And we're gonna look at number basher's clock, which is this clock. Wow, that's very simple. Okay, let's look at the...
That's not that hard.
Yeah, it's not that hard. It's really easy. Okay, let's quickly get done with this and move on, actually. It's 8 to the power of 1 divided by 2 minus pi, and then ln pi squared? So how much is that? Well, 0.1, 2, 3, 4, 5, 6, 7, 8. That's amazing. Wow. Wow. 1, 2, 3, 4, 5, 6, 7, 8. And then we have square root of pi. So pi square root 7, and put that all 1 over pi plus 6 times ln 2 minus 1, I guess, minus 6. And what is that? That is 0.12, 11, 10, 9. Oh, 1009. And that solves the clock. Amazing job, Number Basher. Right, thank you for that clock. We're gonna be moving on to... If only that was the end. There is an unofficial submission by Number Basher, which I will not be grading along with the other clocks because I despise this clock. So,
there are a few erratas which I shall just read. Problem 4 should not just be the number mod 12. It should be the number of 2's mod 12 for question 4.
Wait, question 4
should be the number of 2's in the 2026 positive integer. Number of
2's.
And then problem 7 should change the 5 to 4. Within 5 steps to within 4 steps. That is not 7. Oh,
wow.
Oops, then I'm in
8. Okay, the answer to this is 7. Okay, so the answer to this is 7. Within 4 steps of the original position of the wolf, mod 12. Okay, so as you can see, whoops, my numbers fell out. Guess you'll have to fix my clock. We have problems 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and Number Basher's just slipped up saying this is the 7th problem, which means it must be, the answer must be 7.
I did not. And in fact, I can tell you that the answer is not 7.
Okay. By the way, how do you mod the probability by 12 and get an integer.
Probability can be represented by A divided by B, where A and B are co-prime, and B is co-prime with 12. You take A times the modular inverse of B.
Right. Okay. So I printed this out. I've printed this out. I have a notepad. So, okay, let's go through the problems here. Consider the unique 3-digit number ABC such that ABC is equal to AC squared.
I also will allow programming just because you're already doing it anyways.
What'd you say?
For me,
what'd you say?
I will
run
allow programming.
784. So the unique 3-digit number ABC 784 is equal to 7 times 4 squared. Amazing. And the unique 5-digit number such as D, E, F, G, H is equal to D times F times H. Bam. And let's do...
I will allow you to use programming, even though I can't see it on the screen share.
Bam. E equals N. Bam.
I assure you that programming is designed not to help with the majority of the questions.
Right.
Okay, they are designed to help, but not help in a way that makes it not the 9th circle of hell.
Right. Let's see. 82944. I'm not even gonna check if that's correct. Maybe I will. 8 times 9 times 4 squared. That will be 82944. What is root ABC plus? That's just so. What is 28 plus 894 922 mod 12?
The square root
it's
of
not.
8
Wait, it's not 894. It's 8 times 9 times 4. Bam. It is 4. It is 4. I do need to check it again. 8 times 9 times 4. That is true. 20. That's true. Root ABC is that. Root DFGH is that. Mod 12 is 4. Okay. Problem number 2. What is the maximum number of spaces that can be covered by non-overlapping L trominos in a 2025 by 2025 grid? Mod 12. Non-over tromino covering. L tromino covering. What's a tromino? That's L tromino. That's an L tromino. Reptiling and Golem's tromino theorem. If any, okay.
It is designed to be perfectly doable without research.
It's designed to be.
I did not. Yeah, I did not design with research in mind. Okay, like researching this problem is two scenarios. Either you get the original problem, in which case you solve it, or you don't, and you get nothing.
Okay.
So, I mean, if you're desperate, I won't like disallow searching for the problem. It's just not fun.
Okay. So 2025 by 2025 grid. What I'm thinking of is, like, let's start from a 3 by 3 grid. The maximum is 3. I mean 6. Why is the maximum 6? That's the problem. Not sure why it is 6. I know that if it's a 2 by 2, I can cover it with 3, and we have 1 left. We can cover it in any way. It's 2025. I guess let's first divide it up to 1024. And we will have 1001 left. So this thing can be filled in with only 1 remaining. The problem is, how do we divide this up further? Let's see, 2025 is 1111110101 in binary, I believe. Wait, did I type in 2026? I'm too... Yeah, that looks right. So it's 10,024 plus 512. How am I gonna do this? 512, 256, and then 128, and then I don't have enough time. So do I just divide this up to stuff like this? The thing is, if I ever get 3 squares next to each other like this, like meeting at a point, I can always put 1 ultramino like this and fill up the entire thing if it's 2n by 2n. Yeah. But how does that help me? Maybe it lets me fill all the way up to this point. I don't know. How would I even divide 2025 by 2025? Okay. This can be done without research. You say this is easy. You say this is doable. I don't know any fancy techniques, so here's what I'm gonna do. What am I gonna do, actually? What's the craziest thing I can do? Maybe make up an Excel file that consists of 2025 by 2025 cells.
Great, and you're gonna fill out 4 million cells by hand.
Yep. That's a very...
I would suggest you look at small cases, and it's completely plausible to make an Excel sheet with, say, 6 by 6.
Really?
And
okay.
not 20 by 2025.
So I'm thinking of this as dividing it up to stuff like this. I get a intersection here, so these can be covered, and then we are left with 3. For 4, it's just 2 to the end, so we only have 1 left. For 5, what happens for 5? It is a 4 by 4 plus 1, 1, 1, 1, 1, 1, 1, 1. But if we think of it like that, then we cannot do more than this, and we are left with 1, 2, 3, 4, 5, 6, 7. But if we divide it up further, maybe we divide it up into 4 parts like this, then... Ow. So... This is 1, this is 1, this is 1, and this is 1. So we are only left with 1. I don't know how... Is that even generalizable? I don't think so. Which is a problem. Okay, 6 by 6.
2025 is divisible by 3, so you only have to consider the divisible by 3 cases.
Oh. Wait, that was a major spoiler. Okay, 2025 is divisible by 3. Okay. It's like complete because we can do 4 by 4, 2 by 2, 2 by 2. Then here we divide it like this, and we have a 2 by 2, 1 by 1, 1 by 1, another 2 by 2, 1 by 1, 1 by 1. So it's 36. Left with 0. But it's also a multiple of 5, so maybe we need to look at 9 and then 10. Or maybe the fact that 6 by 6 is tileable means what? This is actually, I mean, maybe it's not like that, but we are left with 3. Wait. We are left with 3. So maybe we only need to look at a 9 by 9, and it's gonna be bam, 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 then. Or maybe we look at a 6 by 9, maybe. We can do a 6 by 9 and a 9 by 9. And it's doable.
Is a 9 by 9 doable or not? Is it just not doable? Huh. Wait. 3 by 3. Divided into 3 by 2s, maybe? I mean, we know that... Okay, I get that a 6 by 9 is doable. 6 by 9 is doable. 9 by 9. Huh. Huh. Like, what's the... Wait, what is the... Okay. Let's think about it again. 2025. Is 2020... 9... Well, think of it like 9 plus 2016. Right? Right? You know? You know? And 2016 is divisible by 6. So this entire part is doable. And this is what I'm thinking. This is 9. This is also divisible by 6. So this entire part is doable. This entire part is doable. And we're only left with the 9 by 9. I was trying to see if a 9 by 9 is just doable by itself. I don't know how. Maybe I just have to try doing it by hand and some like it I think I found it. Yeah, there is a way to do this. Right. Or not. Wait. Yeah, I can do this. Oh, right. Okay, I can do a 9 by 9. So, we can just fill the entire thing. So it's just 2025 times 2025 odd 12.
Yep. Oh, and hi, Arglin.
Hello. And
Hello.
that is
I'm
9.
praying to God that the fireworks stop.
Arglin, you have picked such a good time to come. You could not have picked
No! Oh my god.
Numberbasher.
Oh, this is... Oh my god.
What is the maximum number? Okay, by the way, the reasoning is... I mean, I don't know if I missed something easy, but, like...
Also, hi, Argwin.
Yes, hello.
I fill the thing up like this.
The entire question was so I'm just gonna give a bunch of context on question 2 while you think about 3. The background of this was I was thinking about this question. I later found out that it was a contest problem, but I thought about this myself, and when I thought of this myself, I thought that you can't tile any 6k plus 3 because it's not that easy to construct, and I thought there was a parity thing. And so I tried to prove for a long time that it was impossible, and then I found out a construction for 9x9, which is, if you think about it, really isn't that obvious. Please tell me that it isn't that obvious. So yeah, so that was fun.
Please be respectful in chat.
Oh, you don't have to say that anymore. Yeah. Just don't pay attention to it.
Just don't pay it, or give them a timeout.
Yeah, we'll take care of it.
What is the maximum number of 2x2 squares that can be placed to fully cover a 10x10 grid? But ensure that removing any square makes the grid at least partially uncovered. So for this,
this is just trying your best. There's no pattern to the answer, but it's very fascinating. This problem also originates from a summer camp application problem. And an awful lot of these actually come from application problems. Oh, and since I didn't commentate on one was nice. I thought about it on an airplane, but it's extremely nice. Exactly one. How there's exactly one solution to both cases. So that was just nice.
Right.
Oh no, 2025 is just a special number. It's just 45 squared.
Yeah, and it comes up a lot in these clocks.
Can you draw every country flying with fireworks? Is crazy.
Oh god.
The
that is
fireworks have died down, so
that's good.
I can at least talk a bit more now. Yay! I don't have to suffer.
Yay! But yeah,
I don't have to suffer a lot more anymore.
But yeah, to answer the question in chat, how do you factor numbers so fast? For instance, 2025. If it's the year number, we just remember it. So any competent like math competition person, like as in like for me, I know the factorization for 2021 through 2027. I'm just constantly learning.
2020 rate every country flag by how good their backstory is.
Oh god.
Oh, I mean, I recently was looking into. Okay, so I have been joining in on my friend's craft night stuff, and we've been doing unsolicited country facts, where we spend the Friday evening doing nothing but just looking up on details on a particular country. The previous one was Belgium, and I was looking into it, and the Constitution of Belgium states the colors in reverse order due to the fact that the the fact that the flag changed later that year that caused the Constitution to actually then state the colors in reverse order.
That's actually crazy.
Yeah, the colors used to be Belgium used to be a horizontal tricolor of red, yellow, black, top to bottom. But then they turned the flag 90 degrees, and so now it's black, yellow, red, vertical tricolor.
Oh yeah, it's a new day. Well, it's past midnight, so I can just, if you know, you know. I'm drawing something new every day.
Oh boy, yeah.
Yeah, I may as well give a tip to Zai for how to draw this on Excalibur. Dr. Zai, do you know that Excalibur has a grid feature? If you right-click the canvas and then toggle grid, and now you can draw things snap to the grid. And I would if you drag squares, then it will snap to the grid.
Right.
We know where this is going.
Yeah, and I like the way I did this, which obviously isn't the only way, but I think is by far the easiest way, is to put 2x2 transparent squares and then just copy paste them all over the place.
Right. I guess that's the easiest way.
And I will tell you if you can do better. You may as well zoom in such that you're drawing, like you're snapping to the smallest tick sizes, so you don't have to like manual, so you can just draw 2x2s that are small instead.
So that's one way. That's another way.
To answer, what is the question? The current question is, you have a 10x10 grid, and you want to place 2x2 squares, possibly overlapping, such that they cover every square. But if you remove any 2x2, then at least one cell is not covered.
Oh, wait, I should put it up somewhere. Okay. Okay. Let's see.
This is like
already 30 minutes on this clock. And we're not even halfway done.
Halfway is such an understatement.
Oh, Lord.
I mean, okay, we have 11 actual questions and 10 depending on how you count it. And we're 2 questions in, but question 1 is just trivial with programming. And unfortunately got cheesed. Posting while in call is crazy, that's so true. Everyone spammed the confetti and sure, whatever, I'll allow it.
Why is this not showing? Some reason. For some reason, it's not showing.
Imagine he's still streaming when you wake up. If you're going to sleep within the next 3 hours, I think that is what's gonna happen.
Where did it go? Where did it go? Okay, it's here. Okay.
Your stream is currently sharing the Wolfram Alpha, the Wolfram Math World page.
Oh,
on
what?
On 9cubes.
I don't. What?
Okay, and now it's back to just the problem statement.
Yeah.
The statements.
Okay. You can see the question below now. And I don't need that. What else do I not need? I'm not sure. Okay. Let's go again. We're gonna go again. So this is one way, but this feels like I'm wasting. How do I count the number of cells I'm wasting? I'm not sure. This is another way. I think it's even more wasteful. Actually, I did it wrong here. I did it wrong. Okay. I was supposed to do... I was supposed to do it like... I was supposed to do it like... this. And that's just the same thing. Can I rotate it though? Not sure. That's just the same thing. Let's see. Okay, let's go. I don't know. I don't know.
Cyan Master says, blink twice if you're being captured by aliens and forced to do these clocks.
These patterns don't seem bad. Like... But the problem is... Yeah, it's weird. That's weird. Maybe this is the right idea. And... Okay. 인천님 괜찮습니다. 걱정 안 하셔도 됩니다. Let's see what we can do. Bam. Bam. Maybe?
You have to cover every cell, by the way.
Okay. Okay. Right. Let's see. Bam, bam. Bam, bam. I can't think of a better way. If I do this. What else can I do? This is just not it. If I do this, then what happens? It's just not, it's just bad. That's just bad.
Good morning, Connor King 33.
I guess in toward, maybe it's like symmetric somehow, and it becomes something like that. Bam, 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 bam. Maybe it's symmetric like that. And then, I don't know, we can do this. That seems like a good idea.
You have very optimistic hopes for how symmetric this is. The final figure will be symmetric on the diagonal axes, but otherwise completely asymmetric.
Okay.
I'm already like cutting down your search by a logarithmic factor of 2.
$15 hours.
Yep. It is over 15 hours now.
The stream started when I went to school. It is now 1 a.m.
Oh, let's not even talk about school. School isn't starting for me until next week, but I have winter holiday homework, which I haven't started a single letter.
Brilliant.
Yay!
And now I'm sitting here looking at it do clocks.
Sorry, Professor, I was busy looking at clocks.
The infinite clock gauntlet.
Oh, hey, thank you for the donation, John Sai. I still don't know why that's the only alert that pops up. But I asked the team that has this alert thing, and they told me it's a known issue, unsolved, so I don't know. I'll just look for different stuff. I'll just look for different stuff there. Anyway, thank you so much. I will work harder. I will use your money very wisely.
Very wisely.
Very wisely.
Trust. So anyways, can you construct every flag using No.
That was coming. That was absolutely coming.
Can you construct every flag using money?
Oh god.
Mr. Krabs is going to be... Mr. Krabs is going to be the one that's going to be doing it. Yeah.
Yeah.
I'm not yet opposed to the concept of money. I will happily take any.
It's just bad. It's just bad. It's just bad. It's just bad.
Something tells me this singular clock is gonna I think you really meant it when you said this clock is going to the ninth circle of hell.
This is the final leg of hell.
This is weird. Because I can't cover up any of those, and that's just bad. I have 3 squares here that are not covered. Ah.
Does it have to be optimal?
The construction is pretty hard. I'll put it at that. Alternatively, you can think about how to solve this as a programming problem, Zai, because I think you're absolutely hopeless otherwise.
Do you think I'm actually hopeless, or are you just looking at my progress and you think it's not working?
I'm saying you're hopeless in a teasing, funny way. But the problem is hopeless in general, as in, like it's hard. It's just a construction out of nowhere.
Oh god.
Construction.
And you said it's symmetric. It's not symmetric at all, or was it symmetric along one diagonal axis?
Yeah, it's symmetrical along the diagonal axis.
But that's
so
it. It is only symmetric on one diagonal axis. Otherwise, it's totally asymmetric.
Right.
Yeah.
Good grief.
We're just doing stuff now.
I would actually.
Well, we're gonna find out.
Yep.
How many squares can you pack? Stay tuned to find out.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's like, okay, so what's the number I'm going for? I think I need
a shortcut. If you got into if you right click the canvas and then you select what was it? Let me find that. If you right click the canvas and then you select canvas and shape properties, and then you by default look at the number of objects in your selection. So if you select something, it'll by default show you the number of shapes you select. So you know
right. Right. Okay.
I think you can see that I've definitely used more than my share of Excalibur.
Right. Right.
And by the way, you can do better than 37.
Adrian, remember that a lot of the really weird square roots that exist in flags are a result of a particular construction. So try to look for what that construction is before you try to dive into the square root directly.
Yeah.
Usually it'll be a lot easier.
This is... I can still quietly hear fireworks in the background.
I feel like Zai deserves a lot of compliment here. He's done a lot of he's found a lot of very nice things.
Yeah.
He has single-handedly nerd sniped like 10 people.
What do you mean 10 people? There's like thousands of new members.
Sorry, not 10 people, like
thousands.
700.
No,
sorry.
700 here. Just here. I can only imagine how many more are outside of this server.
A few thousand.
This is only a subset.
Can you even imagine that basically 1/5 of the population that's like Chinese is like completely not counted here?
Oh god.
Our estimate is already by default an underestimate by 20%.
Yep. Yep.
He has done 40 clocks a day. What is 15 times 60 over 40? That's approximately 22 minutes per clock.
Honestly, I felt like that is on pace for what I was expecting. I was expecting like a
38.
lot slower. Like 30 minutes per.
In
38.
fairness, that's also because that we had like a bunch of not as
38.
hard plots.
You have to cover every
38.
trivial fix.
It does not fully cover the grid, but like, you know.
It's a trivial fix. You can just move that. Yeah.
Yeah, you can just move them.
You can do better than 38.
God.
Are we serious? Is there like a logical approach to this?
Is there like a logical approach to this? Yes, if you consider mass bifurcation into 45 cases, if I recall correctly.
Oh my god.
I'm not gonna.
Literally, this is just you can just do this by computer search.
I'm actually curious to see if Zai knows how the computer search does. This is non-trivial to computer search.
Color theorem.
How do I computer search this? Let's try okay. If I cannot, okay. Actually, if I cannot solve this with math, I'm fine. If I cannot solve this with code, I'm a fraud. So let's hope I can solve this with code.
All right.
15 hours into the stream. 15 hours into this stream with this mentality. Can I code a dynamic programming solution for this problem? In Python. In Python, of course.
Python.
Programming tuber goes insane over viewers' puzzles. Today 4.5.
I think what we need to know.
There's a lot less cases than I thought it was.
So
yeah,
if we consider like
dynamic,
like one, maybe if we consider one dot here and this is the center. So okay. Actually, I'm gonna program this because my head isn't spinning. I'm gonna take a bite of sandwich and then my head will spin better, I guess.
Okay, I'm hunting my refrigerator for snacks.
Is that a My Head Spins Zai OSG reference?
I'm gonna work on a compendium in the meanwhile.
It's removing any square, so you can't just cover one square per, you know.
John Sai asks, what kind of sandwich is it? They have also donated.
Oh, thank you, John Sai, for the $10. Thank you so much. It's ham and egg. Yep. Basically ham and egg, and then of course tomato and lettuce and cucumber and stuff.
Nice. Oh, also, Sunny, I did see the what you sent in response to the Bezier stuff. I have corrected those things now.
Oh, okay, nice. I managed to achieve yogurt.
You found yogurt.
I may very well be a fraud, but okay.
It is also late into the night for you, so
I don't know. Let's just start from something I can do.
Every single one of us except you, Orgly.
Yeah, it is looped back over now.
Actually, how would I dynamic programming this? One square covers 4 spots. We can think of it as the center of that square like this, and there should be...
I'm gonna drop food.
Bam, 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 bam. Ah, it's kind of weird. Wait, there are so many cases. Huh. Not sure. Wait. Oops. I think this part is very, very optimal. But this also does the same thing. Maybe.
Magplan asks in the chat, are you allowed to use AI?
Me? I guess not.
I mean, yeah, let's I mean, okay, it depends on what you
I
classify
think I
as
found
AI.
something nice.
I would say large language models, no.
Except that this one is now covered, but I think that's something nice. I think that is finding something nice.
But yeah, like generative AI wouldn't even help. Probably.
Yeah, I don't think so. I don't think so.
Well, I mean, okay, I directly told GPT to generate the code for this problem, like to solve this problem, but I gave it basically pseudocode to the point of if it couldn't do it, I'd be laughing at him.
Yeah.
Whatever. I transformed this into a programming problem with I basically pulled a gun into a water balloon fight. I transformed it into an integer linear programming problem and then just pushed it into the solver.
That's not gonna work. This is not gonna work. Huh. I guess I need to find... I need to program it. I need to program it somehow. And... it's been a while since I programmed these stuff.
It is this is Excalibur, I believe.
Correct, this is Excalibur.
Oh, a person asked, would you consider a CP-SAT model cheating? In terms of programming, I would consider it valid. In terms of actually solving, I would consider it cheating, obviously, because it's programming. But I personally used an integer linear programming model, so that's like not better. like what's the difference? But now looking at this, yeah, this is blatantly solvable with with dynamic programming, and I shouldn't shouldn't have enforced machine guns into a water balloon fight. Yeah, we all just love ILP. MacPlan says I got 36 from ChatGPT. 36 is suboptimal. What if you program it?
36 mod 12. 36 mod 12 would just be 0 anyways.
Yeah.
It's like,
Okay. What do you mean? What do you mean online it says 35?
What
do you mean online it says 36? Whoever online which says 36 is just stupid or I don't know.
It clearly isn't optimal.
I mean, we've just seen a 38, so.
Yeah, we saw a solution for 38.
Yeah. Let me look at some of my old codes about dynamic programming because I am very rusty.
You are very much a fraud, yes.
Right. Let's look at...
Was this gonna end? Never. That's why it's called the never-ending clock gauntlet.
10.
Day 8. The never-ending...
It's just the never ending.
So, let's say we go row by row. If we have this kind of row, what can we say about the next row? We know that there cannot be one here. There can be one here. And we should probably make it into like,
Someone from chat asked, hey Dr. Zaihu, what's your favorite programming language? To which I respond, the objective best programming language is Python and there is no other choice.
I am mildly biased, and it's also questionable whether or not you would call it a programming language, but Desmos.
Desmos.
True.
Okay,
not
maybe
not because it's good. Not because it's good. It has a lot of problems and it has a lot of weird quirks, but that's what makes it more funny.
Okay, brainfuck is also a viable alternative.
Okay, brainfuck is actually viable. That is true.
okay, I know how to program. I can program. Guys, I know how to program.
Holy shit. Actually crazy.
I know how to program. Actually, I don't know how to program. Wait.
Okay. People, let's hedge in our bets. GPT says 36. Gemini says 41.
This is gonna be a poll. What does Claude say? What are the other AIs? Grok.
I'm gonna feed it to Google AI Overview. How about that?
I think that one uses Gemini, well, like a basic version of Gemini that tries to respond in real time.
Ooh.
Grok says 39. Okay.
It gives up.
It gives up.
Okay, so
Google
Google AI overview gives 9 because 25 mod 12 is 1. And 25 is normal. Actually, want to see if GPT can write a dynamic programming approach. Like, I feel like this is not completely out of it.
If you can somehow, I mean, I don't really know this all that well, but if you can somehow prompt it appropriately, and may be able to do it.
I mean, obviously, if I just give it the entire pseudocode, it should be able to do it fine. But I just want to say,
right, but like,
with an
if you can frame the problem well enough, such that it's like not opaque to it or like ambiguous, then it may be able to do it.
Yeah, I mean, there's obviously a certain point in which you just frame it as an optimization problem, tell all of the parameters, and then have it just write the program.
At that point, you're literally just asking it to write boilerplate.
Yeah. So that was what I wanted it to write code.
Yeah.
Gosh, ILP is so fucking fire.
Bad row.
It is just so...
ChatGPT random between 0 and 36.
That's so funny.
Real.
Edward Animation Games, what does the question mean? That's a vague question. I'm gonna need more, like, what do you mean by what does the question mean?
Wait, I'm gonna send this to you.
What?
Because I have so there's a person in the Polyverse Discord server who has renamed themselves to Grok, and they would just answer everything whenever somebody pings them, whether right or wrong.
That's so funny.
And Grok, solve this clock.
Solve this clock for us. No.
No.
Actually, this may or may not be harder than I thought it was to put into dynamic programming.
Yeah.
I'm thinking about... Yeah. I think I was in that stage too. Because now I'm kind of getting... Now I'm kind of getting how to do it. So, how do we do it? Here's a previous row. After we after we draw the previous row, we have a set of places we cannot put squares in, which is something like this. Yeah. There's a problem when you have a oh no, it's not a problem. It's not a problem. In the next row, we can decide to put a square here or not.
Oh yeah, I totally forgot that DeepSeek was a thing. DeepSeek says 1.
Wait, what? Okay, can post what?
When I
do
this,
what it was thinking?
We do that, and we do that.
Does what I mean after
Copilot says 6. Oh right, yeah, like mod 12. Gemini, GPT, and Grok all say 39. Interesting.
That's interesting.
And you ask them why.
It could be 27, 39, 51,
51,
60.
63, or 75. Oh god.
Wow, I'm a fraud.
Oh, they're just.
I am. Yes, I am. Yes, I am. Okay, okay, I get it. I actually get it. Wait.
Oh.
Wait.
I actually get it.
Oh.
Do I get it? Okay, I now remembered what dynamic programming is. Now I finally remembered that dynamic programming, in dynamic programming, you're supposed to in range 10 maybe? 5. Okay.
I think the maximum number of two squares is maybe at least 1.
Wait, I'm gonna...
At this pace, we're gonna finish the clock in 5 hours. Just hang on, guys.
Okay.
It's gonna be 7 in the morning.
Okay.
That is approximately 2 Kyrgyzstans long.
When Zai said, since my clock was at the very end, if we don't ship it, I can go to sleep, wake up, and still see my clock getting solved. I didn't know he meant that the position at which my clock was being looked at doesn't actually matter, and I'm gonna see it when I wake up regardless.
Oh god.
It is 1:30 a.m. and fireworks are still going off.
Well, now chat is just advocating for use all the AIs.
They're like, fucking break everyone off.
Yeah, and then there's
solution. Just writes in the number on the side of the clock. This is fine.
And then there's like 10 other Olympiad questions.
4, 5, 6.
4.
Chat says, why not iterative DP? Even though I believe iterative dynamic programming is just another buzzword.
Use Merle! I know.
Ninja bot?
Alright. Merle, what do you say?
Meep is in the chat.
Oh god. Hi Meep.
Meep got sent this and he politely declined it.
Pick a random character in character.ai and ask them to solve it.
It's like pulls out gun. Grok says 1! Grok says 1!
Use PowerPoint is crazy.
Use PowerPoint VBA is crazy.
Grok says 1!
You need to phrase it like a Minecraft.
Grok not referring to the Grok AI, but Grok referring to the guy that the
That's funny.
server.
Wait, really? That's funny. Gosh, that's funny. Okay, we're gonna tune into. This is the ultimate Zai programmer debunk.
Please, I need to prove I'm a god programmer.
Those are the only two states as a programmer. Either you feel like a god or you have no idea what the hell you're doing.
Real.
Either only God knows what the code is doing, or only God knows what the code is doing and you're God.
Okay, online GDB doesn't even have a it doesn't show any compilers, right? Okay.
No one knows what the code is doing because you completely forgot what you typed 3 lines earlier.
Guys, shall we pull up the Scribbler game, wall size? I'll definitely take Gartic phone as well.
Hey, numberbasher, hey, Arglin, you want to play like one game of Gartic phone while Zeiss?
Merle says... I don't know. Yay!
Oh, I got an ad on YouTube.
Bit count function.
Currently I'm currently working on the compendium. So.
Oh, interesting. I guess you can screen share if you want.
Bit count function.
And maybe.
Yes.
Python, please. Please, bit count function in Python. Count the number of 1 bits. That's a thing? Int.bit count is a thing?
Int.bit count is indeed a IRC.
Compendium during the stream is actually crazy.
Watch as I finish the compendium before Zai finishes the class.
Also, we're keeping this. We're keeping this a secret from the rest of Zai's viewers, right?
I mean, yeah, I guess.
It's not like...
I mean, it's the main focus of the stream is the clock, so.
Yeah, fair.
I'm just doing this as a side thing.
Just because we're here.
Yeah, that's literally the only reason why I'd be streaming here. Or screen sharing here.
I love how every stream it's just us 4.
Because we're the only sane people willing to do this.
Meep got dragged along to a programming competition late last year and it was just applied math, so I ended up winning.
Sane, quote unquote.
Mood. God.
I was dragged into GMTK Game Jam. Basically I was invited in, and I accepted it entirely on the sole reason that the programming language would be Desmos. So it was just me. It was Jake Walker, if anybody recognizes that name, and it was Shrocat. The 3 of us just working for 4 days nonstop in a Desmos graph.
Is there a Desmos collaboration mode?
There is no Desmos collaboration mode, but you can save your code. You can save your graph link.
Yeah,
and then you can paste it in, and it gets merged. Like we basically forked it and then merged it.
What?
Yeah.
Oh, right. You can paste the link into the equation box, and it fits everything.
You can also paste in the JSON graph state, and that'll also work. That is, I don't know if that's intentional, but it is hilarious.
Okay. Okay.
Make your friends work too. No.
Okay. Okay. All I need to do here is that ensure.
Any collaboration with the Grey Cuber is not out of the question.
there was a non-zero chance of it happening.
There's a non-zero chance of this happening, and even if not, there is also another possibility that you will see, at the very least, maybe within the next month or so, Grey Cuber and Zai next to each other. Not physically, but.
Ooh, interesting. I am looking forward.
Legal.
Within the next month. Oh, I see.
This will.
What the hell do you mean?
I mean,
what the hell do you mean? Merle gave an answer.
Merle gave an answer. Other than I don't know. And your question violates the Microsoft.
They said what's the max number of 2x stone block can be placed fully to cover a 10x10 building platform, but ensure that removing any of the 2x2 stone blocks make the grid at least partially covered. It should be uncovered.
Oh my god. You can place a maximum 25 of these blocks.
Oh my gosh. Oh my gosh.
So the answer is 1.
So, ignore squares that have empty space. Bam. 1.
It's so funny. The last hour number that we skipped is 12. But looks like we're gonna be skipping.
We're gonna be skipping a lot. We're gonna be skipping quite a number.
Gosh, there was one moment inside of my mind where I was like, okay, maybe I can make a clock where it's the 365 days. And then I was looking at it like, okay, but that's gonna take days for Zai.
Yeah.
1-1. All I have to do is
for a good while, you guys were planning on doing the one which like had every minor tick mark, including the second tick marks.
Yeah, that shouldn't happen.
Like
though.
you had a clock for every single one of them. I was like, there's no way in hell we're getting that. Like, don't get me wrong, this is a lot of clocks already, but that barely covers. That barely covers a drop of that whole thing.
Yeah.
wait, what happens here? That happens.
Gosh, I'm so excited for part 3. I'm just left out here blind.
Yeah.
Lord.
The clock slowly approaches 6.
Okay.
Actually, there is one more.
Power 4.
1001 and 0100.
Whether or not that thing happens within this month depends on whether or not I'm going to be able to finish my work within the next month.
Okay.
Arlen, what's happening to the amoeba wheels part 3?
So, yeah. I have sent the completed.
So how do I do this with bit manipulation? How do I do this by bit manipulation? How do I do this with bit manipulation?
Yeah, I've done the I've finished the whole draft of the script. It is longer than several of my scripts combined. So several of my video scripts combined. And I have sent it over to some of the people that I am going to be potentially working with. I'm working with a bunch of people already for Amoeba Wheel stuff. I'm just letting them look over the draft to see if there's anything that they can contribute as well. I have received some feedback on it that I have not looked at yet.
Oh gosh.
Cool.
That reminds me, when will I be seeing the part 3 script, if at all? Well, no response.
What? What?
They are locking in. Zaya's absolutely locked in.
I was asking when
like
lock pattern.
Lock pattern.
lock pattern.
Bits.
I was asking when will I be able to see the part 3 script, if at all.
Part 3 of what? Part 3 of
Flag. Yeah.
flags? Like, yeah. At least a month?
Yeah, it'll take a
Part
while.
three- The part
Okay.
3 is a lie.
Oh, okay, we'll see. And we'll see.
We'll have to see. Let them take their time. We are going to get there. That, especially because of the fact that
We are just asking AIs now. That's what this stream has evolved into.
It is insane just how much stuff we just have.
it keeps updating. We have to keep changing the storyline.
Okay. I
was like,
Okay.
surely you can't do 7
Okay.
angle 7 section.
Okay.
And then surely you can't do pi.
Okay.
Surely, you cannot.
Okay.
Now we just have all kinds of trig and inverse trig. What the hell?
Surely
Yeah.
you can't.
It's ridiculous. It's so ridiculous. Which is why I then have to say whether or not TGC and Desire are going to be next to each other depends on me.
I think this is.
Because you guys keep giving me more work.
I think this could be my magnum
Surely
opus.
you can't do the integral from 0 to 1 of negative log x all divided by 1 plus x squared.
Wait.
The x is equal to pi over 2 times log
It's-
of
it's-
pi
it's-
over
it's that-
11 is equal
it's
to
that-
times square root of 2.
It's that freaking dude eating cereal meme
Oh.
and then spitting it out.
Arithmetic and geometric mean of 1 and the square root of 2.
Surely. Spoilers.
41. Like a. 41. 41.
41 is too big. You can't.
What? That was even the first. Like I got it first try. I got the number first try. I got the number first try.
1.
Consolation. At least it's only 1 away from the answer to the universe.
Wait.
It would have been actually would have been really funny if it answered 42.
Wait.
It's like you just asked you literally just asked the computer, what is the answer to life, the universe, and everything? The answer is 42.
Imagine Zai.
1 is April Fools.
Oh, I forgot one part of my code. Wait.
I still remember when Zai was in this server in December, and I was just like asking, "Hi Zai, when will part 2 be out, and will there be a part 3?" And then Zai said,
It's like there will not be a part 3.
"Surely flat video will be done before 2026."
I had to convince Zai that we have to split this into part 2 and part 3.
Yeah.
Because the thing is that literally they had finished part 2 when you were already figuring out new stuff. And I was like, look, I love the idea of like trying to fit some of this stuff into all of this into part 2, but there is no way this is going to happen. I found out a bug. There is no way you're going to be able to fit this all into part 2.
It doesn't work.
And so
It doesn't work.
they basically just wrapped up. They just basically just wrapped up their thing and then went on from there.
Yeah. How likely is it that we're getting a part 4? Like,
It doesn't work.
What is the likelihood of getting a part 4?
I mean,
It doesn't
because
work.
this is like,
I mean, it's
keep
not.
discovering-
It is not out of the question.
It doesn't
But
work.
I would hope that we get this all done by the end of part 3.
Yeah.
The only reason we'd get a part 4 is if the video comes out and then more stuff comes out, in which at that point
oh god.
at that point I'll probably take the I'll probably handle the
Oh, it's
I'll take the
good.
staff.
The only number I get is 41. I am Gemini. I am Grok. I am a bot. I'm a fraud. I'm saving this for later so I can. I know what's. Let's title this fraud.py. I'll save it
Rashawn,
there.
you have no right to say that after you literally transformed the entire.
Hey.
Rashawn, you have literally no right to say that. You were the one who literally completely changed the landscape in the past week.
Also, we still have more to discover with 36-degree polynomials, right?
Yes.
God, fuck everything. Why the
So yeah. So
We'll
yeah.
have to say that for later, yeah.
So yeah.
Uh,
Oh, why am I a fraud? Why am I a bot? Why am I a robot fish? I am a fish. I am a goldfish.
Rashawn is the next Ramanujan.
Why is it?
Yes.
What if I found a new solution? You know? What if I? You know?
Regression. Receive field
Living a dream. Yeah, no, you are just the next Ramanujan. Congratulations. Congratulations, Rashawn, you're the next Ramanujan.
Rishan is the Euler of PowerPoint.
I will say though, actually no, I did have a similar revelation when I figured out Bezier curves. Literally, it was just like I was just doing my stuff in Altera, and I was just like, wait, hang on, this might be how you can use, this might be how you can control points in PowerPoint.
Dreams are just overpowered. I should go.
Okay.
Dreams
I think
are
it's just unsolvably wrong. It's just unsalvageably wrong. I was hoping
I mean, you can.
I could salvage it, but it's just unsalvageably wrong.
Can you print out the solution with 41 squares and manually check it?
Same question. That would be helpful, but also might require some bit of refactoring.
Yeah, because I'm only looking at the... I'm only looking for the number of... Yeah. Yeah, I'm only...
You could build a time machine and ask Euler. To be honest, either Euler or Ramanujan is going to be able to answer him within like 2 hours, or like with like a generalized form that works on infinite grids.
Maybe like 6 or 7 minutes.
Mm,
Come on, asshole.
Who would actually be able to solve it faster, Euler or Ramanujan, for a problem like this? Ramanujan. Okay.
If we're faster, it is always Ramanujan. There is just no debate.
Yeah, that's true. Ramanujan you can literally just like give Ramanujan a random number and they'll give you like they'll just give you a revelation that nobody's figured out about it.
Give Ramanujan a random number like 1,729, and now it's called the taxi cab number because of him.
Because yeah, literally.
What?
Oh boy. Oh boy.
Why couldn't Ramanujan live for longer?
I love how we're all just collectively losing our minds.
I've just woken up, so I'm fine now. You guys are all
fine. This is currently
It's almost 2 a.m.
It is indeed almost 2 a.m.
Out my ears.
Same.
Okay. X equals to y cubed divided by the square root. Okay.
This is just.
How are you gonna?
Yeah, you guys are genuinely slowly going insane.
We have already gone insane. The existence of this clock has already mean that I've gotten insane.
No,
I do not need any more.
Okay.
The fact that you
cannot
touch the
solve
stack
this.
is
I
changed.
cannot solve this. I don't know how to solve this.
Happy 16 hours.
Thank you. I don't know how to solve this. But thank you, but I need a solution on how to solve this.
The solution is the number on the clock.
Yeah, it is just 39. You can manage to sneak in where if you just trust me.
It's 39.
Trust me, bro.
Technically, here's the thing. This is numberbasher's clock. So numberbasher came up with these problems. Sunny came up with these problems, so they know the answer to this. That's why they know like, oh yeah, that's too many and that's too few.
Right.
Numberbasher's name is actually a reference to Zai bashing his head against the wall 59 times trying to solve this problem.
Right.
That's actually so fun.
Right.
It's 39, Source, trust me, bro.
Trust me, bro.
Yeah, that's God. I can't even access my overleaf document for where I have the actual constructions. It's kind of like a situation where you'll just have to trust me. I'll give you a certificate later.
Okay, you know what? I'm posting my.
Jesus.
So yeah, there's a 39 solution instead of stem and polybridge channel. If you look at it, I can validate that I've seen the solution just by looking at it. So it probably works. So that's
39 proof is left as an exercise to the clock solver.
Yeah. I'm gonna try to find my document which I wrote on this, but meanwhile, Zyshelf, feel free to proceed.
Okay. Okay. $38. The only thing I get is 38. This is just absurdly bad. Okay. Let's see. What was I doing? 39. Wow. 39. Mod 12 is 3. Where's the
Oh, Sunny. Rashawn has dumped their solution in general chat.
The smallest positive number divisible by 7 whose digits are all strictly less than 3. Mod 12.
I shall enlighten myself.
Number of 2's. Mod 12. How do we know something is divisible by 7?
I can verify that it does indeed seem to work, and I will now check that it has 39.
Uh, 100. 2. 1,000. That's gonna be 6.
right?
They are.
60.
Justin is asking if you can put the question at the bottom.
Oh, right.
I love how I've gone to my familiarity with the problem has now just gone to the point where I can look at a grid of zeros and ones and I can just know if it works. I can just know if any square can be removed. Because
Here
I've already
this is what it is. 7 divisibility rule, which I forgot because it's so obscure. Right. Wait, I'm wrong? Oh, right. Or is 7 times 5. Yep. And then we go back to 1.
Can you solve?
So each of the
some people have
digits,
already.
Each of the digits are worth 1, 3, 2, 6, 4, 5, 1, 3, and so on. So we have 1A1 plus 3A2 plus 2A3 plus 6A4 plus 4A5 plus 5A6 plus something is equal to 0 mod 7.
Zai sounds completely
what is the
dumb.
22, 026, 26, 26, 26, smallest positive integer divisible by 7? So how do we count these? I have no idea. Let's look at 1A1, 3A2, 2A3. 1A1.
Trivial, but I would suggest not using programming. But also there is a trick to this, as in you can't change 3 to any other number and still have it work. It's very specifically crafted.
It's very specifically 3.
Like if I change 3 to 4, the problem becomes much harder.
Oh God.
7, 8.
Oh, a bit of an update.
10.
The Vexilla Mundi website has updated and the construction sheets are gone, so...
Yeah, no, you want to know what also happened recently? The CIA World Factbook got taken down.
What?
Like, not too long ago. It's ridiculous.
So... So I don't know how it works. The first one is 21. I am so stupid. I am the stupidest fish in the world. So first one is 21. Second one is 112. Third one is, I think, 210. And the fourth one is like 1001. Huh. Right. But how? How? What's the fifth one? Maybe the fifth one is 6 plus 8, so we need 8 more. I don't know. 8 more. Maybe... maybe like 1120. And then
really fucking tired.
We do like. Oh no. 1022 1120.
On the other hand, fireworks have completely vanished.
1120.
Thank goodness.
And then what?
Wait.
62.
Wait, you fireworks going into 2 a.m.?
Yes.
Oh yeah, that happens. Yeah.
How do people sleep?
No, we don't.
You don't. You fucking don't.
Right. That's right. It's the perfect time to
2002.
Man, I love Chinese New Year.
Yay.
And I thought I was gonna sleep tonight. Funny.
5.
I mean,
No,
It's 9.
you are not sleeping at all. What in the light pollution? So real.
No. I'm not. I don't see how this can be patternized.
You've missed 1211.
Wow, I did. Okay. So how am I even supposed to do this? How am I supposed to do this? I don't know anything useful here. I actually don't know anything useful. I don't... what am I missing? What is the thing I don't know? I'm certainly not knowing something. I'm certainly not knowing something here because... do I keep going until I find a pattern? 2, 1, 2, 1.
I don't think larger numbers will be much different. Like, you should try to find a pattern with the numbers you have. But,
right.
Yeah.
Okay.
Honestly, not the slightest clue.
We have this. We have this. We have 210. We have 1001. Geometrically? No. How would I change this into a form that helps me?
I think he's just drawing lines now.
102 digital roots? Taking digital roots. What?
I can't think of a small hint, so I'll give a hint like 5 minutes later or something.
Okay. I'm still angry that I couldn't get that by coding last. I actually thought I'd made it. I don't know what I missed.
If it makes you feel any better, I do not know how to code.
If it makes you feel any better, I do know how to code, and I still do not know how to do that in dynamic programming. So,
the code made so much sense in my head.
We are all losing our metaphorical
mind.
In fairness,
3, 6,
it is very late for you. So
2, 4, 6, 5, 4, 1, 5, 3, 1, 2. No, I am very calm and collected right now. 2, 1, 1, 1, 2, 2, 1, 0, 1, 0, 0, 1, 1, 0, 2, 2. So what do they have in common? I'm not sure.
Yeah, like the...
I mean, times 10, that's of course gonna be divisible by 7 too. 1, 1, 2. What do these numbers have in common? Oh, maybe it's the fact that this is, but it's not actually, yeah, maybe it's the fact that it repeats like that. Maybe.
What do the numbers mean again? What?
So 2 times 10 to the n is congruent to 1 times 10 to the n plus 2.
I will tell you that that's not particularly helpful.
Really? What?
You are slowly approaching 2 hours on this clock.
Okay.
Both 3 and 7 are useful. Like I cannot imagine making a similar problem by replacing 7 and replacing 3 with other numbers. Which is why I think this is like truly insane.
Okay, okay, what happens if I multiply replacing 3? I guess what happens if I multiply this by 3? 9, so this becomes that. 6, this is 18, so that's gonna be 4. 12, so that's a 5. 5 times 3 is a 15, so that's gonna be a 1. And you're telling me this is very useful, but this is not. And also it doesn't...
I said nothing about that actually being useful.
Okay.
This is fine. This is absolutely fine. This is...
Okay. Okay.
This is so fine. This is so...
Times 4? What is that? What happens if I multiply it by 4? I don't know. I don't know.
Masters, you cause eyes
3.
insomnia, you know this?
I'll give you a hint, which is to use base 3.
What?
I may as well give you a hint, which is that base 3 is useful.
Base 3 is useful.
What?
Base 3 is useful. Okay, what am I gonna change to base 3? What am I gonna...
No, don't worry. You're not changing anything into base 3.
Oh, are you saying we need to reconsider this as a base 3 number?
That is not 5 or 4. Yeah.
Oh, this is just 14. Oh. So that's just 21. Wait.
Wait, what? Wait, what? Whoa, that's actually crazy.
What? Okay.
Actually crazy.
Wait, so does that mean I'm like missing all the... I've missed 28 and stuff? I've missed... What's 28 then? That's gonna be...
Whoa. Hang on a fucking second. Let me try.
No, this is 28. This is 28. 27 plus 6 plus 2 is 35. Okay. Wait, so that's... why? But the answer should be just... that times... 7...
Yep, it's still going.
and then turn into base 3.
Yeah. And then I've changed the question statement to count the number of 2s, but otherwise that's just exactly what you get.
Okay.
Do you understand why?
No. I'm gonna try it after I get the answer.
Okay.
Wait. How would you do this part fast though? Like that, I don't even understand how you would do this part fast. Like, I don't understand.
Oh, you just do it manually.
Oh, really?
Yeah, I didn't design around that. I just wanted a big number so you couldn't just count up manually.
Wait. Oh my gosh, School from Alpha doesn't show everything. It doesn't show it.
No, it does in language code.
In language code.
Oh, this is it.
In Wolfram.
Oh.
And you...
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19.
Yippee.
So it's 7. And why does it work? Well,
1, 3, 2, 27, 6. What? What?
so if I write it in base 3, it basically satisfies something like this.
Basically the logic is that if a number is a multiple of 7 in base 10, it must also be a multiple of 7 in base 3, because 3 to the power of n is equal to 10 to the power of n, not 7.
What? Wait, what? Wait, what? 3, what? Huh?
Uh-huh. Uh-huh.
I don't think me nor Zai
Uh-huh.
understands this problem very well.
So we have n 3 to the n mod 7 is like 3 to... Oh. It just works because 3 and 10 are the same mod 7.
Yeah.
Right. Okay.
Right.
So if this is divisible by 7, then this is also divisible by 7 because, yeah, the mod is... They are both 0.
Yeah.
Mod 7.
So you're just
Yeah,
for
yeah.
3 numbers with 0, 1, and 2, which is obvious.
Oh, that's crazy! Oh my god. That was like the equivalent of
If you add 7 to a number in the sequence, you can remove 3 from the ones digit until it is less than 3. Wait. What? Prevents preserving its divisibility? Okay, I add a 7 to a number in the sequence? I don't understand it. I didn't understand it. Oh, 112, if you add 7, 112 in base 3, and if you add 7 to this, it's like, what, remove 3 from the ones digit until it's, what? Oh, wait. 21 plus 7 equals 28. Oh, right. That's what you're saying. Okay. Okay, I get it. Thank you. You must partition a 27 by 27 grid into 27 minnows, rearrange K of them, and be left with no way to add any other piece, allowing rotation and reflection. What is the minimum K mod 12? Be left with no way to add any other piece.
We spent 2 hours.
You know what a 27 minnow is, right?
Yep.
Yeah, just to clarify, yeah, polyomino with 27 squares.
The problem is I must partition, so it must be a partition in the first place, and then be a rearrangement. Wait. Yeah, rearrange them inside the 2027 grid again. How would I do it with, like, 4? Or 5, maybe. Oh, let's do 5. I must partition it first and rearrange it. So, like, how would I rearrange it? Actually, I'll just... Like, every... So wait a minute. Be left with no way to add any other piece. When I rearrange them, I am also allowed to rotate and reflect. And no way to add any other piece, that means any other piece that in the partition, right? No way to add any other piece in the partition.
Yeah, so you can't, like, if you use K of them, you're left with 27 minus K other polyominoes, and you can't add the others in.
Okay. So what if I use, like, I don't know. Let's divide it up. In this case, I don't know. Let's just try dividing up like this. Bam, 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 bam. And then rearrange it like... rearrange it like... Like that? I don't know. Wait. Like that? That's
yeah,
two.
So that's a 2 solution for when you have 5.
Yeah. I guess I should look at like prime numbers and stuff to maybe get the gist of it. Maybe, I don't know why, but 2027 is a prime number. So... 1, 2, 3, 4, 5, 6, 7. Maybe that's something worth looking for first. Maybe. But... No. No.
Playing Discilly Icosahepterus with this one. So real.
Maybe. Huh.
No, I use orange. Okay.
I really love the game of Discilacosahepterus, especially, you know, that satisfying Discilacosahepterus clear when you just drop an eyepiece down. It's so satisfying. 2 hours for a third of this clock. That's brutal. Thank you.
Okay. Okay, how should I do this? How should I do this? How should I do this?
Meanwhile, I'm just chilling with.
That's a 3 solution. right? So I found out that at least 2027 has at least a 1013 solution.
Okay. I'll tell you that's approximately 3 magnitudes off.
Okay. How do I get better at it though? Like, can I find a 2 solution? Can I find a... There are so many ways to divide it. Like, each piece can be different. And... like, each piece can be so different.
Also, problem credit goes to Omega 3301. You'll also see them with the origami puzzle. I hope you have paper.
No.
Okay, what am I supposed to do with this problem? It's what am I supposed to do? What's the pattern? What's the pattern I'm trying to find? Maybe. What kind of solution am I looking for? I want something that I don't know. I mean, with 7, I don't know, but once you have something big, then you can... Okay. So, if you have, like...
Oh, Zai, you should probably change the question to the...
Oh, yeah.
You should probably update the question.
Oh, right.
At the bottom screen.
Question is... partitioning a 2027 by 2027 into 2027 Minos.
I believe the solution is to make lots of square-like minnows, and then have lots of long minnows. And for example, if this is not correct, but
that is the right line of thought, yes.
Wait a minute.
So if I have 11 by 11,
indeed using a lumbar minnow to...
One domino can hold at least 3 by 3. So if I can cut off a 2 by 2 section, like in whatever way I can. I mean, like something like that, but then these have to be 11 long. So what?
The stream is actually called Secretly Giving Dr. Zai Olympian Math Training.
It's pretty much at 3 in the morning.
It's 3:30. Yes. 2027 equals 45 squared plus 2.
The only property you'll need about 2027 is that it's odd.
Really?
And positive.
Okay, so this is not the way. Making a square is not the way then.
I
Okay.
actually recalled an odd solution. Like there was a general odd solution.
Okay, how would I have
A general odd solution.
like
Yeah.
but
I'm
so
scribbling over my blood.
45 squared plus 2 doesn't mean anything. So what shape am I looking for here? Maybe instead of a square it can be a really long, like some I don't know, some sort of this shape.
And the 5x5 case, there's still more to be explored within the 5x5 case.
Okay. 5x5 case. So if it's not a square, so it's maybe not this. Okay, let's just try that. Then what? I don't think that does much for me.
You should with different kinds of partitions. And there's an especially interesting partition that will be helpful.
Okay. Okay. Different kinds of partitions. There are so many ways I can do. So it's not a square. Don't think about a square. Don't think about a square. Think about all the pentominoes that exist. Pentomino. All the pentomino.
Maybe what will help
all the pentomino.
What will help is telling you that you can solve for k equals 1.
K. Wait, what's K? Rearrange K of them?
Yeah, just putting in one of them can allow you to not place any of the others.
Maybe this.
That allows you to place literally like every pentomino except F and T.
Okay, I'm an idiot.
By 9 square. Oh god, what am I doing with my life? What could I possibly be doing with my life?
You're doing a wide variety of very fun things.
Wow, slamming your head against the walls.
You know, I used to just gaze at the Wikipedia page of hexomenos and just lose myself in the beauty of the geometrical constructions.
I lost myself in the Wikipedia articles of mechanical linkages, and I stared at it for long enough to go, I can animate stuff for this.
So,
to make that apple.
Let's just try all of them. That's what I should be doing.
Try all of them.
Can you draw every flag using pentominoes? JK.
No, that's terrible.
Nah.
That's the most.
The 5 is just 5 doesn't do anything unless I can divide it up to things that are a diameter of 3. So can I divide it up to a diameter of 3?
I will have to sleep in 30 minutes.
Diameter of 3.
You should probably go to sleep now.
Diameter of 3.
I will instead be sleeping in 12 minutes.
Well, I'll give you a preliminary farewell.
That's diameter of 3.
Farewell.
Is that the interesting solution though?
That is one interesting. So there's a second one which is basically the same.
Okay.
You can try expanding this to 7, and afterwards
okay.
to
20. So can I also get away with 1 because in 7 is there a 1, 2, 3, 4, 5, 6, 7? We can do that's diameter 4. that's diameter. I guess I may. No. No. Maybe. Huh. 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 I don't know exactly how I'm. Maybe I just start from this, and wait. In that case, this is just impossible.
Oh, it's possible.
Maybe like this. Yeah. Yeah. No. Yeah.
Remember when the hard stream was just
Yeah. Yeah. Okay. Okay. But what about But what about 9? But what about 9? Does it have diameter 5s? Yes, but can I make it work again? 1 2 3 4 5 6 7 8 9. 1 2 3 4 5 6 7 8 9. 2 3 4 5 7 8 9. So that's the solution for every odd square.
Is this 1?
So the minimum of k is just 1.
Yay. Which mod 12 is 1.
Right.
Mod 12 is 1.
What is the number of distinct ways to fold a p pentomino into a rectangle? P pentomino is it that one?
Everywhere.
I'm just saying
It's that
disregard
one.
places because otherwise it's.
Oh, I'm sorry, I couldn't hear you.
Basically just ignore the almost in the question.
Oh, okay.
Like it's technically.
It just says ignore, like, you know, imperfections. Assume perfect folds.
Yeah.
Axiom 2.
Love how you already just know which axiom it is. God. I wonder if Zai has paper in real life that he can fold, because that will be very helpful.
Axiom 1.
Assume perfect tools.
I would strongly encourage actually folding this, because otherwise you're in for some very interesting treats.
What is a P pentomino again?
P pentomino is 3 squares on row 1 and then 2 squares on row 2. With a square.
Okay. Oh, it's actually, it's just a P. Okay, yeah.
Yeah.
But what do you know? What do you know?
Yay! Actual paper.
Actual paper.
Yippee.
Yippee.
This took
this didn't take 2 hours. It is taking 2 hours.
So true. Oh my god, so true.
Arg was just working on their compendium.
At this point, I've basically taken over Kinu as the curator for this. Why did I do this again?
Why did I do this again? extraordinary IRL transition to review a peep. Also, it is intended that Zai isn't speaking, right? Just to check. Also, Asphalt, you're playing this thing, and then it's going back into the Discord.
I think that is Asphalt, yeah.
You want to either mute yourself on Discord, or you want to listen to the Discord audio and then mute the stream.
Yep. This is gonna be a doozy.
By the way, Dr. Zai, that does not count because the folded shape has to be a rectangle.
Oh.
Whoa, okay.
The resulting shape has to be a rectangle. That pathetic excuse of a shape is not a rectangle.
Come on, give us a slack.
No, it's actually a deformed shape. Even though that shape is turned.
The Virgin Pentagon versus the Chad quadrilateral.
Assume perfect tool.
Assume perfect tool.
Perfect tools is just insane.
Rule 1. Assume perfect tools.
You have one solution, Zai, and to help you with the other solutions, all of the other solutions require diagonal folds.
Yay! How fun!
Yay, how fun. The rectangle must be a 2x1 or a 1x1. That is absolutely false. In fact, it cannot be either because the area must be 2.5.
Five halves. Oh my god, it's so crazy. Anyways.
Hello, Zai. Well done on somewhat maintaining your sanity.
What
no,
sanity?
I do not agree that there's no mention of sanity here.
Zai is
There is
incredibly quiet.
We're all just
insane little drats.
Yeah.
No, when Zai said it's gonna take 3 hours to look at my clock, yeah, we both knew it was an underestimate.
yeah.
Yeah.
Can you construct every flag using a P pentomino? Funny.
Can you? That's a very good question. I mean, with the 2x5 pentomino, you can make a rectangle, and with that rectangle, you can just add a multiple of them to make a square. And using that unit square, you can construct already quite a lot of flags. And then using
basically anything that was under the warp and weft chapter is solvable.
Yep. Me when I warped and me when I weft.
Me when I me when I weft. Da, 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 da.
What are we doing?
Rescaled with by 2 and
can you construct every flag? Can you construct every flag with clock and lock patterns? Otherwise known as the flags, clocks, and locks category.
Can you construct every lock pattern in PowerPoint?
The clocks and locks category. I'm officially terming it.
Indeed. Does folding backwards count as a different fold?
That's a different. No. I'm only counting the crease pattern.
Ah, yes. Just.
Wow,
wow, the aliens are trying to trap you. It's crazy.
So crazy.
Can you construct every flag while playing Fear Elise in E minor on the piano while juggling 3 balls, solving a Rubik's Cube, and reciting 100 digits of pi at the same time.
That's not for Dr. Zai to do. That's for Zai World to do.
That's a whole new world.
Oh no.
The whole new...
Accidentally copyright
the holy grail competition. I'm saying, Froggy. I'm actually curious to see what your clock is.
You know what? I'm gonna turn on my camera. I'm gonna solve a Rubik's Cube on camera. This is for those who are in the VC exclusively.
Which is just the 3 of us.
How many? I wonder how many people are whitelisted for this VC.
Most of the people who are whitelisted are actually like more or less silent, which was not what was kind of like what I didn't want to happen.
Right, I see.
Which is why it's mostly just been the 4 of us, because the 4 of us are really the only ones who actually just talk.
You're just the yappers. Anyways, time to solve a Rubik's Cube. I'm gonna start at when this thing hits 1651.
We are now at
Cyan Froggy's cube.
Okay.
Cyan Froggy's clock. Oh, this is this one. Yes, it is. Almighty competition. I wanna look at Cyan Froggy's get solved as well. Oh god. But also I'm like, do I even have any left to preserve?
Oh shit, I messed up. Oh wait, no I didn't.
Y is equal to x cubed divided by k, then get the square root of that.
What is this?
Can you construct a flag on a pre-owned Nokia 6300 feature phone bought from eBay?
Okay, so Cyan Froggy wants your attention. So Cyan Froggy is the person behind the other massively hard clock, and they want it to be reviewed at past 5 GMT or 13 KST.
I mean, if I don't end until then sure. So that's gonna be for me. That would be 28 hours of streaming. So if I'm still live at 28 hours, yeah, definitely.
Still alive.
Okay. Would it be fine to Cyan Froggy if you did it immediately after this clock? If you would be more insane that way, or would that be insane?
Wait, but I thought Cyan Froggy's one had solutions in it?
They want to give hints.
But wait, that was not in my plan. I thought of just looking at the solutions for Cyan Froggy's one. If I'm not allowed to do the solutions, then that's really bad for me because I will have to be live for another 4 hours. But yeah, I guess. So here's the problem. I know that people keep saying that I need to take care of my health and I need to sleep. But every single individual participant of the clock wants me to review their clock with 100% mentality and 100%, like, I need to be in every clock for 100%. So I think there's no escape for me. I have to be alive for 1 day, 2 days. How long it will take, I need to be live. So yeah, Cyan Froggy, definitely. If I'm still alive, still live by 28 hours, I will do your clock then. If you want me to do my clock after numberbasher's clock, I will do that as well. If Mr. Funny Sheep or any of like NB or Papyrus 1902 is not in the chat. If I do it on a later day, that's fine too. If I do it, but the problem is, I need to end the like if this ends tomorrow, I need to work on the flag and another project and my math class for an entire month. So I cannot postpone this anymore. I had to do this today. I had to end this in one day because it had to be done that way. I cannot do anything else for the next 1 month. I have a band session. I have like a band, what do you call it? Band performance, and we have to practice that for a month.
You have a gig too.
Yeah, I have a gig. So yeah, I'll do it as late as possible toward the end of the stream.
Well,
anyway, I found another solution here. It's root 5 over 2 times root 5. That's the second solution.
You might want to draw it. Oh, I see. Nice.
Yeah, this one. I have 2. I don't know if there's another one.
There are more. Continue searching.
Okay.
Oh my god.
Maybe I go like this. Maybe I go like this.
If you want the honest answer to that, Vadu, yes, we are.
Yeah, we are.
We are working
helping
on it.
Dr. Zai.
We it's the reason why we know how this is going to, how we know that this is going to go is because the fact that we're literally the whole thing is still dynamically changing due to the fact that we've been constantly getting updates on new developments.
Oh, Rishan. Oh, Rishan.
Oh, Rishan.
Sadly, despite the insane amount of development and how much the landscape has completely changed in the past week, that's probably going to be crammed into a tiny little section of the video, which really tells you just like the extent.
Okay, found another solution that's just like a mirror version of that, which is like what was it? Like this. It's like this.
Yeah, I will answer in advance that there are more. But meanwhile, I'll look at your solution.
I have a timeline of the.
I can also probably do one like this, and maybe another one like this.
I love how.
Let's try those.
I love how 50% of things happened in late November and December, and then and then the other 50% is February 2026.
Yeah, that's mainly because of the fact that once we had what Rishan found, you suddenly have a ton of...
No, this one is impossible.
You have a ton of developments that it just opens up to, and it has a lot of implications.
Okay.
Everything prior to it had been pretty much just like individual solutions and whatnot.
How are we gonna cram everything branching from Rishan in like what?
We
in like even a small part.
How? I don't think we can, but the thing is that I don't think it's going to be relevant. That's the excuse that I'm going to use here. It's not relevant to flag construction. No flag requires any of the stuff that we found in the past couple of weeks.
The moment we got section.
So just spoil the wordings in the chat. If you don't want to hear anything, just don't.
I mean, the thing is that like I'd ideally like to not spoil too much.
Oh, okay.
To the chat, just because that this is a public space, so yeah.
Mm-hmm. And this will be a VOD.
Oh.
Found another one.
Yummy.
It goes like this.
Yay!
Speaking
Nice.
of February.
More.
Speaking of February, it is the 25th of February 2026. You know what that is?
Can we do it the other way though?
25th is me and my girlfriend's second anniversary.
Hey! Congratulations!
Thank you.
How many solutions have you found yet?
4?
4. Okay. You're missing 1.
Okay.
Why does it go 228?
This one is impossible.
They pushed
perhaps
numberbasher was originally going to be the last clock to be solved, but they have pushed it higher up.
Yeah, the literal 9th circle of hell. Yeah. Dr. Zyke, you should consider different dimensions.
We have hit 17.
Oh. Into a rectangle where the thickness is to almost into a rectangle. Into a rectangle though. What? Into a rectangle.
It is like AB. Yeah, ABC is an interesting way to think about it. At the beginning, for me, I think at least the beginning of PowerPoint was actually quite similar to how the current state of ABC is like, where it's just like you make big leaps, but they don't really get very far. Just because of the fact that it's like it has reached that level of absurdity. What Rishan found basically steps entirely outside of the realm of what is effectively like it steps out it steps out of PowerPoint and goes into vector artwork effectively.
Yeah, it's just so, and
I do not get what you mean by another dimension.
As a not root 5 over 2 by root.
Oh, not this one. Okay.
Yeah.
Talking to my girlfriend before I sleep, because that's in 3 minutes.
I'll probably get in touch with my own partner. Checking how they're doing.
Zai is doing the puzzle from the 9th circle of fucking hell.
Roots and
Okay, good. They are asleep.
maybe.
That's good.
Maybe.
This is just eternal torture.
You.
This is just diabolical.
I don't. The previous discussion had made me start to wonder if Zai has a partner. Numberbasher, how long did it take me to make the clock? Surprisingly little time. It is
Just bear in mind that Numberbasher basically fiddles about in the puzzling stack exchange, so they have a lot of experience in puzzle setting, pretty much.
Yeah, these are a lot of puzzles which I just reuse, and like a lot of this I just source from other places because it takes time to set a puzzle, and the background for this was I was putting together the list of all clocks for Dr. Zai, and I was like, I kind of wish I made a clock that was just Olympiad level. And that was like...
And then you made a clock that was Olympiad level.
Already ended. The clock submissions have already ended. And so I scrambled to make a clock and finished within 1 hour and 30 minutes and hastily posted it onto the YouTube posts and sneakily changed my submission under the table.
Well, you didn't change it because I've already downloaded it before, so...
That doesn't change the fact that I did change it. It's just that...
Right?
It didn't.
I actually have a joke clock. I actually have 2 joke clocks I submitted.
I wonder if anyone has seen my joke clocks.
So
okay,
numberbasher, I want to know, is it root 10 times root 10 over 4?
No.
Yeah, that's what I thought.
I considered submitting a clock, but I realized that like I do not fare well mentally during competitions, so I decided to just abstain from it again.
Actually, a good choice.
This is the reason why I.
I love math competition.
I can't stand math competitions.
It's fine.
Like I applaud everybody who does partake in math competitions, and it is deeply honorable. But I am just not one of those people that can handle that without self-destructing.
Mine aren't pretty high stakes. You know.
Is it a square?
Is it a square? Yes, it is.
It is a square.
Yeah, I'm an avid math competition participant, but I never practice at all, which I actually insane because I am a fucking good person, like competitor when it comes to math competition. I
think you get your practice straight up just from partaking in these things. You've learned like all the nooks and crannies just by being directly involved in the scene.
Fun fact, I have gotten a panic attack at one of the math competitions I went to.
That's
not so fun fact.
I feel like I would get an immediate panic attack just staring at some of the questions.
No,
this was actually.
Because you know why?
I got it. I got it. I got the square.
You got
it. Looks like this.
Oh my god.
These are the only 5 solutions to the pentomino. Huge thanks for Omega3301, which is the creator of origami puzzles, and this is a genre that he has. Yeah. And to answer the question of why it was moved up the queue, because such that I can see it get done and give hints, and also such that Zai is not in a completely degenerate mental state when it comes to a very hard clock.
Very.
Right, let's go. So that was 5. Let's move on to problem number 7.
Now prove that there are no more foldings. I'm just gonna address this in chat. We don't actually know if there are no more foldings, but I am decently sure. That is all I can say.
That is a brutal thing to say.
This is literally a research question that's been like years into fucking. Like I'm not. No.
Let's. I'm gonna go. I'm gonna get to the toilet real quick because I've been wearing that glove for 30 minutes. It's stuck to my hand.
Yeah, you should.
Yeah.
It is 3 a.m.
Cyan Froggy, you got bronze on the IMO? Get the hell.
4 a.m. for Zai.
With the greatest respect, I feel like
IMO isn't like at heart, but just I'm just okay. I'm blown away by the community. IMO participants. I fucking I hate IMO participants. They always get first in math competitions and leave me with second. Fuck.
Okay.
I feel absolutely defeated right now.
like Alexander won is such a
Okay.
insane. Okay,
I feel absolutely and completely defeated right now.
Let's go. 26 people participate in a round robin. What is the maximum K such that you can promise finding a line of K participants such that every even-numbered participant defeats the odd-numbered participants next to them? So let's think. Okay, imagine there are 26 people around something. Maximum K such that you can promise finding a line of K. Wait, okay. I actually don't know what a round robin is. Maybe this is my English issue. What is a round robin? It's a competition format in which each contestant meets every other participant, usually in turn. Right. Contrast with an
also don't know what a round robin
elimination
is, but now I
tournament
do.
where participants
just
are
every
eliminated
pair
after
of people
losses.
play once. Slime Froggy asked, when am I from? I am from China, if that tells you anything about
Wait.
the difficulty of getting into IMO.
I am from Malaysia.
Wait. So if it's a round robin, then every pair of two has a win and loss? Oh, wait.
Yeah.
Does
Every pair of two has one player defeat the other.
Can there be like a Rochambeau situation where one player defeats this?
It's possible for any set of defeating to occur.
Oh, okay. Okay.
Like, it doesn't have to be transitive. Yeah, this is completely possible.
Every even-numbered participant defeats the odd-numbered participants next to them.
Or you can think of it as a line in which the defeating alternates.
Like this.
Yeah.
Like that. So we don't need to think about any other set of tournaments. We just care about what's going on right in between them.
Indeed.
But then like what stops from this happening?
What do you mean?
Like, what stops this from happening?
We'll just find a different line, different way to line them up, such that it works.
Finding a line. Wait. Promise finding a line of K participants. Finding a line. It's not a consecutive line. Finding a line of K participants like this.
Wait. What are you? Are you claiming that? What are you claiming? Like, every set of two people have to play once, and we're just saying if you can always find a length K, like you can take K participants and line them up to have even numbered participants defeat all participants.
So they are. Oh, I thought people were lining up around something because it's called a round robin. I thought they were already lined up.
Oh, no. Sorry, no.
Right, so they are not lined up. We just need to find people and line them up so that every even number participant. Okay. Okay.
And find the maximum line, which you can do so. I wonder, did anyone get close to getting to the IMO? I didn't personally try. Like, the route to getting to the IMO is very different from the casual. Very different from the casual like math line. If you want to, because like you have to compete in a specific set of tournaments, which I have given up because I'm not that kind of math like I'm not the kind of person which is fit for the competitions which lead up to getting you into the IMO team, which is why.
Which means that I don't even have a chance.
I mean, to be fair, like, I mean, you don't have to go to China's team, which should be easier.
It's like, not unless plans change.
God,
Chinese.
我喜欢冰淇淋。
让我们
just to note, I am also ethnically Chinese, although I can't speak Chinese very well.
So it's just like the three of us who are, like the three of us who are Chinese and Korean.
We're just Asians.
We're just all Asians.
Asia.
Asians. You swear it's like 4 a.m. in Korea? Well, it's 4:11 in 2 seconds.
Zai's time is literally just an hour ahead of mine.
It is 14:11 on my side.
It is 3:11 a.m. I should probably be sleeping soon.
Yep.
You did say you were going to sleep.
You were saying you were going to go to sleep earlier.
You were saying you were going to sleep 5 minutes later, 16 minutes ago. And 5 later than 16 minutes ago. Now.
You may want to go now.
4 minutes.
Do rest. I had my rest already.
I'm gonna take one. I'm just gonna drink some water.
Oh, the chatter telling Zai to go to sleep rises again.
Oh god.
Winning the number.
You'd be telling me to go to sleep. I'm asshole, by the way.
By the way,
okay, you know what? Never mind. Maybe I do need more sleep because I just wrote /2/quad/2 instead of God. Okay.
What is
26?
What?
What did you write?
We have a donation.
Oh, thank you. Wait. Wait. Thank you, John Sai, for the $10. Thank you very much.
John Sai. /quad. So /quad is a quad space, and /2 is the right arrow. So I intended to do space right arrow space, but I ended up writing a right arrow space right arrow.
Oh, you mean /2 as in that too? I thought you meant
that too. Not the number 2.
That explains a lot to us.
Yep.
Oh god. I'm trying to find out a way to make a pun of the 9 circles of hell clock with the cube root of 3 circles, but I can't find a way. Surely there's a way. Like, surely there's a way.
No, there's 100%. Considering, no, look, if you're not going to be the one who finds that, it's going to be Palfly. They're gonna do it in the form of Sudoku.
Oh, we take the 6th. Yeah, we take the 6th root of 9 circles of hell.
Yeah, and you get the cube root of 3 circles of.
I think somebody like. For a time, I remember asking Palfly about this, whether or not somebody found a way to make variant Sudoku, Turing complete? And they said they're getting close. I was like, okay. I don't know the details on that. I just asked whether or not anybody was working on that, and they said it was kind of getting close.
I thought it was
if there is not already a solution.
I didn't even do anything. I didn't even do anything good I didn't even do a lot in the PowerPoint community. I just waste my time. I just waste my life making flags.
I mean, it is very It is very commendable because of the fact that none of us were willing to do it for a good while. I do want to try. Yes, we did both do Croatia, but I do want I was about to just say I want to also try Kyrgyzstan.
Kyrgyzstan. You also have to remember Kiribati and, of course, Kazakhstan exists.
Oh, right. You do remind me. I'm going to I should probably give question attribution to this one. This is the final problem in HMMT team round, which means it's like the hardest problem. But
right.
I wish my sleep schedule was as organized as Arglin's PowerPoint.
Okay.
I wish my PowerPoint was as organized as my sleep schedule. But instead, my sleep schedule has now grown to be as organized as my PowerPoint files. Fuck.
I mean, mine has slowly started evolving, specifically because of the fact that I am genuinely now concerned about the Croatia flag construction is the biggest presentation I have made since middle school. And the only reason I have a PowerPoint presentation with more slides than what Croatia has is because every single slide contained the name of a single bone on the human body.
That's actually crazy.
Crazy. That's what autism does to you.
I did not know what autism was at the time.
It takes a lot of bones to. I'm gonna fall.
I probably did not know what autism was at the time when I was in middle school.
Taking these.
At least not well enough.
Clique.
I think before.
What is a clique?
Before I was even in secondary, I was straight up denying the fact that I was trans.
That's how it all starts.
And then the egg.
That's how.
No.
The egg cracked. :3. 6,
In-
7. 6, 7.
Inside YouTube chat, lazy comment says, "Shake my head. You're not even a dog furry, Arglin. Why that bone obsession?"
Hey, look, I'm allergic to chocolate, okay?
Also
At least
called
that
complete
counts for something.
subgraphs.
That is actually
That is actually such a line. Wow.
diabolical.
For people who are actually wondering, yes, I am actually allergic to chocolate. It is a little bit too coincidental for it.
Is it empirically or medically? Like,
what do you mean by?
As
What do you
in,
mean by
is there-
what's the
do you
distinction
know,
here?
like, is there a specific condition which is causing this, or is this?
No, it is
empirically-
it's specifically. I have tried. Every single time I've had chocolate, it has tasted bitter, and then I would undergo anaphylactic shock.
Jesus Christ.
Jesus Christ.
Yeah.
Okay, I may as well help Zai a bit.
Maybe you should. Yeah.
Hi Zai. You
What
want
is
to
Zai?
you want to
Hello?
consider trying to explain.
I'm
Like, you
sorry?
want to say, like, suppose you have a line of K participants. You want to see if it's possible to add another participant into the line, by either tucking it at one of the ends, or inserting it in the middle of the line, or some other stuff.
Okay. Let's say all the out edges from this go to the ones we've already seen. So all the other things are in edges. Then what can we do? There has to be something I need to learn some of the... There was something about the maximal number of out edges.
You don't need any graph theory results from this. Like, you don't, like, this is completely doable without searching.
But doable, but can I do it? That's another question, right?
Internet searching will not help you unless you happen to find the exact problem.
Right. So that I am more concerned about my doability in that case.
My doability.
So if this is if we cannot add any more of this, then like if we cannot add anything after this, then we also let's say we cannot add anything after this. Maybe it all goes out like that.
You know what, gang?
What?
It is 3:20 a.m. and I have school, and I have to wake up in 2 hours and 40 minutes. So
go to sleep.
I will be going to sleep. Goodbye,
How?
everybody.
Goodbye.
Yeah, good night.
Good morning.
Good morning.
Bye.
Good night. Good morning.
Good night. Good morning. Yeah.
A good day.
I go by
I
by
swear.
lazy comment system, which is it is not morning until the sun is up.
I have
Okay.
one last remark.
I need energy back. I need energy back. Okay, so what are we trying to do here? Let's divide it into 3 types. So let's say, so extending is the hint, right? So let's say first we have something like this. Second, we could have something like this, where you have one like even number, and we could have something like this, where you currently have 3 cases, and let's try extending all of them. How do we extend this one? Maybe if it just connects to something else, we can extend it and it just goes to this one. So let's say we cannot connect anything else to this. So every edge is comes in from other stuff. How would we add something here? If any of these, like if any of these connect here, then maybe we can swap this out for one of these, maybe. Okay. I'm not sure. I'm not sure what happens if we have all images from here. What happens, like, there are so many cases. This can go this way, this could go this way, this could go this way. I mean, whatever. I'll do all the cases. Let's see. So, first off, there are many cases here. I don't know. So, maybe there's an outer edge going that way. Maybe that way. There could be something like this. There could be something like this. There could be something like this. What happens in each case? Can we exchange something and make it longer? In this case, we can make 1, 1, dun, 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 and then, like, let's say this is 1, I don't know, A, B, C, D. Then we exchange it like, so B, C, D, A. We exchange it like this. Right. So, what about this? B, C, A, D. What happens here? I'm not sure. Like, in this case, this doesn't do anything. Yeah, then we have to, like, consider what does this do with other stuff here as well, but, like, if, The maximum.
I would.
Yeah.
I would, for the case with an odd line, I would consider an extra point, how that point can connect to the endpoints of the existing line, and how the endpoints connect to itself.
How the endpoints. So we need 2 points, maybe.
No, you just need 1 additional point, and you need to consider that line, the additional point, and the line between that point and one of the endpoints of the sequence, and the line between that and the other endpoint of the sequence, and the line between the 2 ends of the sequence.
Oh, like this? Okay.
Donation from
wait,
S-Mom
small S-Mom Sun DSO. Your perseverance and commitment's amazing and inspiring. How many clocks are left? We have around 30 more to go. Let's see.
Yep. What's the clock on his side? This is numberbasher's clock. Unless you're talking about the live split on the side, that is how long it's been. This run has been going.
How long it's been since I went live? So
yeah, I think they're the live split.
Yeah. Lazy.
Here's one.
Says, so when do we do Oblivion or Bus stream for 17 plus hours? Lazy, I think I'll be done with Oblivion by then. I think I'll be finished. I mean, you might need a little bit more time, but good luck.
Oh my god, Zai, you really do not need to be splitting that many cases, but oh well, I'll just let you continue.
Or
so in this case, we can move this here. So instead of this, we now have 1, 2, 3, 4, 5, 6, and we have increased it by 1. How about this? Then we just increase it, right?
Yeah, so you've eliminated half of the cases already.
Right. I needed to draw everything beforehand because I cannot calculate that, like, for the life of me, I cannot calculate anything beforehand right now, so I just have to do something that I know I can calculate and that my brain can handle. So let's look at this. Then we just added a new line there, so that's also done. And how about this? Then we can add like the, and that also increases it by 1. And finally we have bam, bam, bam. Then yeah, we just add this to this side, and that increases by 1. So this case and this case, they are both always, they can be increased always if we have just an extra node. Now let's look at the even number situation. Okay, let's look at the even number situation.
Situation is a lot messier-ish, but it works. But you have to consider two nodes except for the line. So you have to consider the line and 2 more nodes.
Okay.
Good luck.
1.
But you have to consider a lot more lines.
2. Maybe 1 there. So if this is this, then yeah. Also, if this is like the, yeah.
I would draw the 2 nodes closer to the 2 nodes close to each other, like approximately in the same place, because they're going to be functioning pretty much exactly the same because they're just 2 nodes.
Okay. Now I get that I have to do this first. I've understood that I need to do this first. So what are we looking at here? Maybe look at this first.
You can just assume one of the directions without loss of generality, because for the line you can assume one of...
That's true. Also, if this is this direction, then we just added another thing like that. So this has to go this way, this has to go this way. And did anything happen until now? I'm not sure. So let's look at this one too. We have... Wait. If it goes like this, then we just added something new there, so it has to be like this. This also has to be like this, but then what happens here? I think there has to be some kind of line, maybe. 1, 2, maybe it's that. Maybe it's that.
The two lines you just drew are not useful, but you can consider, like, because you have a kind of M shape at the bottom, you can consider how the two ends of that M connect.
Oh, right.
In a similar sort of way.
And then probably these two. Okay. If this connects here, then we... Yep, then we... do this, then this, then this, and that increases 1. Do this, then this, then this, that increases 1. If it connects here... One, 2, 3, 4, 5. That increases it, right? That increases it. Also, 1, 2. Wait, 1. No. I think A, B, C, D, E, F, G, H. And originally it was 6, but I just connected 8 of them, right? And that increases it. So...
Okay.
So I can always increase it. Always.
So if it is odd, you can always increase it as long as there is 1 more node. And if it is even, you can always increase it as long as there are 2 more nodes.
Oh, right. If it's even. So it's just 2026.
Yep.
So 2026 mod 12 is gonna be 10, right? Okay. 202. Sheep and a wolf fly on a circle. The wolf takes a random walk until only 1 sheep is remaining. Let's update the thing. What is the probability that the sheep is within 5 steps of the original position of the wolf mod 12 until 1 sheep is remaining? Wolf, sheep, N sheeps, takes random walk. So when the only sheep is remaining, what is the probability that the sheep is... So the sheep never move. The sheep never move. What's the probability that the sheep is within 4 steps of the original position of the wolf? There's also like, wait. Okay, yeah. Units don't matter. Like they are all the unit. Yeah, they are all equal distance apart, I believe. Yeah. And
yeah, and then
within 4 steps is probably up till here. 1, 2, 3, 4, up till here. Up till here. Yeah. So the wolf can move at whatever way, and it has to like not.
I hate this chat. Why is there's just people in this chat complaining about solding so hard on last year's IMO? God. I solved the first 2 problems, but I made a mistake on the 4th problem. I got 18 points.
Okay.
Bruh.
I am still angry that I didn't get the you know what, the programming.
You are exhausted. I cannot blame you. I don't think I would be able to do that myself.
Let's see. So the problem is I don't know. I don't have the intuition for this. So how would you, like, for example, if this is the one that's left, what's the probability for that? Like, you have to visit all the way up till here, but you should never go here. And like, I think, like, it feels like it's not gonna be a whatever the wolf doesn't take is not gonna be a uniform distribution. It feels like it's much more. Oh, but then again, is it really more probable for a sheep here to be the one that's left? Because in the end, if one sheep has to be left, then it has to be like the wolf has to do all this for that to work. On the other hand, if this is the last sheep, then the minimum distance the wolf can travel is this, which is a lot shorter than in this case. Like, in this case, the wolf has to travel this much, at least, to make this one the last sheep. The minimum distance thing is really weird, but at any point the wolf can turn, and this, it's random.
For the entire duration of this problem, I'm gonna stay silent because I think it's a problem that is get-writable. Like I think you can get this right. I personally got this as an application problem, and I got absolutely slaughtered by it. But yeah, I did. Yeah, there is a 3 blue 1 brown shirt about that, about this problem. But I learned about it way before by having been murdered by this question in an application set, but I did get into that camp, so I'm happy. But that was a murderous.
Like, it can move for an indefinite amount of time. Like, it just has to visit everywhere except there. So do I take a limit of something? Do I like keep dividing this up to smaller parts and like say this is L, and then try to see if L reaches 0 and what's the chance of the wolf never visiting this section? Maybe. What's the chance of wolf never visiting this section? Like, actually, at first, like, I don't even know how a random walk works. Wolf can go this way, half chance, yeah, half the time. Can also at any point turn around. So what's the distribution look like? It's gonna be centered around this part, and it's gonna be more and more, yeah. We're assuming, yeah, we can assume because we're only looking up until 1 sheep is left. We know that the wolf never makes a full turn. So the distribution of the wolf being at any point is, I don't know. what would be the probability of the wolf being somewhere around here versus somewhere around here? Like if this is L, like after a certain point, maybe is that worth asking? After a certain point, what is the chance that the wolf flies at this part? It's not just like if the entire thing is 2 pi r, it's not just x over 2 pi r. That's stupid. It's gonna be like what? Like how does random walk work? Random walk.
If you're acting mechanically, how it works is every step with equal probability, it goes either left or right 1 step.
Oh, okay, right. Wait, I can think of it as discrete, actually. Right. Right,
Yeah,
it's actually
it is
discrete. Oh. Right. It actually doesn't change if it's continuous or discrete. Ah. Okay. So
This is a version of the Ladybug Club, but yeah.
like maybe like if t is equal to 1, then the distribution is like negative 1 and 1 half of the time, like this. If t is equal to 2, then it's like negative 2, 0, 2, and it's like 1/4, 1/2, 1/4. If t is 3, then it's like negative 3, negative 1, 1, 3, and it's like 1/8, 1/3, 3/8, 3/8, 1/8. So it's gonna be at t equals 2n. It's gonna be negative 2n to 0 to 2n, and at point position 2 I, it's gonna be 2 to the 2n over like what's it, what 2n choose n plus I. No. What? It doesn't matter. It doesn't matter. It doesn't matter. Whatever. So, what's the chance that the wolf never visits this part right next to it? I don't know. 1, 2. Wait, it's actually the same in the dots, in the 3 dots case. It's actually the same in the 3 dots case. But, like, why is it the same? Why is it the same? Why is it the same? Like, if it's the same, what's the answer? That's the answer. But why? But why? Let's calculate that first.
If you want to know why, I would suggest you watch the 3 Blue 1 Brown short. It does a quite nice job of explaining.
That's mod 2. That's 1 mod 12. So I guess that's just 8. Right. Okay.
A ladybug lands on the 12 of a clock, and every second she moves randomly to a neighboring number, either 1 step clockwise or 1 step counterclockwise. Here, each time she touches a number, I'm coloring it red, and on this run of the simulation, the last number to get colored is 3. And if I run the simulation a second time, again where she continues until every number is colored, the last one to get colored is 1. My puzzle for you is, what is the probability that the very last number to get colored is the 6? This is the first in a set of monthly puzzles that I'll be posting this year as part of a collaboration with the mathematician Peter Winkler. Last month, I posted a puzzle. A ladybug starts on the 12 of a clock. She takes a series of random steps, either clockwise or counterclockwise, each with random chance. Each number she touches gets colored red, and the puzzle is, what is the probability that the last number to get colored is a 6? If I simulate it many times in a row, recording which number happened to be the last one colored, here's what it looks like. Running this many hundreds of times, a somewhat surprising fact starts to make itself clear. All the numbers between 1 and 11 seem to be about equally likely to be the last one touched. I say this is surprising because initially it feels like ending in a 6 should be less likely than ending on the numbers closer to the initial position, like the 1 or the 11. And yet, empirically, that just doesn't seem true. And there is a key insight to understand why. Rather than calculating the probability of ending on a 6 from the initial position, start by letting the ladybug wander until the first moment that she hits one of the 2 neighbors of that 6, the 5 or the 7. And then from there, ask the probability of ending in a 6. That is a different question, but the reason it doesn't change the answer is because for any run of the simulation, eventually she's going to hit the 5 or the 7 at some point. That's bound to happen with probability 1. Waiting for this middle condition does nothing to change the probability of that final outcome. So,
right,
from this state, where she's on, say, the 7, what's required to end on the 6? Well, she has to reach that untouched 5 before ever touching the 6.
Yeah. Okay. I had a I had a really weird, like, while I was looking at this, I thought, yeah, I did think that after this point, it just becomes the same as going from here to here, but I didn't like because I wasn't considering this part plus this part separately. I thought this would be rarer because it just takes rarer to reach this point. It takes a longer time to reach this point, and I thought that mattered. And then from then it's gonna be the same as like here, but I guess yeah, it doesn't matter.
Yeah.
Okay, it doesn't matter.
Everybody's asking. Yes, this is. I'm obviously aware that this is the same problem, but I'm using a phrasing which I heard way before the 3 Blue 1 Brown video got popularized. I got this as an application problem, and it absolutely murdered me.
Okay, consider a game on n nodes where Alice and Bob take turns drawing edges, and the first to create an odd length cycle loses. Starting with Alice. What is the smallest n greater than 2026 such that Alice has a winning strategy mod 12? Consider a game on n nodes where Alice and Bob take turns drawing edges, and the first to create an odd length cycle loses. N nodes. Alice has a winning strategy. Okay, this is like... I forgot the name of the theorem. First to create an odd length cycle loses. Starting with Alice. So let's see. This is Bob wins. Alice, Bob, Alice, Bob, Alice. Bob wins, so? Yeah.
It's really funny looking at a fish perform alpha beta pruning in real life.
Okay. I'm not sure how it works. Bam, bam.
Okay, you might be missing some prerequisite. What do you first think of when you see odd cycle?
What do I first think of? It's an odd cycle. What do I first think of?
Like, what does the fact that the cycle length is odd make you immediately think about anything, if anything?
A cycle is odd. If I cannot color alternatingly.
Yeah, basically. But yeah, which is to say the graph is bipartite.
Ah.
That is all the prerequisite you'll need, I believe.
Maximum bipartite graph. Wait. But it's kinda... Wait. So we are... So both players are... Can I just ignore this? I believe both players are trying to make a maximum bipartite graph on their turn. And like they don't want it to be possible to make a maximum bipartite graph on the next turn. They want to make it on their turn. Like on their turn, on all the odd turns. Does that make any difference from just creating a maximum bipartite graph? I'm not... What is a maximum bipartite graph? Matching. Complete. Complete bipartite graph has vertices n plus m, edges mn. And are they trying to minimize mn and minimize the number of edges or maximize the number of edges? They want to minimize it on their turn if it's like if they can do it an odd number of turns. Like if I am Alice, what do I want to make here? Like Bob does this. Like for example, 1, 2, 3. Like when if Alice does this, then Bob can do this and win. But if Alice doesn't do that, then Bob is unable to do that, and that kind of complicates things too much for my brain. What are they trying to do? What is the best move? Is like here, at least Alice shouldn't do that, but does that change who wins if Alice does this? Like Bob does this, maybe Bob does this. That doesn't change anything. So in this case, Alice loses anyway. I think. And then mn is a number. Mn... if Alice has a winning strategy, that means mn should be odd. Greater than 2026. What happens when... No. mn should be odd. Like... Alice, Bob, Alice, and it wins. Right? Alice, Bob... But what does that do? Like... If Bob makes it like this, then... Alice... Bob... Alice. So Bob wins. So 4 is 1 plus 3, but also 2 plus 2. 1 times 3 is odd. So if the players follow this, then like Alice wins, but if the players follow this, then Bob wins. Right. But the problem is... This... Like... What is making Bob win in this situation? What is like what is making Bob win in this situation? Why can Bob change this into a 2 bipartite graph? What is making him able to choose? I don't know. 5 is 1 plus 4. 5, looking at 5 is not necessary. 6 is 1 plus 5. Also 2 plus 4. Also 3 plus 3. So if you follow this, then it's an Alice win. This is a Bob win. This is an Alice win. But like, let's say Alice tries to go for this, but Bob can say, no, I'll do this, maybe this. And then can Alice change this into a 3 plus 3 bipartite graph? Can? Maybe just connect this with this. Bob wants to keep it 2 to 4. I don't know. Like if Alice does this, Bob can... I don't know. Doesn't that like guarantee it to be this? Yeah, I think so. So
Alice will force it into a 3-3 by connecting the 2 dots at the bottom.
Oh. Oh. Wait, how is that possible though? Maybe it's just always possible to change it into the next one. In that case,
And also stream has hit 18 hours.
oh, right. In that case, it has to be 2030. And 2030 mod 12 is 2.
Yippee.
Okay.
That's correct. So the logic behind this is that both sides can always stabilize the configuration. So you can't force it to be 2 plus 4, but you can force it to be 3 plus 3. So the winning side will force it into the stable configuration.
Okay. Right. Let's update the problem. On a truncated icosahedron, I start on a square and take a random walk going to each adjacent face. Wait, that's actually icosahedron. What is that? Icosahedron is like a...
You should... it is not just that... you should search up the full term, truncated icosahedron.
Oh. Truncated icosahedron. It has 62 faces, 30 squares, 20 hexagons, 12 decagons. Starts on a square and takes a random walk. Each adjacent face with an equal probability. What is the expected time for Xi to return to the original square? Mod 12.
You might also want to do some Google foo. This basically concerns the result, which you may not know, and doing it without this result might be tedious, but it's definitely possible.
Okay. Random walk on polyhedron. No, this is not it. It's a vertices. I mean, you can change it into vertices. Yeah, it's a Markov chain. With 62 vertices. And then for each one you have like, so it's like a big Markov matrix where for a square you get like one quarter to some other faces, and then all zeros, and then for every face you get a row, and you try to find, so you try to like find an inverse of that, do whatever, What? Simple random walk on distance regular graphs. What? Vertex transitive graphs. Hitting times for random walks? What's a hitting time? I don't know. Also, I cannot... Like... Huh. Huh. Symmetric. Stationary distribution is, what is that? Vertex transitive automorphisms? No, I don't know what that means. Expectation. Distribution of the time for the random walk started at V to first hit W. So that is the hitting time. Okay. Mean hitting times and related quantities. Numerical calculations for particular graphs. See the triangular prism. For each pair VW we have LVT, WTT, and so in particular. Wait, L? What was L again? Distribution? Okay. Independent of V. Proposition 6 gives a lower bound for the coefficient of variation of first passage time distributions. What am I, like... What am I? I guess it's just independent of V, and that's just the entire thing I need to know, and it's just like the ladybug clock puzzle, maybe. It's just the number of vertices reciprocal, maybe. But then, what is the expected time actually? So how are you calculating? Oh my gosh.
I can supply you with an additional link into the Discord.
Okay. Transitions between different states of a Markov chain describe short-time behavior of the chain in most models. System change states many times per Stochastic process is said to be stationary if the random vectors... What is a stochastic process? Vectors x0, x1, x2, xk. Oh, I mean... Oh, I was just saying, like, is this a sequence or something? Yeah, I guess it's a sequence of vectors.
Do I understand all of this? No. Do I know what the result is? Yes.
Okay.
Did I see the result within this paper? Yes. So. I assume that should be enough.
Stationary distribution. What? Wait, stationary distribution if what's P what is P actually?
P
probability. Okay. Probability is pi I for all.
Yeah, the folded-ish thing. The variable P is transition matrix.
Wait. X0 is a constant while x1 takes two values with equal probabilities. X is what? Okay, X is a x0 is a value. Okay, okay, it's a probability variable. So what am I looking at? Pi is, what's the pi? Initial distribution, transition matrix P. Wait. I didn't know you multiply it to the right. Just multiply the transition matrix to the right. How about if we start from a different initial distribution, whatever. Example. Suppose that the state space S of a Markov chain is finite and let be its canonical decomposition into Okay. Okay. What is this? Is it this? Maybe it's this. What? What? This has to be it. What is this? What is this? Return. Cax theorem. One over pi I is what is it? Pij, Corresponding random walk is irreducible and each state is recurrent. The interesting thing is that there is a very simple expression for the unique stationary distribution. Indeed, if we write our usual system of equations that defines pi in this case, we obtain I tilde j. If we plug in pi I equals di to the right hand side, there are dj terms. Dividing by their sum. So it's degree degree 4 divided by total number of edges 180. 1 over pi I. 45. That gives us 11. No. 9.
The slight difference is pi I is the sum over all of the degrees, which is actually each edge counted twice.
That?
The pi is d divided by d summed over all vertices. Slightly.
Oh.
Up. Yeah. So yeah, these are counted twice. Yeah, which means the answer is 90.
Right. 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 Okay.
Hooray!
Okay. Okay.
It's
11 o'clock. Let's go. 2026 smallest positives integers. Positive integers are rearranged and their prefix sum of the first k numbers where k is a positive integer less than 2026. Are computed. What is the maximum number of perfect square prefix sums? Mod 12. So 1 to 226. Maximum number of perfect square. Like 1, 3, 5, 7, 9. 2025.
But then you can possibly hit more.
Yeah. How much is this? So let's compute this first. We need 4 times 10 13 plus 4, and we can make that up with the even numbers. Okay. Maybe. Wait. What was this? Maybe I'm just horribly wrong. Maybe I'm horribly wrong. That's wrong.
Also, can you slightly change, can you slightly change the specification such that k is a non-negative integer instead of a positive integer? Because otherwise it is off by 1.
Oh.
So basically we're counting 0 as a prefix sum.
Wait. Oh. Wait.
Just because otherwise it's messed up.
Wait, then it's... but then my answer is 1241, I think? My answer is 1240. And that just doesn't make sense. Okay, I did something really wrong.
How did you get 1241?
I'm not even sure because we have 1013 here, and then I thought for every 4n plus 4 starting from n equals 1013, if we can add 4n plus 4 to what's already there, so right now we have 1013 to this 1013 squared after all the odd numbers. So I did a from n equals 1013 to x for n plus 1. This has to be less than or equal to the sum of all the even integers I have left. And that is this. And I solve that. X has to be 1239. But that means we get everything. We can add, like, at the end we get like 1239 squared, and then we are able to add 4n plus 1 to that, and we are able to get everything up till 1240 squared. Which means I have 0 squared up to 1240 squared, which is 1241 prefix sums being perfect squares.
How did you add from 1013 to 1014 squared, say?
So I didn't actually calculate that. I just assumed that it's going to be possible. So it's, what's this? Wait, actually, do we just get... Oh, can we just get 1014 squared? No. No. We cannot get 1014 squared. We have to get 1015 squared after this. Isn't it? Like, by... by adding that. Am I wrong? And like you have all the even integers up to 2026, so you should be able to make this, right? Right? Shouldn't you be able to make it every single time, or does it stop after some point?
The result is that after 1013, you can only make every other square number. but you can always make it.
Yeah, so 1015 squared, right? After 1013 squared.
Yeah, and then 1017 squared, etc. You can always make it.
Oh, wait, I did the sum completely wrong then. Wait, this is wrong. And so what is it? I had to what I actually had to do was n equals 506 to x, and then do 4 to n plus 1 plus 4. Oh my gosh. Ah! I spilled water.
That was a sudden jump scare. Gosh.
Very.
And Chad is saying first sign of sleep deprivation. Man, we've already been so much past just first signs. Where are we even at? No.
You guys, Jesus.
Yeah. Zai is probably just cleaning up the water spills.
Yep,
PNG Tuber is speaking some very interesting things. And also, people have been asking if there is going to be a highlights video of this video, which I assume not.
I need to make it because I don't have anyone helping me right now. So if I have time, right?
But like I was assuming like a highlights video instead of just an awards ceremony ish.
Yeah, of the stream, right?
Yeah.
Yeah, I'll have to edit that if I have time. 714.
Good luck. Well, I mean, I have contributed more than 4 hours of footage.
Yeah.
This is just going to be the time lapse at the very end.
Just it's really just funny how I can just go to 4 hours before and it's still just my clock. Clock.
Why do you have to torture Zai like this?
1223. 1223. 1223. So it's 11?
Yep.
Okay. And this is 12?
And the final one is 12. Yep.
Yeah.
In fact, you could have started by solving the last problem because every of the other 11 problems all have mod 12. Therefore, they must be less than 12.
Yeah.
So it was essentially 2-3 questions.
Okay. So I wasted 30 minutes for one of the questions. And this was not even a submission. This was not even a submission on time. So this is
this was not even a submission.
Not even gonna be graded.
You just have to do this.
Yeah. Okay.
On Earth.
Thank you for making this clock. Now please go to sleep. Thank you so much. Thank you for making this clock.
Oh god.
Okay.
The worst is over, Zai.
That's a solved clock. That's solved clock.
Let's hope the other clocks are not nearly to any order of magnitude this hell.
But
you desperately need to get this wrapped up.
Sai and Froggy wants me to solve their clock.
Yeah. Let's push them up.
Yeah, and they're saying they have hope that now I can solve it, and I don't know. I don't know how. Okay. I'm gonna get water, and please, I will end the call. Right? I will end the call. Thank you for being here.
Zai and Froggy is saying no, not now.
Not now?
No, not now. They want you to sleep.
I'm assuming they want to wake up and still see their clock.
Yeah.
Even though I have no idea, like, they want to wake up and see their clock afterwards. So
yeah, I guess that's what they're doing. That's what they're doing.
Last.
Yeah. Okay.
I will go to sleep.
But it was fun talking with you.
You desperately need to sleep.
Well, I'm gonna end the Discord call. So thank you so much. Thank you so much for being here.
All right, you take care, Zai.
Right.
Please do take care of yourself.
Yep.
Do take care.
I just spilled water, so I need to take care of the water situation. I need to get more water. Yeah. Thank you.
All right.
And I will take care.
See you guys, chat.
Yep. Thank you. Okay. I will get more water. Ah. Okay. 18 hours, 45 minutes. And we are done with the hardest clock on the entire list. There are 23 more clocks. Okay. No, not eating dinner. Uh-huh. So. Now. I will leave tips on my latest community post. SZY Mech, thank you. Okay. Okay. The real grind starts now. It's just me and this mountain of clocks. The next one is by Mr. Funny Sheep. Let's see. Mr. Funny Sheep. Repost number 1. Let's see that. Let's look at that clock. Bam. Lock it in. Lock it in, literally. Control-Shift-L, lock it in. Very bad math clock. Let's see. Okay. 2y squared divided by 5. Y equals 5, so this is going to be just 2 times 5. This is 10. Plus 5 over 2 minus 1 over 2. This is going to be 2, so this is 12. 1 plus 1 minus 1 plus 1 minus 1. That's just 1. This could be like cubed, but that doesn't matter because it's 1 anyway. We have an insane number here. Square root. No, not square root. Root of 99. So 633-825-300-114-708-351-602-688. The power of 1 divided by 99. Does that give us 2? Yes, it does. Now, for 3 o'clock, we have 3a minus 10 equals 2 minus a. So, 2a equals 12. That's unfortunately 6, I think. Yeah. I think that could be 6. Here we have insane number. Actually, instead of calculating this, we can just do 4 the power of 999. And it looks like it is indeed 2.87 to the 10601. E601. So this is for next one, 345, right? Another 9999. This time we just make 6 to the power of 9999. And that indeed gives us 5.42 to the 107,780. Amazing. Next one, we have 7 o'clock. E7777, very fitting. Bam. It is indeed 2.125 to the 106572. Okay. The next one is a pretty hard one. I see what you're doing here. I 1 to infinity. This is just gonna be 1. 1 to 9 and 10. Wait. Yep, that's just gonna be 1, 2. And Or not. Wait. Yeah, this... It's 0.9 plus 0.09 plus stuff. So it has to be 1. This is sine squared theta plus cosine squared theta, I suppose. So that's another 1. This is ei2 pi, so that's another 1. We have 4 up till now. N, 1. Is that combination sign? I think that's a 2 to the n. There's a 1 over there. That cancels out to 2. There's a half over there, so this is another 1. We have determinant of 1, 0 plus... Okay, this one is kind of confusing because I don't get what this is. I believe this is a plus here, so there... I think there was a matrix here and it got kind of rubbed out or something. I believe it's supposed to be something like determinant of 1, 0, 0, 1, the unit matrix. So this has to be 1, maybe. And I believe these are just 8 ones. So this was a 6th one. This has got to be the 7th one. Because I root 6. Yeah, it's 6 root 3 plus I... But this is 2 root 3 plus I root 6. No. It's like this. Okay. It's parenthesis 3 root 3 plus I root 6. So the size of that is going to be 3, but we have a third there, so this entire thing is again 1. That's the 7th one. This is 0 to 2 pi over 2 cosine x ds. That is 1, so this is 8. Right? And 9, we have a simple 3 times 9 divided by 3, so that is 9. Okay. We have 1 to the e2026. Yeah, that's just 10. That is why this and this have the same number. Here we have 3 times 2 plus 2 times 3 minus 1 is 6 plus 6 minus 1 is 11, and that solves the clock. Thank you, Mr. Funny Sheep, Mr. Funny Sheep, for that clock. We're going to move on to NBIE. Let's see. Bam. Delete everything first, actually. Bam. Bam. Okay. Let's see. This is from NBIE. Details. At the 5 o'clock, the result is rounded up. At the 4 o'clock, the first bit has the value of 1 and goes from left to right, top to bottom. Okay. So, 2026, 12. That's 26 by 26. I guess it's like 2026 something something. But the important part is that it's a lower triangular matrix and all the diagonals are 1. So it's going to be, the determinant is just going to be 1. We have E of 206. I actually don't know what it means. I think it's the edge count of this graph, which has 2 edges. So maybe it's 2. K2, 26 times. So this is going to be 12 minus 1 is 11. 11 in base 2. Like 11 in base 2. That's 3. Oh, 2 in base 3 is just 2. 11 in base 2 is 3. So this entire part gets deleted. It's just 11 in base 2. So that's just 3. Find the error bit Hamming code. I am not sure what a I'm not like sure how I'm supposed to do Hamming code there because like it's not a 7-4 Hamming code. There are 9 rows here. So I guess like from the first row we have 1 1 0 0 1 0 0 0 1, right? Let's see. So the Hamming code works like this. This bit contains these 1, 2, 3, 4, whether these rows have an even number of black squares. And if it's odd, it's a black square. Yeah, I mean, if it has an odd number of black squares, then this has to be a black square, I think. Wait, is that how it works? Wait. I'm not that good at this one. Oh, it works like this. Okay. Okay, it works like this instead. So the parity of these 4 cells has to be this one. And the parity of babam parity of these 4 cells have to be this one, maybe? Maybe. Oh, no. That's wrong also. How does it work? Wait. I think it works like maybe? Maybe that's how it works. I think. So this is like and this one is just I think it's okay. I don't think this is. I'm not sure. That's extended Hamming code? Okay. Wait. Use the grid on Wikipedia? It's this, right? Update the title at the top. Thank you. Thank you. Wait. I were doing it correct. I just need to do it on the entire grid. I just need to do it on the entire grid. Okay. So, wait. This is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 by 9? That's 117. So we need... Okay. 1. How am I even gonna do this? Huh. 1, 1, 1, 2, 4, 5, 6, 7, 8. I mean, 8. Huh. Let's see. Even. Odd, even, odd, 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 even. Odd, even, odd. Is that how I'm supposed to do it? Is that it? Is that actually how I'm supposed to do it? Okay. Odd. Even. Odd. Even. Okay.
Odd, even, 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 odd. So like there are no errors. Like, what? Is that? There are no errors. The 1 2 3 4 the 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 Odd, even, odd, even, odd, even, odd, even, odd, even, odd, even, odd. Even, odd, even, odd, even, odd, even, odd, even, odd, even, odd, even. Odd. So this is wrong. 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 da 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 5 6 7 8 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 the odd even 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 right? And what now we have to do 16 actually 8 9 10 11 12 13 14 15 16 16 1 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 bam. Bam. 1 2 3 4 5 6 7 8 9 10 1 2 3 4 5 6 13 14 15 16 da 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 odd even 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 odd and that's also correct. What? Am I actually just what is happening here? Let's do 32 16 17 18 19 20 1 2 3 4 5 6 7 8 9 10 1 2 and we're supposed to do 32 1 3 4 5 14 23 24 25 26 27 28 29 30 31 32 5 14 23 32 yep. And then we have 9 18 27 the 32 and then we have all of these right. So let's look at odd
even, odd, 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 even. And that's also correct. Or I have gone crazy. I have actually gone crazy. I have actually gone crazy. We went from odd even to even odd. Really, really. Really. 14, 23, 32. Then odd, even, 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 odd, even. No. So this is 32. 33, 34, 35, 36. 45, 54. 54, 63. 64. Bam. Right? And it's just gonna be everything after this. Odd, even, 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 odd, even. And that's also correct. So, so only this one is wrong? What? And the fourth bit is wrong? Okay. So it's the fourth bit that is wrong. It's the error bit, the thing that's wrong. It's a parity bit. Parity bit is wrong. 51.51 degrees. $25. So this is 5. This is 2, and it's an XOR. 2, that's a 0. So that's a 6. One digit of a 2-digit number such that when applied the collapse conjecture, it reaches 1 faster than 2026, exactly 1 step. 2026 reaches what? 112 steps. We need 111, 111. 111. No. 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 Maybe it's this. I guess what I can do is just this. What happens with 17? Steps 12. What happens with 27? Oh yeah. This is a 27. One digit is a 7. Max element of max element is 2 and 6, so 8. R1, R2, R3 are the roots of these numbers. So it's squared, it's product squared, so it's this squared, so it's 9. That's a 10. Max amount of comparisons to search a sorted array of 2026 elements, binary search. So it has to do with how this is lower than 2048. And that is 2 to the 11. And that is why we need 11 binary steps, yeah, to search. So that was NBIE's clock. Thank you for submitting. Next up, we are going to move on to Papyrus 1902. Wait. Right. After quite some work, here is my entry for Dr. Zai's 2026 Math Clock Contest. I decided to not only stop at math, but to do also a couple of interdisciplinary puzzles. Follow the 2026 and rule best as I could, but in some puzzles I had to do some small workarounds. In the following slides there will be the solutions for all the puzzles. Where is the 2026? Right. Great. Wait. Actually, I only tried... Okay, whatever. It works. It works. Okay. And they have solutions for each problem, which is amazing. So, let's start from 1 o'clock. It is 2.026 liters and 0.2026 moles. So the mole divided by liter is going to be 10 to the negative 1. And pH, I mean, yeah, the mole thing, molarity, I don't know what it's called, mole something. pH is minus log of this, so it's going to be 1. Area is equal to circumference, then 2 pi r is equal to pi r squared. I mean, 2 pi r here is equal to pi r squared, so r has to be 2. Here we have x dx, that's just gonna be 2. This one is gonna be 4, divided by 2 is 3. This is multiplication, vector, like, okay, 2 times 2, 0 times 6, it's 4. Around e to the 20 divided by e to the minus 26, is it I squared? So it's just around 2026 divided by e to the 6. And that's around 5. Amazing. Denominator of pi squared over 6. Bessel problem. C, I think I saw their solution to this. It was supposed to be this C note equals 0. And then this is 2 notes higher than that. 2, 2. That's 4 notes higher than this, so that's 2026 hidden in a like 7-tone scale, right? Do re mi fa sol la si, you know. Here we have, that's 1. That's also 1, so it's 2 times 2 times 2, which is 8. Here we have log minus, so log 2026 x equals, you send that way, and it becomes x squared over 9. So x has to equal 9. Here we have 2026 mod 12, which is 10. Pi 2026, so that's prime pi. Prime pi 2026 minus prime pi 1942. And that is 11. Nice. And finally we have 3 times 4, or that's 12, or 2 times 0, 0 times something, or 0. And that solves the clock. I also looked at their solutions. It's very well put. Thank you for this amazing submission. Okay, next up, we're gonna move on to Pinchas. So Pinchas clock, and Pinchas one is like, I never got their email or their YouTube post because their YouTube post was like somehow deleted and I can't find it anymore. So if Pincha ever sees this stream or like the VOD, please give me an email to letter.2.zai@gmail.com. It's in my channel, or you can like leave a comment, but I might not see your comment. So if Pincha, if you ever see this, please give me an email, because I do not have your YouTube handle or your email. I cannot find it. Okay. Anyway, let's look at this clock. So we have, this is 1x squared divided by 2. So this is the x squared equals 12x thing, which is 0 or 12. Here we have, this is a matrix with all the things equal. The determinant of that is going to be 0 because this is not invertible. So factorial of that is 1. Here, we have an amazing puzzle. So we start from here. N, U, wait, actually, wait, actually, where do I start? I thought we start here. Oh. Number, maybe we go like this. Number, like, I'm gonna just capture that and come here, and I think we're supposed to go like number. Oh, I think it goes like maximum number of odd nodes for Eulerian path. So, you see, if an Eulerian path has an odd number of nodes, it has to be 2. It has to be 0 or 2. So the max number is 2. So that's why it's 2 o'clock. Here we have mines. Okay, what is this? I'm not sure. So there are 2025 mines, location unknown. Start. I'm not sure. Okay. Minesweeper? Like, yeah, I was looking at this today morning and I didn't know. I didn't understand this one. I'm just gonna leave it at that for now. I'm gonna continue here maybe. Whoa. Whoa. There, that's 64. Oh, it's Graham's number. This is Graham's number. Right. At first, like the Graham's number starts from G1. Or is it like this? And it's 3 to the 4 arrow 3, and this is saying how many arrows in the first thing there. So I think that's why it's 4. Next up for 5 o'clock. So I believe it's like set theory notation, maybe. Yeah, I think these are set theory notations. Like n you do something like this. Each number n is represented as a set that includes everything from 0 to n minus 1. 0 is just an empty set, so that's included everywhere. This is a 2 because, like, wait, is it a 2 though? Wait, I'm not sure. Actually, I'm not sure anymore. This is a 1. This is a 2. This is a 3. This is a 4. This is a... This is a 4, but you got 1. Oh, this is 0 and this is 2. Right. Right. Where's the 3 though? Oh. Maybe, wait. Yeah, this is 1, the 0, 1, 2, so this is 3. So this is 4. So this is 0, 0, 1, 1. Right. So this is 2, this is 3. 1, 0, 0, 1, 2, 3, 4. We need a 5 for this to equal 6, and that's why it's a 5. It's actually really creative the way they made 2026 here. And here, I don't know, maybe hex code? D9 B766. I'm not sure about this one either. Maybe we just... Huh. Stack instructions? Oh! Wait, that actually makes so much sense. So, we put in 2, 0, 2, 6. We see a plus, so we add the two of them up. So, at that point, we get an 8. We put that back in the stack. We get a times. Wait, was that a times plus? Actually, times plus divide. Times plus divide. Times plus divide. So when you see a times, we do 6 times 2 is 12 and put that back in. When you see a plus, we do 12 plus 0 is 12. Put that back in. When you see a divide, we see 12 divided by 2 is 6 and put that back in. And the final number left is 6. That's the stack. Okay, that's really clever. 1, 1, square root of 2, square root of 3. That's 7. Hypotenuse of 2025 times 2027. Yeah, if we go on like this, then the 2025 times 2027 triangle will have an hypotenuse of 2026. And that's because this is 2026 squared minus 1. Okay. It's digit 1 TS 1 TG digit. First digit. Oh, it's first digit. First digit. First digit of... wait. I'm not gonna be... Like, I'm not accepting any late clock submissions. I'm just looking at them in the stream if I have time. I'm not accepting any late clock submissions. Read it from first digit. So what is this? Is it 20 and base 26? Maybe? So that's 52. Maybe? 104 plus 6, so 110. $220. 446. I don't think this is working. Maybe it's supposed to be the first digit is this 8. Okay, that's the first digit 8. Orbitals of atoms, yeah. Minus 20 minus what? Log. What do you think this is? I'm not sure. This was... I mean... minus 20 minus... This is a variable, but the log makes me think we have to, like, I don't know, calculate the factorial? Log. I'm not sure. Will this happen again next year? I'm not sure. Maybe. But not in the same format. In a little slightly different format. Wow. What is this? I kind of want Pincha to see the video and give some clarifications on how some of the puzzles work, because they look really good, and I would like to know how it works. 36 times 46 minus 4 times 6, 24, 22 minus 3, 19 squared? One. That's 29. 29 squared. Minus 20 plus 64. 44 minus 3. 41 squared. Right? 46. Plus 10. Try to make a bit more structured. I mean, I'm just a single person. How? I don't know. Like... So, at least what I'm gonna do is that I'm gonna make it make the rules so that you have to give out explanations for every single step of the puzzle, of solving your clocks puzzle. That's at least gonna be the rules for next year if I ever do it. Yeah. Plus 3, that's 59 squared. 66 minus 858. 59 squared. That's 59 squared again. That's all multiplied, right? That's a big number. Oops. Huh. I guess that's not it. Maybe. Maybe we're supposed to see what? Huh. Okay. I don't get what this one is either. Maybe it's supposed to be that this entire thing is a triangular number? Like this? Maybe? No. At least it's not... yeah, I didn't get it. So, yeah, I would need some clarifications on some of these puzzles. Like 3 o'clock, I don't know how to solve it. But the other ones there were really creative. The 2 o'clock, the 6 o'clock was really creative. The 5 o'clock was 2. So, yeah, 9 o'clock, 10 o'clock. Oh, by the way, yeah, I forgot 11 o'clock. 11 o'clock is a... what was it? I have my notes for this one as well. This is Epsilon 1 from Googology. And what is it? It is the Veblen function. The thing on top is the Veblen function. And so, how it works is that the Veblen function, I'm not going to explain it at all, like in its entirety, but if it's 0 and something, then it equals something like looks like this. And if it equals 1 and something, then that equals something that looks like this. And here, it's very creative because 6 divided by 2 is 3, but we're like rotating it 180 degrees to make an epsilon 0 there. And that's also from like ordinals, transfinite ordinals. So this sequence, like, you can think of it as something you get after continuing this sequence forever. Oops. We know that that is equal to epsilon 1. That's just from transfinite ordinals. So, as you can see here, this is going to be equal to the function 1, 1. So that's going to be 1, and that's why it's in 11 o'clock. IMO 5번. 알겠습니다. 그거는 나중에 그럼 확인해 보도록 하겠습니다. Anyway, thank you, Pincha, for submitting this clock. And that's a solve. Okay. I need to go to the toilet. So, thank you for waiting. Odd even, odd even. Odd even. I'm back. Okay. We still have a long way to go. So... let's go. Really? And Hasana, maybe? I'm sorry, I do not know how to read your name. But thank you for submitting. Let's look at this clock. Welcome back to the Infinite Math Clock Gauntlet. Yep. Okay. So, I think for most of this, I might have to use Wolfram Alpha. Here, we have, what is this? 2x divided by n. So we can just move 2x out. And this is just, not out there. I mean out here. Yeah. So this is like I think, I don't know. I think it's this. And this thing does not converge, so I don't know. This one is 1. I think this was meant to be 1, but maybe it's like meant to be 2 to the n? Yep. So I don't know about 1 o'clock. And then we have 1 plus I over n. So it's Oh, now I get it. Wait, I was stupid. This is not it's I and n. Those are different. Those are 2 different things. Okay. So this is actually this is actually just 2x. So this is gonna be 1. Okay. This one is gonna be... Is it... I think it's supposed to be... like this? And I think so this part is supposed to be 1. And this part is supposed to be... be like... maybe this. Like, you can absolutely bring in that outside. So I think that's a 1 plus a half? Maybe? Huh. I guess it's supposed to be 1 plus 1, and that's why it's 2. Okay. Because it goes from 0 to 1 and there's no x. This one is n divided by 3 to n. When n reaches infinity, we can just assume that we're doing... Okay. So we can bring n out here again. We can bring 6x out there again. So this is just going to be around this much. Times 6x. So that's going to be 4x. Right? Isn't it 4x? I think it might be 4x. Yeah, so it's like this, which is gonna be 2. Yeah, I think that's how it would work. Let's see. Yeah, it doesn't matter in the ceiling doesn't matter in the limit. Here we have, again, let's bring n squared out and 8x out as well. Then this becomes just I, which gives us this. This cancels out. So this is 4. Okay, this is 4. Here, let's bring n out, and then this is going to be sine pi I over 2n. Okay. We have this becomes nx plus sine pi I over 2n. That has to be like 0, right? Wait. 2n pi up to 2 pi. Wait. That's actually gonna be like 1. So that part is gonna be like 1, I think, because it has to be like it's something like this. It's something like this. Maybe not. I'm not actually sure. Can we actually try that in Wolfram? Maybe. N infinity. Sum n does that solve to something? Yeah, that's 2 over pi. That's what I was thinking. So it's like, I think it's like this. The answer is this, which is weird. This one is just, you can bring everything out. The n just cancels out. It's just, this? Yeah, I think it's this, which becomes this, which is 4. Okay, what is this one? Does that make sense? Let's see. That is 2/3. Okay. And then we have x. So we have this, which results in this. And I guess that's why it's 7 o'clock. Okay, here we have, again, we can bring 16x out. We can, that's I divided by n, right? We can bring all of that out. Times, that's gonna be sum of I squared. So this entire thing is gonna collapse into 1 over 3. So I think this time the answer is 16x times 1 over 3, which is going to be this. So this is 8 over 3. I guess we're only thinking about the numerator. Okay. This one, again, bring n out, bring x out. That's gonna be another n over pi or something, right? Sine I pi. Can we get that? Yeah, it's 2 over pi. So this is like this is 18 over pi. This is gonna be ln. What is that? Okay, that's 2 log 2 minus 1. So it's 20x times 2 log 2 minus 1. So it's 10 times, this is the answer. 10 o'clock, maybe. Here we have 1 minus... What's that? That's 1/3. So we have this, which is going to be 11 over 3, and that's why it's 11 o'clock. Okay. And finally we have that's just going to be, yeah, that's just going to be as it is. So what is cosine I pi divided by 2n? That is, yeah, that is also 2 over pi. So we have like 48 over pi x plus this thing. So it's going to be this. That's the answer for 12 o'clock? Maybe? I'm not sure how this clock works. Maybe I'm doing something wrong. But I think it could be they could be mistakes. But anyway, thank you, Really and Hasana, for this clock. Thank you for submitting. And let's move on to our POSKQ1 clock. We have 20 more to go. Okay. Let's see. They have a solution, right? Right. Let's... And then we have this. Copy that. Paste that. Rotate that. Bam. Okay. Is there sunrise in Korea yet? I'll look out the window. Not yet. Okay. Let's see how we solve this. Digital root of 26 is, what is that? 2 the Wait. Digital root of... Wait, 2026 02 of 2026 prime? I guess this is a 2026 prime, and that's the digital root of... Okay, that is the digital root of that. Yeah. Digital XOR of this? Oh my gosh. SHA-256, oh my gosh. Wow, you're supposed to do all of that? I mean, it's a relief that they've done it for me here. And it actually contains... So it says SHA-256 that when you put it... A SHA-256 of a 2026 starting string that also ends in 2026. That's amazing. Rounded log base... Huh. Okay. This, I think this is more readable, so I'll just look at these and then read this. Read these. Okay. Round around 3. Rounded log base. Okay. It's a log. Oh, it's also... That's the time at the... Yeah, okay. Okay, that's the time the contest ended. 4 o'clock. That's very easy. 5 o'clock, Fiv, 20, Fibonacci. Yep. 6, 7, 6, 5. Okay, that ends up in 5. 4, 6, we have, yep, a simple XOR. Number until 2027. I know what I'm saying. 2026. And what's this? Pixel? Okay, let's read from here. Number until 2026. Pixel 1 stabilizes in game of life. Ignoring glider. 20 minus 20. 26 minus 20. Black equals alive, white equals dead. So I think we're supposed to draw 2026, maybe? Or like write out binary 2026? Huh, but I don't think writing a binary in a 2x2 grid works well, so I think maybe we're just supposed to write down 2026 in game of life. Maybe. 279, wait, what is that? Number until pixel 1. Pixel 1, is that a thing? I'm not sure. So, like, I don't know exactly what I meant to do. Maybe actually just 2026? Pixel 1. Yeah, I don't know what that means. Maybe I'm just supposed to do this? It's supposed to be like... Supposed to be 279 somehow? Wait, but I don't think it's 279. Okay, I'm not sure what it is. Let's see, 8 o'clock. The 12 place pixel art. The 12 place pixel art. Oh, this one. Oh, right. Okay, let's look at that one then. Right. Okay. 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 Oops. Right. Okay. Let's go to 270 something. Uh-huh. And then 1, 2, 3. And then it's stabilized at 279. Right. Because after this, nothing happens. There's a glider down there, but nothing happens here. Right. That's awesome. And then we have base 7 stuff. Okay. And that goes to... that. So, what is that? That is 8. 49 factoratic. What is that? Factoratic. What is a factoratic? Maybe it's just a factorial? Factoratic. What is this? Factoratic. Huh. That's factoratic. Wow. Okay. Okay. Three, 4, 2. Uh-huh. Okay. That's amazing. I didn't know factoratic. Okay. Let's look at our 10 pi 3.14 15926. So the decimal number of pi, yep, that adds up to 10. Okay. Digital root of 2290th prime is 2020. Okay. It has 2026 in that. That's really nice. XOR each row on pixel 2026 with each other. So we're simply gonna count odd, even, odd, even, odd, even, odd, even, odd, even, odd, even. 0. Odd, even, odd, even, odd, even, odd, even, odd, even, odd, even. 0. Odd, even, odd, even, odd, even, odd, even, odd, even, odd. That's a 1. Odd, even, 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 odd. That's 1100, which is 12. Hey, that's actually a really nice construction. And the fact that it also works at Conway's Game of Life. Thank you for submitting this. Thank you. I will get some water and look at the next clock. Okay, I'm back. I'm eat a candy. For the next one, we were looking at Saumya Manu's blog. This one's also interesting. By the way, we are at all the way up to S. That's a great sign. I see hope. I see a future. I see myself sleeping. Okay. Question 3. The angles on the amber logo is 80, 90, 90 degrees, and the angle on the other logo is 180 degrees. Wait. That's 90, that's 90, that's 80. I know. What is 80? Angle on the other logo? 120? Yes, this is 80. I guess this has to be 60. I guess this has to be 160, which means this has to be 20. X is equal to ky, so k is 3. Okay, that's why this is 3. But let's move on. Oh, 20 hours, right. 20 hours. We're up to 20 hours. Nice, nice. Thank you, thank you. How am I feeling? Am I still sane? What is the odd even lore? It's just like what you do when you count the parity of stuff. So you count it with odd even, odd even. What is X here? This is 5. So this has to be 3, this has to be 4. So X has to be 1. Right? Makes sense. Three blue, 1 brown. 0, 1, 2, 3, 4, 5, 6. E and M. Oh, just this is this set. A set. Yeah, that's the intersection is 2. How many can be drawn without going over an edge more than once? So this has 2 odd. So this is possible. 1, 2, 3 more than. I mean, yeah, this is impossible. 3, 3, 2 odd, possible. 3, 3, 2 odd, possible. 1, 2, 3, 4, impossible. 1 and 1, yeah, that's 2, that's possible. So it's 4 are possible. And physics girl? I mean, maybe it's I to I. I'm not sure. 5 letters. Oh, phi. Phi. Huh. I'm not sure about that one. How many unique numbers does the hexadecimal contain? Ling Ling 40 hours. Length of Ling Ling? That's 8. But what is 8? Unique numbers does the hexadecimal form contain? Form? Is this a form? I don't know. Maybe it's just 16. And oh, 40 divide. There's a divide sign here. So 40 divided by 8 is 5. And I guess that solves the problem. And I don't know what this part is, unfortunately. Convert Ling Ling into hexadecimal, but this is not a hexadecimal string. Wait, translate it into hex? Is it like base 64 or base 40 maybe? Oh, the ASCII to hex. Okay.
4C, 4-9, 4E. G is going to be another 4-7. That's 4 C9 E7, 5 unique numbers. Right. Nice. Right, there were 2 ways. By the way, okay, so Miyamanu, do you can I ask you how to solve this one? I mean this one? Maybe? But wait, maybe this is just not part of... I guess it's phi? Maybe? It's just phi. Cantor function of 8 divided by 9. Oh, that's just a reference. Oh, okay, okay. Cantor function of what? Nah, come for fun. Is it exactly 3/4 at that? Maybe. Maybe. Oh, yeah, it is. Multiply the simplified fractions numerator by 2. That is 6. That's a nice reference. There are some amazing references here. This is 2 plus that, so this cancels out, and this becomes 7. What's the difference between both? See... equations, highest roots. Right, right. Highest roots. So let's solve it. Plus 30 equals 0. That's 3 or 8. Can you submit a fixed version of mine? You can, but I may not be looking at it today. That's a 5 or negative 16. Both equations' highest roots. Maybe it's 8 and 5? So it's 3? An octahedron. 9 planes of symmetry. Right. Oh, great depiction of a ring, actually. It's 16 and 8. Oh. It's 16 and 8. Okay. Oops. So that's 8. Frequency. Calculate the sample standard deviation. Right. This is 25. So we have n minus 1, which is, this is going to be 10. And this is going to be, they are all 10 apart, so it's going to be 100. It's always going to be 100. So 100 times 10. Divided by 10, 100, root, then you get 10. Nice. X is half of the large hexagon's side length. Find the small hexagon's area to the nearest centimeters. So half
means this has to be 2.1. This has to be 1.05. And the area of a hexagon would be 6 times. We have 1.05 squared. And then the area of the little triangle. 3 square root 3 over 4. Wait, is it not 3 square? Wait. Uh-huh. Wait. This is x is actually 4.2. Actually. Wait. Actually. 2.1. Right. I did mistake. That is 11. Okay. I made a mistake. It is 11. EI pi plus 1 is 0. And that's an amazing clock. 2026. Thank you. Milk Straw Meta. Thank you. Soumya Manu. I absolutely love the aesthetic. That's a clock solved. Let's go to Sputnik. This is also an interesting one. Okay. This is an amazing aesthetic. So, what do we have here? Let's start from this one. So we have 0 or 12, right? The caret here, I don't really know what it stands for. What is the area of this star? It is S6 root 3. Okay. So we have, this is A. This is A divided by 3. So I think what we have is 12 smaller triangles. 1, 2, 3. Yep. 1, 2, 3, 4, 5, 6, 7, 8, 9. We need a 4 root 3 over 4a squared times this, which results in 2 6 root 3 times root 3 3. Right? Yep, I think that's right. So it's, I think 1/9? Maybe? 1/9? This one is also like, yeah. This one divides the entire thing into 1, 2, 3, 4, 5, 6, and 7 parts. Okay. By the way, actually, I do need a limit on when to stop this stream. I do need to end it before 24 hours, which is kind of sad because, like, then I have to pick a new day to do all of the hard clocks, which is Gonna be... Yeah. I think... I don't know how many more I can do because I don't know the difficulty of the clocks. So... join the Tom Rocks Maths essay. Googleology is a great topic, I think. 2206. Wait. Okay. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Huh. Hello? I'm not sure what this one is. Bam, 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 bam. This is 1/4 made with 2026. 1/4. So, oh. Maybe. Oh yeah. I now get what this is. If this big hexagon is 1, then this small hexagon is 1/7, but then we do the same thing to the small hexagon and then remove that, and then add a new thing, and then remove that, and so on. So this is a alternating, like, yeah, infinite series, and then it sums to 1/8, I think, because it's like this. Wait, is it? Wait, I'm actually not sure. Maybe we're supposed to just add all the parts, actually. Actually, maybe it's like, oh. Maybe it's like this? Yeah, that makes sense. That is it. That's why it is. Okay. 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 C times 20 times VI minus II. 6 minus 2 is 4. 8, but there's a divisor at the top, and I don't know what that means. 80. So maybe we do this first, but I don't think. So this is 80 times 100, maybe? Each line is times 1,000. Each line is times so this is a 6 million, you're saying? So this is like 24 million? Wow. Okay, 24 million times C? Right. And then another 2 more zeros. In that case, I do not know what that means. Find B, R1, R2 for polynomial values. X is 2 and 6, Y is 0 and 2. B as in binomial, maybe? Oh, wait, is that something I don't know about? Huh. Yeah. The thing is I have to end it after 24 hours. And I'm sorry to everyone who is, maybe? Like, I think it's better to do the ones of people who are here right now, because then like if there are people like if some of these people are not watching right now, then it might be better for them if my rescheduled stream is better for them. Like in that case, it's gonna be a win-win situation. So I think maybe I will have to do people who are in the stream right now. But like if there are many people, I have to end it before 24 hours. So like it has to end at some points. Yeah, okay. The thing is, yeah, there has to be like a day 5 or something where I actually go through the things in a clearer mind. Maybe like I'm not getting these puzzles because I am not clear-minded right now, maybe. Like, what is this? Is this a root? Is this a sigma? I don't know right now. Yeah. Okay. I will end it at 24 hours. Yeah. I will try finishing this clock, but like I doubt I can finish this clock right now because there are too many things that I don't know about. But this is really pretty, so I really want to look deep into this. Maybe I'm gonna, like, if I don't know, I'll skip today and I'll come back like tomorrow or when I do the stream again. Then I'll be more prepared. So this part we're supposed to put something through here and through here. How though? This is 2 root 2. If this is a like right triangle isosceles triangle, then the area of this is gonna be 4. Right? 6 plus 4, 2. If this is a combination, then this is gonna be 45. Something times something times and what is this? I think this is an AND gate. Maybe this dot is for the knots. So 6 and 2 and 2. And that we get 2. NAND that we maybe get this. We OR that and then do reverse it. So we get 0, 0, 0 here. 0, 1, 0, 1 and 0, 1, 0. We get 1, 1, 1 here. 1, 0, 1 and this one we have and then reverse. So we have this. And this we OR that and reverse. So we get 0, 1, 0, which is 2. I think so. I'm not sure. Because this was 1/4, this was 1/8, so this was 1/9, so I'm thinking like what are we supposed to get here actually? And I do not know what this means like at all for polynomial values. I wish I knew. This is a Braille. Let's look at some Braille. Braille numbers, maybe. No. Wait. What is this actually? Well. Actually, is this a... Maybe we need to reverse it. No. What is it? Like... Extended rail? Maybe Wikipedia has something to say. Wait, TH? That... No, there's TH and then BB, and that immediately doesn't make sense. BB. Any numerals? It's semicolon. Semicolon. I'm not sure actually. So many things I don't know. What is this actually? Is this a sigma and a gamma I'm seeing right here? It's not a square root? What? Tau? Wait. And that, like, I don't know what it is at all. I wish I knew. I equals 0 to 10. 2i. That's just gonna be 1. Number of ones in this, which is 8. So it's 8 mod 2, but 8 mod 2 is 0. Oh, right. I was like this. I was looking at it the wrong order. This, yeah, that is the addition of all the numbers. So this is 8, I think. Yeah. Huh. Oh, it was 2026? Right. The timer just went from 2026. This is the Singapore flag. Flag of Singapore. How much is this? This is 27. Wait, up until where? Like half of the flag, maybe? We have a construction sheet that says... Oops. Okay, if this is 27, then this is 9. Because it's 1 to 3. Okay. So we're kind of getting numbers here. And here. I feel like this should be 7. And I did it wrong. Okay. 26. What? Okay, I have no idea what this is. Oh, it's carbon. Oh, if you add carbon, what is this? 3 of a beta. That's just an electron, right? Maybe. Wait, what's a beta particle? What's a beta particle? It's VE. I need to read this in. 1 neutron turns into 1 proton. Okay. 1 neutron turns into 1 proton. So we have this, right? 7n. C. K. That's... this is hard. Right, at least this I can calculate, right? 7. x7 dx. That's 7 over 8, I think. Oh, that makes sense because it's a 7... Yeah, 1/8, 1/4. Like, this has to be 3/8 somehow. This has to be 1/2. This has to be 5/8. This has to be 3/4. And yeah. Oh, and now I get what this means. It's 0 or 1. 0 or 2 to the 0. 1. So that's what this was about. Okay, I'm getting what it means. HC mod 2 mod 13. All this is 13. But yeah, I don't know what this is. Okay. Thank you, Sputnik, for this amazing design of a clock. I will look at it again if I have time. Yeah. There are many things that I've missed, I think. So let's see. Do we have Zmek SZYMEK in chat? I know there was Trizubni TRYZ in chat right now. I want to do people who are in chat, and then I have to end the stream in 24 hours. So yeah. Okay, let's do Triz TRYZ first. Okay. So we're gonna be doing TRYZ down there. Let's see. Bam. Hi, Dr. Zai. I stumbled upon the math clock vid a while ago and felt like doing the clock right away. Although I kind of forgot about it very quickly. Reshid discovered a few days ago. Okay, let's see. We have... That's a big hint. Church numeral of 1. Oh, okay, let's reset the board. Church numeral of 1. Yep, that is 1. And you can look at plus times plus by TwoSoft for that. Hex code. Okay, let's return to this. Open image in new tab. Do that. Get the color. More tools. Eyedropper. This is a FFF001. So this is like log that of that. Yep, that's the that's the square of this. Right. Actually. FFF, this is FFF001, and yeah, this is the square of this. Right, that's amazing. That's amazing. That's an amazing puzzle. This one, I know this is by Ramanujan. I would never calculate this. It's 1 over pi, and pi floor is 3. 2 tetrated infinite times to 2 is still 4. Still fits in the 4 hole. XOR each letter of the word XOR in binary, and look which place the letter you get is in the alphabet. So XOR, let's bring up, not Conway's Game of Life, let's bring up the ASCII table again. So X, X O R O. Okay. R. Let's do XOR. So this is odd, this is even, odd, even, 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 odd. Which place of the letter you get in binary is in the alphabet. This is 1 plus 4. Maybe? Yeah, we don't think about this part, I think. Oh yeah, I was not supposed to look at ASCII code, but it happens to be the same if we just remove that first one. So this is the, like, because X is the 24th position in the alphabet, this is 24. Anyway, this is the 5th position in the alphabet, that is E, but we're looking at 5. Right? 5. Sum everything to 3, 1 plus 2 plus 3 is 6. 5th decimal place of, oh my gosh. I don't know how you would calculate this actually. Does it just do it for you? Just calculate? Okay. Maybe we do that. Okay. What's the lemniscates? Wolfram Alpha. Please, lemniscate constant. No. Physical. Unfortunately, Wolfram Alpha is not fit for it. 5th decimal place. Let's just. Why am I in Korean? Why am I in Korean? Lemniscate constant. I mean, if I put this in, it's not gonna be exact, so it's gonna break. But, I mean, we have to try. No, it doesn't work. Okay. Hard. Toshin function applied 7 times to 2026. Does that work? You think you might have rounded as well? It's hard to, like, yeah, I wish I could calculate it. Once you get 1012, twice you get 440, 3 times you get 160, 4 times you get 64, 5 times you get 32, 6 times you get 16, and 7 times you divide by 2 again, that's 8. Divide the hypervolume of a pentachoron. So a pentachoron is like a 5D, I mean 4D shape. It's a 5, what's it called? 5 cell. And I learned the volume of this yesterday, which is side lengths of 12, so that's 12 to the 5 times It was root 5 over 96. And divide it with 24 and then divide it with the square root of 5. So square root of 5 gets demolished. We divide it by 24. Bam. That's 108. Wait, maybe I missed... Oh, it wasn't... It's not to the 5, it's to the 4. Right? Why did I write 5? So that is 9. Oh, the first 20 are... I have a puzzle that's not a clock. Can I put in chat for you? I'm sorry, I cannot solve anything in chat right now. This is... this is a Google. So this is 100 divided by 10, and that's going to be 10. And this is AI, but you've said that it's a Cyrillic numeral. What's a Cyrillic numeral? A is 1 and I is 10. So I would think I is 1 and A is 10, but actually A is 1. It's the first letter and I is 10. So that added together is 11. And mu, Möbius of 12, is 0. Because this is 2 to the 2 times 3, and if there's a square, then this is always a 0. Right. And that solves the clock. Thank you for submitting. Yep, it's 12 and 0. Yep, thank you, thank you. Okay. Let's see. Like... So we change the ordering yet again, and that's a clock complete. Man, I really hope to finish everything by 24 hours, but it's just impossible. What should I do now? Yep, go to sleep. Thank you for being here. Do I script the whole flag series? I mean almost the first one and almost all of the second one. Yeah, I scripted it. Bam. Anyone else in the chat with a clock yet to do? That's a great question. Yeah, I just wanted to ask that. I also need to go to the toilet real quick. 안녕하세요. Hello. Drawing the community channel. I will check it later. Let's look at. It says SZ Mon Creeper SZ. Yeah, this one is also a hard one, so I do want to finish it. It's a pixel art one. Let's see. Okay, Zai merch. I mean, if I have the time. So let's look at that first. What is also, do they have? They also have a backside of the clock that's actually really cute. Made in Poland. Made for Dr. Zai. Thank you. Unfortunately. What is this clock's radius in millimeters? Okay. Let's first start by doing this, which is integral of 2 to the 26 over 2 is just 13 x dx. 82.5, so this is 83. This is x from 26 to 83. X cubed. Minus something divided by 8 plus 56 times 36. That has to equal 6 somehow. No. Wait, what is tau? Wait. Oh! That's why it was weird. But that's also weird. Okay. Huh. I'm not sure. What's the thing below? Where's that? What? Where's that? Oh, it's not multiplied at the end. It's plus. Okay. Okay. Huh. I'm not sure how this works because it's not an... Whoa, it's not a natural number. Okay, let's try this one first. What? Either that or... Okay. I have no idea what it's meant to be. Wait, maybe... Yeah, maybe it was a mistake, like, doing this when I am not thinking straight, maybe. Huh, what is it about? Unfortunately, they are not in the stream anymore. I think it would be better if I skip this and if I could ask them about it, because I get that the concept is like it's about really big numbers, but I don't know how they calculate to 1 to 12 or something corresponding to that. There are also like a lot of things here. It's all this is 16, this is 16, 128. Weird. Oh, what? Like this is, these are really big numbers all around the clock. Okay. Okay. I guess I'll have to skip that for now. Like this. Yeah. Just, I'll return to SCYMEK CMEX clock later. Right, anything else I can finish fast? Oh, this one was not finished in time, so it's a concept. Let's see. So this one is very simple. It's x squared, I guess x squared divided by 12 equals what is, I mean, this is, I guess there's 12 in it. And, what is this? Maybe we're just adding it, like, yeah, we added 3, we get 1 here, plus 8 plus 4, we got another 3 here, another 1 there, that says 10, maybe we get a 4, and then maybe x is equal to 1, and that's what we're trying to do. 12? 3 minus 2. Yeah, oh, I get it. 12 minus 9 equals 3. We make this 7. 7 minus 7 is 0. 2 minus 7. We do another 12 minus 7 equals 5. And this becomes 2 instead of 3. And that's why x is 2. This is multiplication. 2 times 7 is 14. I believe this part will be this times 7. This part will be this times 8. So it's gonna be, this is gonna be like 8 times 2, 16. 8 times 4, 32. So just with that alone, we know that x is 3. And this is like, okay, what's the thing we are left with if we divide 1947 by 113? I can just do mod, maybe, and the result is 26? Actually, no. Dot. Wait. 1? Something. Wait, dot? Unfortunate. That's my wake up alarm in 8 a.m. It might be like weird. Let's just go to Desmos. 704? No. 591. Huh. This is never 4. So I'm kind of confused. Okay. Huh. Oh, this is calculating square roots. I see. I see. And it's all okay. I get the concept of the clock. So I guess this was unfinished. They also told me this is unfinished. Right here. Yep. They were also going to represent the year in different calendar system for each digit. But unfortunately, it wasn't finished. Yeah. Unfortunately. But, like, nice idea. I don't think anyone else had this idea. So, nice idea there. Thank you for submitting. And that's a solve. Submitted through email. Oh, was it submitted just now? Okay, but I don't know if I can look at it right now. Let's see. Could you wait? What is your email name? Hugo. Oh. Right. Yeah. Was one of the late submissions, right? Right. I don't think I can look into it right now because I believe it's going to take a lot of time. And I was going to look at the late submissions altogether in some other time. Yeah, sorry for not being able to do it right now. Oh, we have some fun stuff that we can do in under 10 minutes, I believe. So these are cryptic crosswords. So it's like this. Eno looking back is 1. And then his set 1 is a set containing only the void, which is 0. Like this. So 1 is defined in 2 ways in this one sentence. This means that the answer is 3 letters. Obviously, it's 1. Next up, we have 1 with I reproduces with conjugate. So 1 with I should be I reproduces with 1 with I reproduces with conjugate. So that should be 1 plus I times 1 minus I, which is 2, resulting in a Gaussian ramification. Actually, Gaussian... I don't know what's Gaussian with 2. Maybe. Yeah. Abstract theorem with no modus operandi is primary among 52 we know. So this part is like abstract theorem means anagram this word. With no modus operandi stands for M and O. So with no modus operandi means we need to delete the M and O, and then we abstract reposition these characters and we get 3. Also, it says primary among 52 we know. Actually, I don't know what that stands for. Maybe it's a group theory thing, actually. Maybe. Among 52 we know. Primary. Maybe 52. Okay. Audible 4-2. So audible 4 is what you hear by saying the word 4, and that is 4. 2 or 6 exclusively is the 2x or 6 thing. X or 6 thing, and that is 4. V is just 5, right? Odd number in first generation of Happy Family. Oh. That's the Happy Family is the thing that numberbasher just wait. Did I learn about the Happy Family during the numberbasher session or during the ModularDiscriminant session? I think, yeah. So 5 is an odd number in the first generation of Happy Family, really? That's the 20 among 26 sporadic groups? I guess. Rome describes symmetric group on 9 elements, finding smallest order among non-abelians. That's also something that ModularDiscriminant told me. It's just 6, I think. And Rome describes symmetric. Rome describes. Why is that 6, actually? Maybe it's like 6. I'm not sure. Actually, I'm not that good at cryptic crosswords. Poles sit around woman in lines on Fano's plane. Iran is now constructible in Google. Really? I didn't know. I actually didn't know. Poles sit around woman. What? Poles sit around woman in lines on Fano's plane. That should be just the 8 curve, I think. Poles sit around woman. Oh, this is 7? Wait. Yeah, that's true. Poles sit around women. Woman. Eve, I guess. Woman. S and N pole, right, in the magnet. So S and N around 7. In lines on Fano's plane. What is Fano's plane? One, 2, 3, 4, 5, 6, 7. 7 points and 7 lines. Right? 8 loudly. That's say 8 aloud. So it's 8. In Mr. Clifford's algebra period. 4 reals. Mr. Clifford's algebra period. What is that? Mr. Clifford algebra. Clifford algebra. Wow. Wait, in that case, I don't know anything about that. I wouldn't know what a Clifford algebra period is. For reals. For the real numbers. I guess that's an algebra thing. Non-invertible. Non-existent. Roots of cast out number. Non-invertible. Non-existent. I see some 9s here. Cast out number. Maybe take out the 5v. Roots of cast out number. Okay, that's hard. Half of baby animal in Schrodinger's box. Maybe it's both 1 and 0. Cat. Kitten. Half of kitten is 10. Maybe it's both 1 and 0. 10 has both 1 and 0. That's true. Amazing, amazing. 1/3 of 12. Minus, not odd, even. Oh, that's not minus. It's just 1/3 of 12. Maybe it's like in the middle, 2 characters, and then add even. So that's 11. Not odd, but a prime, that's not 2. I guess that's also pun on how it ends with even? Maybe. This one, 20 divided by 2 plus 55 plus E. I think this one is actually 12, like spelled out. I think it's not numeric. I think it's supposed to be 20, right? 20, but divided by 2, so you only take the first half. And then 55 is LV in Roman numerals, and then E is just E. So that gives us 12 here. And then is minus 1 over a natural sum according to Ramanujan. That's the famous Ramanujan stuff. 1 plus 2 plus everything. Yep. That almost solves the clock. I don't know what this is. I think V is just V. I don't know about algebra enough to know that. Non-invertible. That's weird because I think it's supposed to be 9 in there maybe. Yeah. Oh, roots of. Okay, that means this is. Oh, right. Thank you. Thank you. Roots of means get only the initials. Roots. Okay. Amazing. Amazing. Wait. Q quiz. Did you upload something new? I'm sorry. I cannot look at that one right now. But this one, I think it's done. Bam. That's a bummer, dude. Also has a cryptic crossword clue. Yeah. Let's look at this one. How long have I been live? I've been live for 11 hours, 30 minutes, but that's like, add that to the 12 hours before that. So I've been live for 23 hours, 30 minutes. I'm probably at most I can probably do like 2 more. And then unfortunately I have to end it at 24 hours. I'm like, it's breaking a lot of promises, but I'm sorry I didn't. I wanted it to end before 24 hours. Like, there's only 10 more to go, but I don't think I am in a mental state to do them. So, maybe if I can get some help from, like, my friends or, like, from ModularDiscriminant, then maybe I'll be able to do up till here. Maybe. Okay, let's get back to this cryptic crossword. 20 halved again. I think that's just this part. TWE. 15 to, wait, that's actually the same thing. 12 negatives 8. Yeah. So negatives 8 may be referring to the first letter of 8, so that's 12 in one. That's one way you get 12, but then the other way is just you actually do the calculations. You do 20 half is 10, 50 into 5, maybe that's 50 divided by 5, 10. Negative 8, 10, 10, negative 8, that is 12. Actually, that's amazing. For bases of log, it's undefined with any call. Yep, log 1 of anything is just always undefined, so this 1. Bases of log. It's undefined with any call. Okay, how does this make sense? Why can't I do this? Little hint. Solutions and explanations. Right. Delete first and last. Oh, 4 bases is like, okay. Delete and first and last letters. Any. Oh, any stands for any. Oh, right. Right, that makes sense. That makes sense. 20 divided by 26 on paper. Double, you say, then round. So if you do the calculation, it's like about 1, double then, and round them, and then you get 2. But what about the cryptic part? You say, double you say. Okay, round is, oh, on paper. 2026 on paper. On paper? What? On paper. I actually don't know what that means. Oh, 20th letter of the alphabet. Oh, 20 out of 20. Wow, that's actually so clever. Wow. Wow, this is actually so clever. Amazing, amazing. Triangular prime before turning 4. So that is always 3. Mersenne prime at their lowest is also 3. Triangular prime is T. Triangular is T maybe. Before. So we put T before. Turning 4, we get H. That's amazing. Turning 4, that's amazing. And then or Mersenne prime at their lowest is maybe the last letters of those 3 words. So it's THRE that way. Okay, okay. East to west of minimum for unadjacent colorways, essentially. What? East to west of minimum for unadjacent colorways, essentially. Okay. Unadjacent colorways. I guess it's a 4-color theorem? Yep, that is the 4-color theorem. And then east to west is backwards. Oh my gosh. East to west. So that's FO. Minimum for unadjacent. The first one of unadjacent. Okay. Colorways essentially leaves the middle. Right, that's amazing. 4. Okay. Okay, root of 4. 2 plus 3 in a roundabout way. That's already 5. Root of 4. Okay, so again, root of means first. Wait, this is amazing. If you turn this, if you roundabout this, you get IVE. That's 5. Oh my gosh. Amazing. Ultimately, to antithesis. Okay, so how this works, cryptic cryptically is ultimately antithesis is an ending letter. To second root is going to be the second letter. And then 10 is X in Roman numerals, so that gives us 6. And then second root of 16 is just antithesis to second root of 16 is going to be minus root 16, which is minus 4, plus 10 is 6. Amazing. Puzzled, triple 10 plus 5, lastly, and divided by 5. That's triple 10, 30 plus 5, 35 divided by 5 is 7. Puzzled means scramble, and lastly means the last characters E-N-S-E, and that we like put it maybe like this, and divide it in the middle by Roman V. That's how you get 7. Embodied by the rotated unlimited sign. Okay, it's the infinite symbol rotated 90 degrees, and that's the 8. But also, embodied by. Embodied by. Embodied by. Embodied by. Oh, you Pixel, you cannot submit clocks anymore. Sorry. Where is it? Embodied by is reverse? What? Embodied by... No, maybe it's the rotated. The rotated. Yep. Okay. Embodied by means contains something. The rotated is EHT. And EHT embodies unlimited. So, oh, unlimited is also so clever. No ends. Okay, no limits, no ends of sign. So it's 8 like that. Okay. Normal vector question mark. Obtain angle finally and divide by 10 minus 0. What? Oh, normal vector's angle has to be 90 degrees. Divide by 10 is that, so that's 9. But then also, obtain angle, finally, N and E. Divide by 10 minus 0. Normal vector. What? Normal vector, what? Normal vector question mark. What is that? Divide by. It has to be in or something, right? Oh. What is it? What is it? Oh, it's just N for normal vector. Oh, I forgot that's a symbol. Okay. It's N and an E divided by, that's gonna be just 1 in this case, like I, right? Fourth of triangular integers, but add first to come out newly binate. That's fourth of triangular integers is 10, but add first to come out newly binate. What does binate even mean? Double, growing in pairs or couples, grow in 2 parts. At first to come out newly binate? What? Triangular integers, fourth of... No. But that's A and E. But at first, to come out... Okay, I have to look at the answer for that. Anagram? Newly binate is an anagram. Newly... Wait. Wait, minus A minus IB. Triangular. Okay, fourth of triangular is A. I got that. IB first. Oh, Oh my god, that's like that. Oh my gosh, IB at first. Wow, AIB to come out of newly binate. You delete AI and wait, but like it makes so much sense when you explain it. Like when you explain it, I get mad that I didn't get it. Solved 12 plus 1 minus 2. That solves to 11. This is also an this is this is actually an anagram. Like you add up these letters, remove T, O, T, W, and O, and the rest becomes 11 if you solve them. As in rearrange them. And that solves the clock. That's actually amazing. That's amazing. That's amazing. Thank you for that one. That was amazing. I think that has to be the last clock of this 12-hour stream because it's 11 hours and 43 minutes right now. So, unfortunately, I could not finish the thing in a day. I will have to prepare again and come at a later date. And it's a bummer because I had to end it. I had to end it today. I had to do this 24-hour stream because I don't have much time starting from today. Like, I don't have that much time to stream the clocks. Thankfully, there are only like 10 more clocks, but they are really hard, so it's still gonna take a lot of time. But yeah. Anyway, it's been 21 hours, 21 minutes. Just as a final, I'm not in the toilet. Meister, yeah, I don't know if I have to make a full day break like today, and I have things to do. I need to study for the math thing and the band thing, so yeah, I have to do that all day long today and tomorrow and the day after tomorrow, so like it's gonna be a really busy week. I need to think about it again and write the community post again. But as an apology and a thank you for everyone who's been here today, I will play a simple piano song. Just I don't even have a camera right now set up. So just please listen. Thank you. I will be taking a sleep. I will maybe upload a community post later. On what I'm gonna do for the rescheduling. Thank you, everyone. Thank you. Thank you. Thank you. By the way, oh, did I miss a really old donation by Smom? Like this, I think it has been hours since Smom Sun DSO donated. Like, thank you for the donation. Your perseverance and commitment's amazing and inspiring. How many clocks are left? Greetings from Germany. Like, I'm sorry, I wasn't paying attention to the donation at all. Yeah, thank you so much. Yep. Greetings from Korea. How many clocks are left? Now, around 10. Thank you so much. Yep, goodbye.